May I please request and a Good morning, ladies and I'm Shruti Mishra, and we have all gathered here at Bharat Mandapam, the heart of India's capital, to witness a shift. A shift from hand to precision, from distance to connection, from possibility to reality. Because today we stand at the dawn of a new era, an era where surgery is no longer bound by geographies, and where technology doesn't replace human touch, it amplifies it. And yet, this era didn't arrive by accident. It was built, designed, tested, and proven here in India. 10,000 robotic surgeries, 150 telesurgeries performed across continents, across distances, across what was once thought impossible. All powered by one platform, made in India, trusted by the world. This is not a conference, this is a declaration. A declaration that India does not just consume the future of healthcare, India creates it. Over the next 3 days, you will witness surgeries, live telecast. You will see a surgeon operate from hundreds of kilometers away. You will experience innovations launching today that will redefine what medicine can do in the operating room, on the battlefield, and in the most remote corners of our world. What you're about to witness is not the future of robotic surgery. It is the present, built in India for the world. Welcome to SMRSC 2026, the third global SSi Multi-Speciality Robotic Surgery Conference. A new era of surgery dawns today. And now to formally welcome us into this extraordinary gathering, it is my privilege to invite a leader who has helped shape the strategic and technological direction of this moment. Driven by an unshakable belief that technology must serve humanity, this man turned a bold idea into a global movement. A medical professional who in 2008 stepped into robotic surgery, built the world's first high-definition robotic cardiac surgery teaching website, led the development of Omni 3D medical visualization system, and today serves as the CEO APAC of SS Innovations. Please welcome Dr. Sudhir Srivastava.
Good morning. I'm Dr. Sudhir Srivastava, CEO for Asia Pacific, and on behalf of SS Innovations International, I would like to take this opportunity to welcome all national and international delegates, faculty, guests of honor, and all members of the audience to the third annual Global SS Innovations Multi-Specialty Robotic Surgery Conference, SMRSC 2026. Today marks a great day of pride for our team at SS Innovations, where we have now achieved the global platform, an opportunity to showcase the result of years of dedication, hard work, persistence, and sacrifice in order to make gold standard surgical care a reality for all, not only in India, but around the world. I would like to thank all the doctors throughout the nation and now the world who have not only supported us with their encouragement and enthusiasm, but also with their surgical skill and feedback, helping us to further refine our technologies and contributing to where we are today, having now done over 10,000 cases throughout the world across the entire spectrum of robotic surgery. We at SSi strive to remain a science-first company, led by surgeons, for surgeons, and most importantly, for patients. Through the family of our Mantra users, patients have been able to receive gold standard care at an affordable cost. There are around 430 surgical robotic systems today in the country, after more than 24 years since the first case was done by Dr. Sudhir Srivastava back in 2002. In less than 3 years, we've been able to account for nearly 50% of all surgical robotic systems in India. So how did this happen? We are a company led by surgeons. We have an open mind to constructive criticism and feedback. But most importantly, we have a heartfelt desire and driving force to effectuate positive change, not only in India, but globally. I would be remiss if I didn't also offer our heartfelt thanks and appreciation to our chairman, founder, and my father, Dr. Sudhir Srivastava. Without his vision of finding a path to democratize access to gold standard healthcare, I would not be standing here today. His vision pioneered a revolution. His mission offered a solution. As physicians, we have been given the task to solve problems. And through the efforts of SS Innovations, today, we now have one less problem to solve. We have a very exciting program over the course of the next 3 days. There will be presentations given from renowned national and international faculty, live surgeries, telesurgeries, and groundbreaking demonstrations. There will be an unveiling of our newest technologies that I am certain will excite you all. I would like to thank each and every one of you for coming here to engage, discuss, learn, and contribute to the ongoing discussion of how we can collectively deliver the best healthcare to all walks of life, regardless of their socioeconomic status. To recognize and remind ourselves that gold standard healthcare most certainly is a right for all and not just the privileged few. On behalf of SS Innovations International, I warmly welcome you all to SMRSC 2026, and I wish you all a wonderful experience while here. Thank you. Jai Hind, Jai Bharat.
Thank you, Dr. Vishwa, for a great welcome. Before we begin the plenary session, let us take a moment to reflect on the journey, the vision, and the momentum that brought us here. Since its inception, SS Innovations has grown from a bold Indian vision into a globally trusted robotic surgery movement, driven by the belief that advanced surgical care must become more precise, more accessible, and more affordable. Today, SS Innovations International stands as a powerful example of Indian innovation shaping the future of global healthcare. Ladies and gentlemen, please turn your attention to the screen for the SSi movie.
History has always been shaped by those who dared to dream what others could not. A dream is only as powerful as the will to make it real. Today, that dream is transforming lives across the world. What began as a bold idea is now a living, evolving reality. Across hospitals, across cities, across continents. A new era of surgery is already in motion. And this journey of SS Innovations is only gaining speed.
We are very, very happy that today more than 10,000 patients have been helped with our technology. More than 200 systems are now in place. And we are very advanced in providing tele-operations, telesurgery, teleproctoring, and continue to evolve in the world of science and technology to help humanity.
I think not only in India, but also globally. So we've, since launching our product commercially, we were approached by many other countries, Nepal, Sri Lanka, Philippines, Indonesia, extending all the way to South America. We've since launched in Colombia, Iraq, many other countries, and then Africa, and of course, the US and Europe are next on our horizons.
Today we stand at a defining moment in medical history, where technology is no longer assisting surgery. It is reshaping how surgery is delivered, not in one place, but everywhere. Because the focus has never changed, the patient.
The only reason patient comes to the doctors is to get better, so they can return back to their functional lifestyle.
The patient goes home early, he has less pain, less blood loss, and his recovery is faster. So this advantage of robotic surgery can be offered to many other patients, which was not possible before.
If we can reduce the cost to the patient, there are two ways to do it. One is to make the robotic system more economical, and the other one is to make the healthcare as such more economical.
With robotic surgery एक अच्छे रीजनेबल कॉस्ट में जब हमें मिलती है तो हम न केवल पेशेंट को सर्व करवाते हैं, बट अब ये जो डिफ्रेंसिएशन है कि बड़े शहरों में ही ये इलाज हो सकता है, छोटे में नहीं हो सकता है, ये अब ख़त्म है।
2 तारीख को जैसे ही मेरी वाइफ ने मेरे को किडनी दी, मेरा ट्रांसप्लांट बहुत अच्छा रहा, सक्सेसफुल रहा। उसके बाद 2 तारीख के बाद 3 तारीख को आईसीयू में ही डॉक्टरों की टीम आई, उन्होंने मेरे को 3 तारीख को ही चला दिया था खड़ा करके।
रोबोटिक सर्जरी करने के बाद अभी मुझे बहुत अच्छा फीलिंग हो रहा है, बढ़िया रिकवरी भी है और आज मैं चल सकता हूँ, फिर सकता हूँ, अपने परिवार के साथ बैठ सकता हूँ।
मेरी रिकवरी बहुत अच्छी हुई है, बहुत फास्ट हुई है और बहुत जल्दी हुई है।
मैं किसी और को सर्जरी करनी है और अगर मुझे पूछेंगे वो तो मैं रोबोटिक सर्जरी उनको सजेस्ट करूँगा, वही करनी चाहिए।
So surgeon skills, knowledge, added technology will give the benefit to the patient.
And it is already happening that people who are living in villages deep inside rural area in India, they have come to know about robotic surgery now.
Truly, all patients get access to minimal access technology and changes the dynamic and the healthcare, which is the right of every patient.
Yeah, so at the end of the day, ultimately, the patient and patient safety is paramount.
What started as a system is now becoming a connected ecosystem, where surgical intelligence is no longer confined to a single operating room.
By this telesurgery, we can easily operate there any kind of surgery in Tier 2 or Tier 3 city. I think this is the main game changer in any field.
Of course, we're the only company in India or platform in India that's being utilized for telesurgery. So since we officially announced telesurgery, we've been doing now successfully more than 150 telesurgeries of all types, including cardiac surgery, which is very complex.
And this is very important because in a big country such as India, majority of the population live in Tier 2 and Tier 3 cities. And if patients there can access this kind of technology, that really truly democratizes surgery.
SSi has penetrated across India, and I believe in next 3 years, maybe every taluk district places we will have a telesurgery chair and SSi Mantra robot. So pan-India robotic becomes a household surgery accessible to all, rich, poor, first tier, second tier, village, non-village, and metro, non-metro, to all the people.
It is already happening. 24 complex telesurgeries completed within just 12 hours. A demonstration not just of possibility, but of scale, of precision, of trust.
We recently did this telethon. We got the global or world record, for it, where 24 telesurgeries were conducted successfully in 12 hours. 9 surgeons had come on site here to our SSi headquarters here in Gurgaon. What that means is that 9 experts could now extend their expertise to 24 patients located throughout the entire country.
And we have now done many telesurgeries across the continent. In fact, the longest distance was 10,000 kilometers. So we were able to do cardiac case from France into Indore.
For the first time, distance was no longer a limitation. And with MantrAsana, a telesurgeon console designed for a connected world, a new way of surgery is born. With immersive 3D visualization, intuitive control, and seamless connectivity, it is a command center for a borderless surgical future.
The surgeon who is doing a telesurgery, he does not need the rest part of the robot. He just needs the chair console. Only with that chair itself, you can help do telesurgery at any part of the world.
Now imagine this chair could be placed in your outpatients or in an office, and you could get the best expertise that there is available in your institution and democratize that to anywhere in the world.
The idea with MantrAsana is that an expert surgeon can be sitting in their office. They can stagger their cases. So one room will start at 10 a.m., the next one at 12 p.m., the next one at 2 p.m. So stagger the cases, and then you can just go from operating theater to operating theater, remotely.
I was not very convinced when I was explained about the idea. But when I sat and did my first surgery, which was supposedly the first robotic weight loss surgery on MantrAsana, I could feel it is better than the routine console.
Technology like MantrAsana is based on the advanced techniques of the wireless transmission. Wireless transmission is future.
So I think MantrAsana is a great addition to our armamentarium, giving surgeons the abilities to extend their expertise.
So this is the need of our in a large country like ours to make it affordable, accessible to all the patients.
But what if care could reach even before infrastructure does? Introducing SSi Aero, a drone-deployed surgical robot where time is critical and access is limited. Care arrives when it matters most.
So I think when Professor Sudhir Srivastava came up with the concept of telesurgery, this was his brainchild. He told me long back about this, that Mohit, I'm going to develop a technology which will reach the battlefield, and one of the soldiers have been shot with a bullet which is there in his legs or in his chest and his lungs, and this drone can go there and can operate upon the patient entirely and can get back safely.
We were actually requested by the Indian Army to develop something that could be sent out to the remote areas or in battlefield situations, so that in any sort of traumatic case of the soldier might have suffered, a traumatic injury that a soldier might have suffered, then this drone will be able to fly on top of them. Then through telesurgery and the use of a miniaturized robotic system, at least be able to stabilize them.
So not only it will have army application, but also sometimes these various things occur, earthquakes or anything else, which opens up many challenges about really getting to the patient. So again, this mobile aero drone-based unit will be very helpful in getting to the patients and provide the immediate service.
SSi Aero, this will redefine the whole emergency surgery, battlefield, trauma, accident, combination of all three. And first time SSi Mantra is equipped with all the three to do this, which will revolutionize emergency surgeries, not only in India, across the world and globe.
SS Innovations is always a step ahead of the curve. With Project Operion, a reimagined surgical environment where advanced surgical capability is no longer fixed but travels to the patient.
We want to offer everything to the patient near his house, where the travel-related stress can be reduced, the expenses of going away from home can be reduced.
Not only the patient has to travel, but now their families also have to travel, staying in hotels, eating in restaurants, etc. So now with our mobile operating room, we can bring the care to them.
Second tier city, third tier city, taluka places, small nursing homes, small hospitals, single specialty, multi-specialty, all of them are able to afford and take this.
Any technology is only going to be useful once it reaches the masses. So this decentralization will help a big way to train and, more importantly, treat patients across the country.
From the patient's viewpoint, they don't have to travel to get the expertise. And since today technology exists, allowing surgeons to be able to operate from wherever, and I think this is a tremendous evolution that will help patients and the families.
This is the true shift, where the best surgical expertise is no longer limited to a few locations, where advanced care becomes accessible across Tier 2 cities, across rural regions, across the world. A world where every patient has access to the best possible care. Every procedure, every connection, every innovation, taking us closer to a future where healthcare has no boundaries.
Future of surgery would be error-free, standardized, AI-enabled, ambulatory surgery, accessible by surgeons sitting anywhere in the world, including his office or in vacation or other, and reproduce same result by different type of surgeon across all.
Cost-effective, accessible robotic surgery being democratized by a current platform, and also MantrAsana is going to completely revolutionize the way surgery is delivered around the world.
Whether it is orthopedics, whether it is neurosurgery, whether it is brain, heart surgery, abdominal surgeries, urology, my core branch, kidney transplant, robotics and technology will reach everywhere.
Mostly these things going to be very minimally invasive, where something will be entering inside the lumen through a scope, and all the procedure will be done endoluminally. You will not have incisions on the body in future.
You will use a lot of technology to make the diagnosis fast, treat effectively without pain to the patient.
So now how to find creative ways utilizing technologies aligned with our company mission and vision to be able to actually effectuate that positive change. And we're using India as a model initially, but that model is now spreading globally like wildfire.
We didn't just imagine the future of surgery. We are building it. Because when distance disappears, care reaches everyone.
And we really hope that this care truly becomes global. The divisions actually dissolve. We start to look at how we can help each other rather than finding ways to destroy each other.
SS Innovations, defining the future of global healthcare.
What a powerful reminder of how vision becomes reality when innovation is driven by purpose. We now begin our plenary session with a speaker who has devoted his life to fighting cancer through the precision and promise of robotic surgery. A pioneer dedicated to fighting cancer through the precision of robotic surgery, specializing in urogenital oncology and serving as the medical director and chief of urogenital oncology at Rajiv Gandhi Cancer Institute and Research Center, Delhi. Please welcome Dr. Sudhir Kumar Rawal, who will take us through the powerful vision of democratizing robotic access across the globe with SSi Mantra.
Thank you and good morning, everyone. If we go in past, when this robot was actually made and we did the trials, we never thought that it will click like this and we'll be talking about this topic. Though the main intention of making robot of Dr. Sudhir Srivastava, when he met me, he said he wants to make an affordable robot, for which I was looking for, though I did have Da Vinci at that time. This was in 2017 or 18. But then because of some problem, you know, everybody knows of those things, that Da Vinci was very costly and the running cost was very high. So I was immediately interested in this, and finally when this got launched in 2022, slowly the things, they changed. And if you put your, nowadays we talk a lot about AI, and I put the topic on Cloud A and Notebook LM to get the PPT out of it. And my PPT is from those only, with some slides which are actually actual. And that talk a lot of, you know, AI hallucinates also. It's not that it will give you the fact. And those things are there in this. And there's some things which are very, you know, true also. I'll be talking of that, those things in my talk. So when you have the robot and you want to go everywhere, there is definitely, you know, you have to look some steps, because whole of the world is not same. It's not like West Europe and America. The main thing which matters is cost, maintenance, and running cost. That's the main thing which was problem with the Da Vinci. And as you see that the robotic revolution which occurred, where are we today? We can see that $9.2 billion dollar market will be there in 2034. And this is how the Da Vinci, robotic world has evolved. In 1999, first Da Vinci was approved for FDA. Then 2006, it was approved for radical prostatectomy, which became a standard all over the world. And then in 2014, it was approved for robotic gynae and colorectal adoptions. In 2020, during COVID, people actually started thinking of doing remote surgery. While in 24, you have Vercius, that is CMR, Hugo Res, entered in the US market, but Vercius was before that in India since 2019, and 2022 Mantra entered. And now we have in 2006, the things are changing. While Da Vinci is mainly in United States, almost 59% of the Da Vincis are in USA and Europe, 19% in Europe. Asia, they are 18%, and 4% is rest of the world. This makes a lot of difficulty providing the robotic surgery everywhere in the world, and there's the problem with Da Vinci. If you want to democratize robotic surgery, you have to have affordable platform. And next generation platform, I think Mantra leads anybody else, like Hugo or Vercius. Vercius has his own problem. It's not very popular, and it is there since 2019, and only 39 sites it has gone. Then training infrastructure, you have to have simulation, curriculum, cloud-based e-learning, telementoring, and international fellowship programs. Third is policy and reimbursement. Robotic surgery has a problem of not reimbursed by the many TPAs and all. That's a big problem we face in our hospital also. But then one has to have government has to step in so that this can become like open surgery. Then fourth is technology, equalization, and where AI, AR guidance and telesurgery via 5G comes, and which is already happening in the robotic world. When I put democratizing robotic surgery in Notebook LM, I got these two statements which were very encouraging. That first was how to reduce the robotic manufacturing cost, and they said that advanced manufacturing local materials has to be used. And for example, Indian company SSi Mantra has successfully developed a fully robotic system at a fraction of the cost of global incumbents targeting both public and private hospital. So this is what actually already there in AI, and which is true also. And second statement was that you can reduce the cost by using open source software and low cost hardware. And that's what actually is needed, and is only platform in the world is Mantra. So I now switched over to Mantra only because I will not talk about CMR, Vercius or Hugo. So Mantra can be used by anybody. This has been proven. Almost 10,000 surgeries has been done by urologists, general surgeon, gynecologists, GI surgery. And though it started from the urology, but then now it's more used by general surgeon and gynecologist. This is the comparison access gap in the how the Da Vinci robot system are worldwide, and its cost is $2 to $3 million, and in developing nation it's only less than 5%, and 70% of the world population is lacking, which can be covered. There's a huge market for the affordable robots. So Mantra actually developed by SSi Innovation. You've seen that CE marked. This is from again AI, which is wrong. CE marked robot surgical system approved by international market. It's not been approved so far, but soon it will be. 60 to 70% of the lower total cost of ownership, which is very good and is true also. It's a 4-arm wristed robotic system with 3D HD visualization with thermal filtration. It has got 5-arm also. You can have 3 to 5 arm, designed to deploy in the tier 1, 2, 3 hospital across the emerging economy, which is happening already. You will see in my slide where else it has gone. It is compatible with existing laparoscopic training and reduces the learning curve. This is not true, and this is from AI, but definitely it's very easy to learn as any robotic system. Now these are specifications. You have robotic arms, console design, visualization. Instruments I will talk. They have more than Da Vinci instrument. Da Vinci has 30, they probably have more than that. And many instruments they are making which will surpass any company in the world. They have tremor filtration and modular platform. Those things are there in the MantrAsana. We have used it recently for telesurgery. Then application in urology, the radical prostatectomy, nephrectomy, cystectomy, pyeloplasty, everything has been done with Mantra and routinely done. In gynecology, hysterectomies, robotic myomectomies, sacropexy, endometriosis surgery, and robotic staging gynecological cancer is being done. Robotic cholecystectomy, fundoplication by general surgeon, hernia has picked up like anything. Everybody is using robot for hernia. Then robotic splenectomy and adrenalectomy. Then GI surgeon are using for LAR, low interior resection, gastrectomies, hemicolectomy, esophagectomy, Whipple, and robotic liver resection. Also, few urologists have used to do robotic recipient transplantation. Now, this is the cost difference. If you go through the system application and all, where the Mantra is actually traditional cost is $2 to $3.5 million. Mantra is $0.6 to $0.9 million. Annual maintenance cost is $150,000, while Mantra is even less than this. Instrument cost is $1,500 to $2,500 for traditional robots, while Mantra is $300 to $600 US. And training center, the traditional one have the limited center, while the Mantra has an India-wide network. It enables to a tier 2 to 3 hospital to adopt robotics for first time, as it happened when we bought this robot in 2022. Next robot came to Raipur and third came to Muradabad. Accessible for 40 plus developing and emerging market countries. It is actually accessible for any place in the world. It depends how it goes. But then community hospital in India, Southeast Asia, Africa and Middle East, they are using it not in Africa, Southeast Asia and Middle East, it is there already. And reduced per cost enables a sustainable surgical volume. That's the most important thing with the Mantra. There's a modular infrastructure requirement, no dedicated OR build is needed for Mantra. These are the facts which I got from SSi. They have installed 190 plus robotic system and 100 plus validated surgical procedure has been done. More than 10,000 plus multi-specialty procedure has been done. Out of them, 450 are cardiac surgeries because Dr. Sudhir is a cardiac surgeon. He's pushing into cardiac surgery like anything. Then 160 plus telesurgeries have been done. 1200 plus surgeons have been trained. 1500 plus surgical staff has been trained. And 100 plus times live surgery demo has been done. It is being done since 2022 when this came. We showed everywhere in all conference whenever we had an opportunity to show in the country. Then there is zero mortality and any device related injury is not there at all and device related complications are zero. These are the places where Mantra has gone now. There are 2 sites in America. There are academic center. Well, the red sites are installed base. This in Colombia, South America, and I think Guatemala also. Then in Middle East and in India, then Jakarta and Philippines also. One surgeon came from Jakarta to see the Mantra long back, and at that time, whole of the Indonesia has only one XI. They wanted that something affordable robot can come. So they were looking forward, and the guy was gynecologist, and he said, and I had 2 Da Vinci in my Audi and 2 Mantra. So he said, Sudhir, you have defeated Indonesia alone because they had only one robot. So that was funny part of him, and he was a very nice person. These are the India's fastest growing and most cost efficient surgical robotic platforms. You can see that how the growth has occurred in 2025. 103 robots has been sold. But if you see the growth of Intuitive in India, they say they are there in India since 2002 2002, 24 years, only 290 robots are in India. CMR is since 2019, 29 is actually misprint, and there are 7 years, there are only 35 robots in India. The Medtronics Hugo is since September 21, and there is only 11 robots in India, while SSi has got 194 robots in India. And if you see the tier 3 penetration, then there is Ambala, Mulana, Moradabad, Guntur, Rajamundry, Tukumur, Jalandhar, Aligarh, Purnia, Nashik, Sikar, even Agra, Gorakhpur, Muzaffarnagar, Ludhiana, everywhere. So many of the city you may not be knowing, but it has gone to those cities. Especially any hospital which has 50 to 100 bedded, well-running hospital would like to have this robot in their theatre. Now, clinical outcomes with Mantra and Da Vinci or any other robots are comparable. There is less blood loss, less length of stay, less complication, increased precision, and the adoption is increasing everywhere. And you can see the volume across RGCI and Muradabad and every other AIMS and other leading centers. Now, these are again some AI hallucination, like talking that it is there in Africa, Nigeria, Kenya. It is not there. In Europe, market penetration is there, but it's not there. But once CE mark, then let us see. But in Latin America, it is there in Colombia. And Middle East, it is there. And Southeast Asia, not in Thailand, Vietnam, but in Philippines and in Jakarta. I think SSi will be happy to see these slides if they are in Thailand, Vietnam, everywhere. So it is affordable, accessible, has high quality robotic surgery, and it should be there for everywhere. And this comes training and support ecosystem, which is very robust from Mantra. They have fellowship. I get a lot of fellows from everywhere, all over the world, to get training on Mantra. They stay with me for 2-3 days, then they go to headquarters, and every month we get 4 or 5 fellows from somewhere from India, South India, or maybe in the neighboring country. The roadmap ahead for Mantra, they I think already working. They are more than this, and tomorrow we can talk about single port, what is going to be in future. But the vision of Mantra, according to AI, is to position India as global hub for accessible robotic surgery innovation, which is correct. But serving patients from Mumbai to Nairobi and Delhi to Dhaka, I don't think it is correct, but it is there if you put in AI. Future of surgery is here, and it belongs to every patient everywhere. SSi Mantra delivers world-class robotic surgical capabilities at a fraction of cost of Western platform, which is 100% correct. Comprehensive application across urology, gynecology, general surgery, and GI surgery. It has been used everywhere, even head neck surgery. They have not given this, but in my center, people are using it in head neck surgery. They are doing thyroid and neck dissection. It's a true democratization by Mantra. It's enabling patients in tier 2 and 3 cities and emerging economies to accessible robotic surgery. Robotic surgery is no longer is a luxury. It is necessary because it gives you better outcomes, not only in cancer patient, in other benign surgeries also. New platform like Mantra is making technology affordable and accessible. Telementoring and AI are eliminating training center and going the chief surgeon anywhere. He can teach from his center. Collective action on policy and economics is now needed from the government. Now this comes from my name, but I have never said this thing. And this is from AI again. Every patient deserves the best surgery, regardless of where they live. But I never said this. This is in AI. But what I said is this, that laparoscopy surgery will be thing of past. Thank you.
Thank you so much, Dr. Raval. And now it is time to call upon a physician, medical device developer, and entrepreneur who has shaped the very foundation of medical robotics as we know it today. Please welcome Dr. Frederick Moll, the pioneer of surgical robotics, who will take us through the extraordinary evolution of robotics from where it began, where it stands today, and where it is destined to go. He will be joining us virtually today.
morning, everyone. I hope you can hear me.
Yes, we can, Dr. Moll.
Great. Good morning. Apologize profusely for not being able to attend in person. World events got in the way of my world travel, and but I am pleased to speak with you today. And I thought what might be interesting to the audience is to have a little bit of history with regard to at least my experience in developing first robotic systems, and what my thinking was then and what my thinking is now with regard to the future of robotic technique. We have the first slide. There we go. Next slide, please. Yeah. I think we would all agree that medical intervention is a algorithm that keeps changing based on knowledge and development of technology, and it will continue to change and hopefully improve for the betterment of patient care. I was, next slide, please. I was lucky enough to be trained at a time and had a front row seat to the development of not robotics yet, but the really dawn of minimally invasive surgery itself. I was a general surgery resident, but saw the attributes of laparoscopy in the hands of the gynecologist. And as a aspiring general surgeon, got very excited about the future of minimally invasive technique, and this notion that you see in the next slide, that the idea that there was an alternative to making a big incision and creating trauma to the patient and excessive morbidity associated with just getting access to anatomy, and the idea of limiting the trauma to a few puncture wounds made so much sense to me that I went off and tried to develop and had some success in developing manual tools for laparoscopy. My experience with that was a good one, although as general surgeons tried to do more and more manual laparoscopic technique, some of the challenges associated, next slide, with the technique, as everyone knows, is you do not have the same dexterity and capability as one did in open surgery. You lose the wrist and the movement of your digits in a way that creates challenges. Next slide. Next slide, please. Where my experience in watching conventional manual laparoscopic technique is that there were very well-trained, very talented surgeons that were having trouble tying knots. And, that sort of hit me right between the eyes. This is not sustainable as a technique that can advance to very sophisticated surgery. Great for simple things, not so good for the development of more precise and technique and more complicated surgery. Next slide. Ironically, some old things are new again. So the inspiration for me to get involved in and have the idea of robotic surgery that could augment laparoscopic or minimally invasive technique was a demonstration of, believe it or not, telesurgery way back in 1995. that was trying to, they're attempting to develop what was just mentioned, battlefield applications, where the idea wasn't to limit the size of the incision. The idea was to try and transmit surgical technique and capability to the battlefield. And they hadn't gotten very far. They could transmit open surgical technique from one end of the room to the other. That was about as far as that capability was developed. But for me, it represented the opportunity to use this idea of telesurgery or transmission of movement from not across the room, or as now is possible across continents, but just across the body cavity to reach internally, and then be able to return to the clinician the capabilities that he or she had in open surgery. Next slide, please. So the idea of creating and transmitting the capabilities of the hand inside the body was for me the sort of aha moment of why robotic surgery might make sense. And the challenge was only to create instinctive movements from outside to inside in a way that felt natural to the surgeon. Next slide, please. So this was a challenge, a technical challenge in those days. There were some very smart engineers that did a very good job of making the movements inside the body natural, and complemented it with three-dimensional vision, which gave back to the clinician the ability to have depth perception the way they had in open surgery, which they actually lacked in manual laparoscopic technique. Next slide. So I thought we had it all figured out, and then I ran into for a 10-year period the very strong objections to robotic surgery as a concept. And I talk about the 4 stages of acceptance. It's a bit tongue-in-cheek, but it was a struggle that saw enormous amount of resistance. There were a few people that saw it very early. Dr. Srivastava was one of them, and but most didn't, and most really were not only skeptical, they were sort of vehemently opposed to what, for a variety of legitimate reasons. It was early on, but we survived, sort of a 10-year battle for acceptance among the general population of surgeons, and we're very lucky to be able to have the resources to weather that storm and deliver what I think is now proven to be a very important new capability in surgical technique. Next slide, please. So we because of the enormous resistance, we thought very hard about what can we do in robotic technique that will be recognized as a very significant improvement over laparoscopic or open surgical technique. And what we ended up with as far as what might catch everyone's attention is to be able to do a coronary anastomosis with a minimally invasively with robotic technique. And if we could do that, then the naysayers would recognize that this is something that can't be done with manual technique and in a minimally invasive format, and would prove the value, from a pure technical standpoint of the technology. So we started in cardiac surgery. Next slide, please. But as you know, it has grown over time, where cardiac surgery was probably, in retrospect, a very difficult place to start. Once we found prostatectomy, it was much easier to propagate systems because the match between the challenges associated with prostate surgery and the advantages of robotic surgery was a very good match. It is now, as you know, gone to many other places inside the abdomen, thorax, and pelvis, as well as in other areas. Next slide, please. And I think the attributes that I would say have made robotic surgery successful, it is first the ability to minimize the size of the incision and still have very fine capability. And in that way, given surgeons of all skills, the ability to a real democratization of technique. What's really interesting to me now is that robotics is necessary, I think, for us to take the next step in the development of surgical technique by integrating capabilities like AI and teleintervention. And it is necessary to have the hardware and the software to progress from where we are today in robotic surgery to even more sophisticated technique, and in some cases autonomous capability with certain parts of procedures. So very excited about how robotics can lead us and is leading us to teleintervention and more sophisticated capabilities with the help of AI. Next slide, please. So the big question, in the robotic space is, can robotics add value not only to what we've seen to date, but in diverse clinical applications. Next slide. And I think the answer is clearly that the answer is yes, and there's and everyone is aware that in not only general surgery, gynecology, thoracic surgery, but in orthopedics, in procedures that involve electrophysiology, ophthalmology, cosmetic surgery, and vascular intervention are all candidates for the development of and the betterment of these procedures with robotic technique. Next slide. So in conclusion, I'd say that we're just getting started, I believe, with robotic technique. And I do believe that robotic systems will emerge as the conduit for ever increasing integration in technology and the sophistication of how we do surgery and how we deliver medical intervention. Next slide. I want to tell you about what I think is a very exciting development in vascular intervention with robotic technique, and I'll tell you about it because I was just in Panama, and we did the world's first telerobotic stroke thrombectomy. And why is this interesting? I think it exemplifies. We're going to talk a lot in this session or these sessions in the next couple of days about telesurgery. And I think if you look at what can telesurgery do for medical intervention, it's a long list of items, but one of them that I think is at the top of the list is to really revolutionize the treatment of emergent situations. And at the top of one of the medical conditions at the top of that list is stroke. And everyone knows that stroke is a major killer that can be treated now very effectively in many cases if caught in time. In other words, and we all know the term, the reference to time is brain. And so it's a race with the clock, and nothing, I think, can make a bigger difference in the treatment of stroke than teleintervention. And so we were in Panama, and we had a logistical setup such that we could recruit patients from rural areas in Panama that had no hope, if they were unlucky enough to have a stroke, had no hope of getting embolectomy therapy if they qualified. In other words, they would never see, even if they got to a hospital, had a CT scan, and it was determined they had a large vessel occlusion, that they would have no hope of having someone that had the skill and the capability to do an emergent thrombectomy. And they would suffer the consequences, run out of time, and either die or live with a lifelong disability. So this is an example of teleintervention that I think is in our future, that is very exciting. It's also an extraordinarily challenging potential use of robotics because of the logistics associated with identifying a patient in time and intervening. And this is where teleintervention can be, with the proper logistics and the proper organization of and communication between healthcare institutions to identify patients that are candidates for thromboembolectomy in an emergent situation, and be able to have telerobotic intervention as an option, such that a neurointerventionalist does not have to be in the same location as the patient, I think can define a new chapter in this type of teleintervention that would have, I think, an enormous impact in the practice of interventional neuroradiology. We spent a week in Costa Rica we had 6 institutions that were referring patients. We were, in the first 48 hours, we had a patient that had a large vessel occlusion and was able to get to the hospital that was remote from the command center where the neurologist, neurointerventionalist was able to do a thromboembolectomy and save the patient's life. If you show the next slide. This is a before and after of the patient's left hemisphere vasculature that was completely occluded, that got full reperfusion, and the patient left the hospital in 48 hours. You can see the clot that was removed. This patient would have died or would have been horribly handicapped for the rest of his life. And I think it is one example of the future of robotics, of telerobotics, teleintervention, and the ability to really turn the corner on some of the most debilitating and deadly diseases that we face as surgeons and physicians. So I'll stop there. Thank you very much for your attention.
Thank you so much, Dr. Moll, and we look forward to you to join us for the inaugural session, which is going to be a little later.
Thank you.
Thank you so much. Now please welcome Dr. Venkatesh Munikrishnan, a colorectal surgeon with over 30 years of experience at Apollo Hospitals, a grant awardee by Bracco Milan for CT colonography research, and a proud recipient of the Royal Society of Medicine Traveling Fellowship, who will take us through his remarkable journey of expanding the horizons of telesurgery with the MantrAsana.
Morning, ladies and gentlemen. So I've been asked to speak about introduction to telesurgery, so I will share what I understand of it. So the topic given to me is expanding the telesurgery horizons with the MantrAsana. So let's ask the basic question and try to answer it. Now, when I looked at telesurgery, I think the key question or the challenge we face is that for our patients, where you live should not decide how you access surgical expertise. If you actually analyze the data which is available around the world, 80% of specialist surgical expertise sits in urban centers. Millions around the world have to travel long distances for care that they shouldn't have to. And consequently, outcomes vary, not because the disease is different, but because access to expertise is the challenge. So access to surgical expertise today is limited by geography, and I think this is a very important point to ponder. Surgical disease, as we know, can be complex, highly morbid, and surgeons have steep learning curves, so it's a complex problem to deal with. We've answered some of that as surgeons. Some of these challenges have been looked at through subspecialization, where we've seen high volumes, and with high volume surgery, consistent quality outcomes, predictable outcomes, and scalable protocols have all given us the results we need for our patients. Robotic surgery has given us precision, ergonomics, reproducibility, and more importantly, data capture and digitization. Now, this is a capture of an operation which I did recently. It shows every movement of mine, either energy or instrumentation or the camera being digitized and stored in the system, transmitted across to the robot through hard cable, and stored in the cloud. Now, if expertise can be digitized, then it can be transmitted to any point around the world to the point of care where it is required, which forms the basis of telesurgery. So telesurgery, as we know today, is also known as remote surgery, is the performance of a surgical procedure by a surgeon located in a different location than the patient, using advanced robotic systems, high-speed telecommunications, and real-time high-definition video. We've seen this in most of our operating rooms, one platform or the other, which has a console with a surgeon sat on it, and a robot which is docked in a patient and which is hardwired. This is pretty much across the world. Now, with high-speed fiber, 5G and satellite, we're able to separate the surgeon and the operating room. The surgeon may be sat in the clinic or in a hospital lab, where a console is physically separated. Now, I think that's where this new technology from, sorry, I don't have the audio here, from SS Innovations or the MantrAsana, I think we got it back here. So I let the video run. So the MantrAsana is a telesurgeon console. I love the audio when they first shared the video. I think a little bit of Bollywood is always good in surgical meetings. So this chair is telesurgery enabled. It's got AR glasses. It's got a tele-interactive screen, ergonomics controls, retractable foot pedals where the energy devices are, and magnetic sensor hand controls. Now, what this enables us is the expertise is centralized, but the delivery of surgical care can be decentralized. It has a low footprint, enabled with telesurgery, it's portable and office-based. So we recently had a telethon right out of Gurgaon in the SSi headquarters, where we performed the first robotic colorectal surgery using a portable telesurgery chair. So the distance between Gurgaon and Chennai Apollo Hospital was 2,200 kilometers. The round-trip network latency, that's from when I perform a movement, it is transmitted across. The movements are, in the patient. We do the procedure, it's transmitted back, and I visualize it. The round trip is very important. And so that latency is about 250, 260 milliseconds. Anything less than 400 milliseconds is not perceptible to the human eye. So the SS Mantra National Telesurgery Experience, if you look at what we've done so far, is about 158 procedures covering varying specialties from general surgery, bariatric, gynecology, urology, cardiac, and GI procedures. And the MantrAsana was used to perform 29 of these 158 procedures. So what we are heading or seeing in the future is delivering surgical expertise at scale in multiple locations or geographies safely. And as a surgeon sat in the office, you could connect to a remote location, could be multiple locations, and staggered timelines. So surgical expertise at scale is happening now, whether it's intra-city or intercity, intrastate or interstate, or transcontinental. So the standard of care has been patient travels long distances seeking expertise. Expertise has always been centralized in the ivory towers with the expert surgeons. But now patients can stay local with their local support systems, which becomes very important. And the surgeon delivers expertise through decentralized remote robotic networks sitting either in the office or the clinic. Now, your office could be a warehouse where you have multiple MantrAsanas with different specialty surgeons coming in, logging in and operating in different parts of the world in different specialties. Or you could be sat on the beach with your MantrAsana with no stress. I know where I want to be sitting, definitely the latter. So this is what I call hyper-localization of surgical expertise. And I think in the future, we would see there will be patients who have, for example, rectal cancer, whose The data would be transmitted across where it would be AI-assisted triage and workflows will be done. There will be predictable surgical planning on the multidisciplinary team, which says, okay, this cancer is ready for surgery, and who is available, who's got the license to perform. Say in the Middle East, if you have a license, India or the UK license, I should be able to connect and do the surgery. And then a centralized platform where all the data outcomes are collected, and you have a chart which shows the entire workflow. So there are still challenges to implementation which come with licensing, credentialing, reimbursement, and liability, but those are the challenges which we as a group will have to address in the near future. But I think the true democratization of surgical expertise is happening, and I think there is already a pathway where the subspecialization will give you lots of experience and expertise, which you can carry on to robotic surgery, and the more you perform, and once you reach a certain skill set, or experience volumes, you should be able to translate that through telesurgery safely. And then with portable telesurgery, you should be able to decentralize where you deliver surgery from. Thank you.
Thank you so much, Dr. Venkatesh. Our next speaker brings us closer to one of the most important realities of healthcare in India: how advanced technology can move beyond metros and begin serving the wider nation. A general surgeon with over 20 years of experience, trained at the University of Delhi, and a specialist in advanced surgical procedures with a record of over 15,000 laparoscopic procedures and over 500 successful robotic surgeries, please welcome Dr. Magan Mehrotra, who will take us through the inspiring story of how SSi Mantra has successfully led world-class robotic surgery beyond the boundaries of metropolitan cities.
At the outset, I would like to thank Dr. Sudhir Srivastava and the entire team of SSi for this system and for the opportunity to be here to talk in front of you. Yeah, so how SSi Mantra led to a successful robotic program beyond the metropolitan cities. I bring greetings from Moradabad, where we have the SSi Mantra 3.0 installed at the Apex Hospital. It has been 2.5 years. And so I'll start with what robotics meant to us when we looked at it in 2017. And it meant high capital investments, limited access to the surgeons for training, limited access for the patients, and high recurring costs. So what has changed now is that an intelligent fool can make things bigger and more complex. It takes a touch of genius and a lot of courage to move in the opposite direction. And that is what this man did for us. And that is how we got the great system that we are working on today. So I'll just take you through my journey. Life was meant for good friends and great adventures. And there was a good friend who visited the SSi office back in 2023, who told me that this is a great system and you should try it. And so I went the next day to the SSi office where I met Dr. Srivastava and Dr. Vishwa and tried on the system. And when you like something, that was on 27th March, and you want to take it, what do? You convince your wife first. So I took her on 7th April to use this system. And when she also said, okay, let's go ahead, we did not waste time. Within a 2 months period, we got the system, and we started the training of the staff on 6th of July with the Mantra 2.0. And it was 1st of August when we did our first hernia surgery on the new robotic system, and we were really enthusiastic about the possibilities that it was opening up for us. And it was in no time that we completed our 100 cases, which was on the 20th of January. And I remember fondly, it was 2024, 20th of January, when we had the first SMRSC, where we declared that we had done 100 cases. And then the ball got rolling from there on. We did a live demonstration in IAGS in Chennai, which was on 3rd of February. Then in 2024, we did in the ARIS 1st of March, we did a live demonstration of an ETAP, which is a complex abdominal wall reconstruction surgery, and we did it live on this system, which gave us a lot of confidence as a team. And then it was in ASICON in December 2024 that we demonstrated the ETAP again with greater finesse. And then came the 500 cases, and this is our team, which is very enthusiastic about this milestone that we achieved on the 30th of April last year. And as of now, we stand at 900 plus cases at our center. So robotic trends have changed over time. Complex excisional cancer surgeries, advanced urology cases, cardiac surgeries, complex reconstructive surgeries were being done on the robots till about 5 years back. But now it consists only 40% of the work on the robot. And now the robot is being increasingly used for hernia and abdominal wall reconstructions, upper abdominal surgeries like the hiatus hernia and the bariatric surgeries, pelvic surgeries, which include gynecological surgeries, and routine surgical procedures like the laparoscopic cholecystectomy. These constitute 60% of the work of the robot now. And this is also shown by the number of publications which have increased after 2020, after the COVID era, that we have seen that the publications on robotic surgery have increased by many-fold. So the next challenge is the economics of robotic surgery, and that is why Tier 2 city and robotics is important and is being looked at. So I'll talk about decoding the ROI of robotics in 2026. So this slide sums up what all you require in a Tier 2 city to make a successful program. One thing is a lead surgeon. Second is a dedicated OT staff and hospital administration, multidisciplinary team. And you have to choose the right robotic system. You cannot be taking the most expensive system which is available and then try to take the ROI of that system. Then the market analysis has to be there. You have to add value to your product that you're giving to the patients. You have to see how you can make things better for them. Marketing and projection has to be there, and then clinical research and development. And the last two will be actually aided by the fifth and sixth points. So there is one part in the OT and the other part outside the OT. To sum up, these are the key ingredients for success. And so I'll come to the first, which is the lead surgeon, and I'll go back to what Alexander the Great said. Through every generation of human race, there has been a constant fear, a war with fear. Those who have the courage to conquer it are made free, and those who are conquered by it are made to suffer until they have the courage to defeat it. So here you have the lead surgeon in 2026. He has to allay fears and apprehensions associated with a new concept or investment. And that is what the lead surgeon has to do here. The he has to generate robotic surgical work through an established surgical practice. He has to give the first mover advantage to his center, and he has to train extensively to give good results. So OR team has to be very dedicated, and the sympathetic administration is very important. If the administration thinks about recovering the cost of the robot from the first case, then you will never be able to find the first few cases for your robotic platform. So you have to think about cost recovery later, and first gaining experience and trying to explore what you can do with the system. Multidisciplinary involvement, general surgeon, gynecologist, urologist, GI and onco-surgeons, and preferably a cardiothoracic surgeon if it's possible. Market analysis, I will spend 2 minutes on this. In your city, if the patients are paying for IPOM meshes and tackers, they cost somewhere around 50 to 60,000 rupees. If they're paying for knee replacement, total knee replacement, where a knee replacement costs anywhere around 1.5 to 2 lakhs, or if they are paying for bariatric surgeries, they can definitely pay for the robotic surgery as well. So it is about paying capacity, but it is also about whether you are convinced that the patient will benefit from these things or not. So insurance, again, insurance are more happy to pay us for robotic surgeries when we are outside the metros, because our general healthcare costs are lower than the corporates like the Max and Apollo, because they have too many overheads to take care of. And hospital image, I would say the hospital image gets better. It is something like a cath lab used to be in 2000. If some people are here who used to practice in 2000, any center which would have a cath lab would be considered an advanced center. Similar is the case with the robot nowadays. So Da Vinci versus Mantra, Hugo, the list is becoming longer, Microport, Edge, Merrill. You have to choose your weapon. If you take the wrong weapon, you may be a good warrior, you will not be able to fight the war. So value addition is the economic enhancement a company gives its products or services before offering them to the customers. So what do we do for our doing so? We have a robotic counseling desk because as clinicians, we don't have time for these patients, to convince these patients and to tell them about everything, every benefit that the robot may give and how they can decrease the cost of the procedure even by taking the robotic advantage. So a desk, an assistant to do so is always beneficial. We can offer multiple surgeries from the same ports. We can make the same ports for a hysterectomy and a cholecystectomy, which can be done simultaneously. We can make the same ports for an umbilical hernia and an inguinal hernia. And so many different surgeries can be clubbed because we have improved dexterity. We can follow the ERAS protocols more stringently to give them better benefit of postoperative pain. And we can plan ports in such a way that they can be cosmetically more appealing and they can be less painful to the patient, as I will show you in subsequent slides. So this is how I am looked at in Moradabad, the James Bond. I have all the latest gadgets with me, and that is the advantage that you get when you have a robot in a tier 2 city. So I'll not spend much more time on marketing and projection. Everyone knows that social media is the key to marketing these days. Clinical research, we have published eight papers in respectable international journals till now, and they are all related to general and gynecological surgeries in reputed surgical journals. And the latest of these is in surgical endoscopy, which has been accepted just a few days ago. And it is about comparison of robotic and laparoscopic cholecystectomy, and I'll come to that in a bit. So midline primary ventral hernias, if you can see, this is a large hernial sac which has been dissected away. This is a papery thin peritoneum, and you can see it has been dissected without a hole in the peritoneum. That is the power of the robot. That is the precision that it gives you, and that is the advantage that you can pass on to your patients. So this is a very short video. I will not show the whole video, just as I talk about the advantages. 2/3 of our practice of ventral hernias is primary midline ventral hernias. And these hernias are becoming more common with the problem of obesity. And so these patients want a minimal invasive surgery for their disease. And at the same time, you have to give a durable repair, and you don't have to fiddle with their body too much. You don't want to cut the muscles and everything. So you want to raise such a papery thin peritoneum and make a space of 10 by 10 centimeters, which is almost a very difficult possibility with laparoscopy because of the tremor of the hand or because of the ergonomic difficulties when you have the assistant standing by your side. And it is so much reproducible when you do it with a robotic platform. And that is why this hernia surgery is actually the backbone of our workload in hernias, as you can see. So next, I come to the inguinal hernia repair. So inguinal hernia repairs are being done by the laparoscopic method since long, but these big holes, as in direct hernias, were left open with a mesh there, and so they used to accumulate seroma in them, or at times the mesh would eventuate into the defect, and defect closure has definitely improved the seroma rates, as well as in the long term it will show that it will decrease the recurrence rate in inguinal hernias. And this kind of defect closure, which is being done on the roof, is much easier when you have a wristed instrument in 3D vision as compared to laparoscopy when you are struggling alongside your assistant to make angles meet. And therefore, TAPP for large hernias can decrease the seroma rate, and combined procedures are possible. And it is a very good procedure to start with in your robotic journey because it closely replicates the laparoscopic counterpart. What procedure was done here in this photograph? You can see this abdomen, the next one, this one. So you can see that this patient will have a clean abdomen when she is going to wear any dress that we Indians wear. So this is a cholecystectomy that has been done on this patient, and we call it the bikini line cholecystectomy. Here, if you can see, this is the image of the scars, and this is the image where how we put the ports for these. So this is what we have sent for publication and has been accepted. These patients have less pain, better cosmetic outcomes, and they are much more happier after a robotic cholecystectomy. So technically feasible to avoid an epigastric port in the, which is almost a necessity in the laparoscopic era. A tab block is more effective when the incisions are below the umbilicus, and it is a great tool in the learning curve. So here what we do is we completely separate the gallbladder from the bed, and after that we do the rest of the part with the clip applicators, the normal laparoscopic clip applicators and the extractors. So we have decreased our total time for a cholecystectomy to as less as 30 minutes with the console time of only 10 minutes. So this is how we can scale this technology and do multiple cases in one OT in a day, and make the cost, it is more cost effective, the robot. So abdominal wall reconstructions, ETAPs, TARs, these are all much better done by the laparoscopic stability and by the dexterity. However, these are advanced procedures and proctor guidance should be taken to avoid disasters. The other procedures that we do at our center are bariatric procedures, fundoplications, cardiomyotomies, ventral mesh rectopexies, hysterectomies, Verdheim's procedures, mesh sacrocolpopexies, myomectomies, choledochal cyst excisions, and any other complex benign surgery that comes our way. And the latest was a telesurgery that we did alongside Dr. Chandramohan Vaddi, who's a specialist reconstructive urologist, and he helped us to achieve a telesurgical repair for a recurrent VVF, which the patient had been struggling with, and which had excellent result. So that is the power of telesurgery that we just saw Dr. Venki talk about. And towards the end, I would like to pay my regards to my guru. And I say a guru is like a live road map. If you want to walk uncharted terrain, I think it is sensible to walk with a road map. And this is the person who actually inspired me to go into robotics, because I saw at his age he started doing robotics, so I thought I should also go in. Thank you for a patient hearing. These are my details. And we're doing a course on 16th and 17th May on inguinal hernias, where we are focusing on robotics only. Thank you.
Thank you so much, Dr. Magan. As robotic surgery evolves, one of the most important questions before us is this: what legacy are we building for the next generation of surgeons? Please welcome Dr. Mohit Bhandari, the first surgeon in the Indian subcontinent to have performed over 21,000 bariatric and metabolic surgeries, and a pioneer in laparoscopic and robotic-assisted surgery, who will take us through a visionary conversation on the future of surgical training and the legacy that the next generation of surgeons will proudly inherit.
At the outset, I would like to thank Professor Srivastava, Dr. Vishwa for inviting me here. It's an honor to speak. At first, I thought that this topic would be more philosophical for surgeons and young audience here. But then I thought I should prepare something so that I can take you as a sneak peek into the future of surgery. So, is it playing? I don't need the sound. Okay, sorry for that. So the future of surgery, legacy we should be leaving behind. I'm Mohit Bhandari. I represent Sri Aurobindo University and IRCAD India. We are so proud that IRCAD could come to India. There are 7 IRCADs presently in the world, and one of them is in India. I'm primarily a bariatric surgeon, a weight loss surgeon. I don't do, usually would not perform other kind of surgeries. These are my disclosures. This is our case mix, close to 45,000 bariatric procedures now, started in 2009. And we have a good mix. Bring greetings from colleagues, Manuel Galvao Neto and David Cummings, who work with me, and obviously Jack Marescau, who is the global director for IRCAD across the world. If anyone of you would have visited Strasbourg, you would know how big it is. A true surgeon's legacy is not counted in the number of surgeries he has performed, but in surgeons he has created. And I think that's very important when we discuss about legacy. And when we are talking about that, the future cannot be predicted, nor it can be decided without artificial intelligence. So in another 10 to 15 minutes, I'm going to show you what will the future of surgery look like in time to come. A surgeon who resists artificial intelligence, anybody in this hall who would try to do that, is not preserving the legacy, he's erasing it. So it is very important that all of us get trained and be prepared, because it is not going to take our job away in a big way, it is going to assist us in a big way. The goal of surgery in the future would be to democratize surgery. That's what Professor Srivastava has done. We heard in the first lecture that now it is reaching the district places. But we will never be able to democratize surgery without artificial intelligence also, even if we have a robotic system. How is that possible? You see, we are talking about augmented surgery. And if we talk about augmented surgery, the diagnosis would become much more important, because believe me, no matter how many number of cases you would want to operate, if you are not able to diagnose these cases at a very early stage, say about this colon cancer, if you have artificial intelligence, it does automatic diagnosis. This is a genius platform. It's a Chinese platform, but it's now available in Europe also. It can actually differentiate between an adenoma and non-adenoma. HiThink is another early gastric cancer detection platform surgeons will be using in future. The accuracy of this cancer detection will be over 90%, far exceeding the ability of any general doctor to diagnose a cancer. There are 3 existing product lines, the EndoAngel, RDAngel, and several others, which have done over 2 lakh patients, and they have diagnosed these cancers. You just need to put in a scope inside. If anybody knows colonoscopy or gastroscopy here, it will pick up the lesions automatically. It would decide whether it's an adenoma or non-adenoma, what is the extent to which that lesion has already gone, and it's going to create a huge difference. This is what Fred Moll was talking about, and I have a huge regard for him, somebody who has created robotic surgery, but the platform of robotic surgery in the future for young surgeons would be completely flexible. And you can record this, and you can take this back home, but 2028, we will be talking here about a completely endoscopic, flexible robotic platform than a rigid platform. And this is work of Professor Sarah Arcel from Barcelona. This platform, known as EndoQuest, is already ready, as you can see. You can suture it, you can cut a lesion, you can coagulate it, fulgurate it, whatever you want, and the suturing is precise and it's possible. A lot of people believe that suturing intraluminally is not easy. It would be very, very easy, more than what you do extraluminally, the kind of platform which is going to develop, exactly what we have seen with several other platforms. So the future is going to be robotic and flexible. Again, AI diagnosis in solid organs. We will be having a scope for the surgeons, and the radiologist will be taken away in the future, where a surgeon will put a scope in his OPD on the abdomen, and he would decide whether this is a mass, it is a simple mass, or it's a malignant mass, and the tumor detection would be possible. ChatGPT 5 is already there assisting surgeons in doing a lot of planning, not only in terms of therapy, but also in terms of what is the prognosis of the disease, and it is going to even happen now. The preoperative planning, we as surgeons, we are not very smart in that preoperative planning. We are more dependent on the radiologist. But imagine you are a pediatric surgeon and you have a pediatric hematoma, and you have an AI-guided lesion location platform, which will not only locate the lesion for you, will also tell you it is surrounded by which vessels, how you need to access that particular lesion, what you need to cut, what you need to take out, and at the end of the day, what is the extent of your dissection. This is all going to be possible by the AI. This is a software developed by IRCAD Strasbourg, and they have worked where you can actually do a completely 3D pre-op planning. Now, this is a case of endometriosis, and patient has some rectal nodules. What they have done is, in the software, they have put the CT and the MR images, and now they are trying to identify how much of the rectal shaving is required in this particular case. And you can go ahead and do a virtual colonoscopy through a software which will tell you these are the areas involved in the endometriosis and those are the areas which need to be dissected or separated. So even small bits of endometriosis inside would be picked up by using this particular software. And this particular software is being used at IRCAD in Strasbourg regularly for doing the planning for endometriosis. Similarly, preoperative planning with endosimulation, this is going to be there. SSi Mantra is also working on it. This is some work from our colleagues in IRCAD Strasbourg. You can do exactly a good preoperative planning. You would know how and what instruments needs to be used, where you need to go and put your ports in so that you get an early access to the tumor, what you need to do and how you need to plan. Exactly a complete simulation can be done. Also in terms of the instruments which needs to be used, which need not be used, a complete surgical planning can be done as if a surgery can be performed in simulation even before you enter the operating room. Again, surgical GPS, this is very, very interesting. I was involved in this work, and you can see that this is a robotic surgery going on where the surgeon has a parallel monitor in front of him while he is already peeping inside the robotic console. Now, what this is doing essentially is that he exactly knows what his anatomy is when he's going to dissect a colorectal cancer. This is Professor Armando Milani, a very close friend from Brazil, the director of IRCAD Brazil. And again, you can see inside the console, he can actually overlap both the images of where the tumor is, where the artery is, where the vessel is. It's just like a surgical GPS, which can guide you as to how you are moving inside. Anatomy, location, identification, extent of dissection is one of the most important feature where robots are going to assist in future. And this is going to be possible. You can see this in this particular case. Again, augmented anatomical organization for the fellows who are doing cholecystectomy. This particular project can detect, known as the Condor project, can detect if the amount of dissection at the Kellogg's triangle is good enough, more prone to damage the common bile duct, or it is going to create more problems. It starts from the stage of clipping to cutting to showing the gallbladder packaging to showing the gallbladder being removed. Every step which is being performed by the fellow is being marked and it's being done so that the outcomes can be predicted, the mistakes can be identified by artificial intelligence, and it can be done on a very automated way. Imagine you are doing a hernia repair. We saw a beautiful presentation of hernia robotics being done. Now see, you have triangle of doom and triangle of pain in hernia. Imagine you doing a hernia repair and AI guides you as to not to enter a space of triangle of doom or the triangle of pain where you can damage any of these nerves and cause essential trauma to the patient. And this is a beautiful example of how you will have to avoid dissection into places where AI is actually guiding you. This is the place, there is a genitofemoral nerve. Don't go there, you're going to damage it. Imagine if you get this in your operating room inside the robot, which is going to come. Most of these softwares will be coming in SSi Mantra. It's going to be so easy for young fellows and for you to understand. Again, the same thing can be there for the pelvic surgeries. This is a robotic surgery being done. You can see that the vessels are being marked, so you have two monitors. One monitor where you are doing all these surgeries, and the other monitor is actually showing you the location of the vessels, the arteries, the vein, the ureter. And that's two parallel monitors being operated, so you can actually understand and anatomically locate this. This is a robotic low anterior resection. Again, see, this is somewhere you can damage a lot of important nerves. Since here everybody, surgeons from all specialties are sitting, I'm not going to go into the details, but you see how it has identified the area where you need not dissect and the area where you should dissect. So we are going towards a phase of very high patient safety and very less surgeons litigation. And that's what is very, very important because we never had that. Talk about the fusion image. You have an ultrasound, you have an MR, you have a CT. You fuse all these three images, and then what you see is this. You see a complete deformable registration, insufflation plus manipulation, and you see this. You see the entire liver duct being delineated, where you need to go or where you need not go, and this is being overlapped with the image. So now, when you are entering inside, you are not blind. If I damage the common hepatic duct at the area of origin there, I'm going to find this. If I do not, I can be saved. So all I'm trying to say, the surgery is going to become easy. The hybrid operating room, we never thought that this is going to come. This already came in 2018 where, MRs and CTs were installed inside the operating room and a cath lab inside the operating room. The problem in 2017 and 18 was that this being planned, let's take an example of a hepatic surgery. You can do an intraoperative MR, you can do an intraoperative CT, you can combine those images with a lot of software, and this was a Zygo intraoperative fusion system which was installed in IRCAD, and this was practically working. And they were doing a lot of surgeries on these hybrid operating rooms. But why and what happened and why these things did not become very common? Again, this is another one which was, you can go and visit this in Strasbourg. It's already there, another hybrid operating room. You have one of the most advanced cath labs inside. It's a robotic cath lab with CT and MR installed. But what is the problem? It is not real time, it is not ergonomic, it is very, very costly. And they had cost of $4 million to create it and then $350K per year to maintain it. But then they came up with a new concept of smart, affordable hybrid OR, where they used artificial intelligence. Now, how here artificial intelligence has assisted surgeons to reduce the cost. An ultrasound which costs less than $5K plus a new generation C-arm can do exactly the same what they were doing and wasting so much of money in a hybrid operating room. As I said, fusion of images, 2D, 3D, with CT and MR is going to create this kind of image where you will have a cross-section. You get every other details of the anatomy in terms of what you need to operate and do the surgical planning. Remote surgery, we have already talked about so much. I'm going to skip these slides very fast, but just wanted to tell you that this was the first operation known as the Lindbergh operation done by Jack Maresca, sitting in United States of America, New York, operating a patient in Strasbourg in France. And this operation was published in journal Nature, was the first one. That time was very difficult, but then came the dormant years till until 2020, where nothing could happen until the revival era of 2021, where some of these companies could start and ultra-low latency networks could come. But let's talk about the Indian story, the SSi Mantra. I think Professor Srivastava has paved the way for this entire thing, and we also became a part of it. We bought 4 SSi Mantra system. After seeing his dedication, we could do the first bariatric telesurgery sitting in Gurgaon, around 800 kilometers apart. That day, we did 2 gastric bypasses simultaneously, and I could feel that there is no lag. Just to make this particular history, this is history. I was sitting in France in Strasbourg. On my side is Manuel Galvao Neto, my mentor, and we could perform a gastric bypass sitting in France with a patient in Indore. This is 3,000 kilometers away. This is a transcontinental surgery. One of the surgeries we performed, the second surgery was done by Professor Srivastava, and you can see that this is beautiful. We could do this, did in 42 minutes, absolutely no lag, and we were working on the university open network at that time. I hope we have more surgeons who could come to IRCAD Strasbourg to perform these kind of surgeries. There's a system there, you can go and do it. And this was the world's first telerobotic bariatric surgery, which was India's proud moment. 8,000 kilometers apart, 1 robot, 0 limits. I could ask my team to bring the Indian flag there in France, and it was a surprise, and we got it. And this is a photograph I would always remember in my life. There is something which I want to declare to all of you. Obesity surgery, one of the most reputed high impact factor journal of bariatric surgery, agreed to give the name to this operation as Sushruta operation. In the name of the legacy, we created the father of surgery from India. And this was the world's first long-distance telerobotic surgery using an indigenous robotic platform, a landmark case series of 1 anastomosis gastric bypass with SSi Mantra. And so it's a proud moment for us. Now we have developed our hospital networks. I'm based out of Indore, but I have hospitals in New Delhi and tie-up hospitals in Ahmedabad, Mumbai, Hyderabad, Chennai, Delhi, and we do telesurgeries to all these places. One such example, this is Dr. Sapan Jain's hospital in Udaipur. I was sitting here in IRCAD India office. This is his theater, and we could perform surgery at one of our patients sitting here at his hospital. This we are doing with multiple hospitals on a very regular basis. These days I finish my OR from 6 a.m. to 10. 11 I would reach IRCAD India's office and I would go and perform surgeries. Again, magnets have come to do the anastomosis. As surgeons, we have always struggled to do the anastomosis, the most difficult part, but now the magnets have come, and you can see how these work. So you don't need to do a full surgery. You can just make an enterotomy. So this is a mini gastric bypass. You see, I made an enterotomy. This device is known as an autolock magnetic device. This is a silicon-based device, and then you can fire the magnet inside the stomach. This magnet will remain inside the stomach, and then you go and make an enterotomy in the small bowel, just as this. Put another magnet there, and that magnet also will have autolock to just preserve the magnet there. This you can see is the magnet. I pull the magnet out, and then I do nothing. I just bring both stomach and the small bowel close to each other, and this is done. I have not edited this video. This is done. This is the anastomosis. So you can do a 5-second anastomosis. Now, what this would mean that even if you do not have a very good assistant at the other end, you need nothing, just somebody to make an enterotomy and gastrotomy to put magnets, and you can sit at a robot long distance apart and just join them. And you see how beautiful it looks. It's a patency established on table. This is going to be the future of robotics and the future of surgery, because this anastomosis, these magnets would be produced very, very cheap. And I know SSi Mantra is going to produce these magnets on robotic instruments very soon for all of you to use. So this is the world's first immediately patent magneto-duodenal first in human we did in India. And our own system, our own data got them approval, a US FDA approval for this company. Now we have done 100+ magnetic bypasses. In fact, we have crossed. We are doing surgeries in the Mantra van, sitting and doing surgeries all across the world. Now we are doing it on MantrAsana chair. We did the world's first MantrAsana bariatric surgery at the platform. This is another great achievement. Again, I think telementoring is the future, and you will not have classrooms which will be like this, like all of you are sitting. You will have somebody sitting in the Vision Pro at his home, where all these classrooms would be without walls, like so many people not there. We meet in the meetings more to meet each other and to sort of know each other, but a meeting can be attended very well sitting in the home using a Vision Pro, where you can see all the surgeries, you can demonstrate them, you can mark, you can you can do that. We have done 10 telerobotic bariatric surgeries in a single day, which is a world record with SSi Mantra. So you can see it's not just one or two. People say, oh, it's a fluke. You can do 1 or 2 such surgeries. But ultimately, there will be a lag. I have done 10 telerobotic surgeries sitting in the SSi Mantra office, and I finished them in 5 hours. So I can tell you there was absolutely no lag, and we had a lot of time. So this is our dream. This is our dream, to have a command center where we have 10 to 15 SSi Mantra, MantrAsana chairs, or maybe robotic consoles, and surgeons from various other parts of the world can come and sit and operate across the world. Natural stupidity is sometimes better than artificial intelligence. One should remember that. So we all know that barriers will be there. We will have people making complaints that, oh, this is not possible. There are ambiguity in terms of compliances. There's a cost to it. There are cybersecurity threats. But let me tell you, SSi Mantra has done all the legal framework streamlined for all of you to follow. So you need not waste your time. You should start doing surgeries with SSi Mantra. Just last 2 slides on the next steps of surgery. A lot is being talked about autonomous robotic surgery, which means that the robot will perform the surgery on itself. I know that most of you must have heard about that happening in the US, where a cholecystectomy was done autonomous by a robot on a pig. Yes, that is possible. You can see why this robot, a suturing can happen, where now the person has taken his head out of the console and the robot is suturing automatically. It's not still developed, but that can happen. This is a video borrowed from Johns Hopkins, and I thank my colleagues from there. This is a robot doing a cholecystectomy on a pig, and nothing is happening. There's no person there. And you can see that he has done the cystic duct dissection and everything is possible. But let's end this lecture by paying our tribute to Professor Srivastava. He's coming up with all these things, the project Operion, the single-arm robotic endoscopy ultrasound, the SSi Vimana. For the first time, ladies and gentlemen, friends and colleagues, I felt that India is leading the change and it is not following it. Every other part of the world I go. In fact, last 2024, I have received at least 10 international invitations to come to that country and do a telesurgery sitting on the stage. We are about to travel to Australia, where Australian College of Surgeons is extremely proud to invite us there to do a telesurgery on SSi Mantra. So I think it's time for all of us to lead the change as Indians and not follow it and rule. Thank you so much for this opportunity.
Thank you so much, Dr. Mohit. And now we move into a subject that beautifully reflects the future-facing spirit of this conference, the convergence of precision surgery, artificial intelligence, and telesurgical care. It is time to invite Dr. Ashutosh Tewari, who will take us through the transformative world of nerve-sparing robotic prostatectomy and how artificial intelligence and telesurgery are together democratizing surgical care for all.
I must thank Dr. Bhandari for setting up the foundations for my talk, because so far we have been hearing about the telesurgery and we have been hearing about different multiple procedures and how they can be done. I'm going to change the pace a little bit. I'll bring you back to one disease on which I have been working for last almost 20 years, have done over 10,000 of them, and I still think it needs to be improved. And I personally feel that AI and possibly the telesurgery will make me better, and hopefully it will ultimately scale it down to almost everyone can get the results the same way expert surgeons are getting. That's the foundation of my talk, and I will start with thanking and acknowledging Dr. Srivastava, who is a legend, who is a visionary, and who is the reason why we are all in this room. Thank you, Dr. Srivastava. And I also want to acknowledge that he and Dr. Rawat and Dr. Ashok Hemal, who are sitting here in the room, were the awardees for the Golden Robot Award this year, last couple of months ago in New York City. So bring it back. It's not AI, it's not telesurgery I'm talking about a disease. A disease which is very common. Over 11 million people in the world are living with this cancer, and if you look at the population of Greece, it's exactly the same. The problem is that this cancer is not slowing down. The Lancet Commission recently estimated that there will be an increase in the number of cases of prostate cancer all across the world, and they use the word, a tsunami will hit this part of the world with the prostate cancer. Reason I'm focusing on prostate cancer is because that's what I do, but what we will learn in this operation, we can scale it down to other delicate operations, other delicate diseases. So that's the reason I want to set it up, that why prostate cancer was the first target, while Dr. Fred Moll, when he was presenting that, he aimed at the heart and ended up at the prostate. In year 2000, I was part of the first robotic case being done in Henry Ford Hospital with Dr. Menon, and we got successful. Reason prostate is an important organ is that it's very common, almost every man will have to deal with it in one form or the other. But this cancer is very sharp, very smart. It has an ability to kind of fool us, because so many cases of prostate cancer will be there, but not everyone will have a bad cancer. And this cancer can hide amongst a large pool of sheep, but there are enough wolves around, to the point that while we can treat and cure 95% of prostate cancers, 5% patients still die, and that 5% translates into 4 Titanic ships sinking every week. Large pool, small percentage of patients actually dying, but that number still is very big. So how to tackle it? That's what the challenge is, and the challenge is not just in saving those lives. Those 95% of the patients, those 11 million patients who are living with the prostate cancer, are not just always healthy. There are patients who are having complications intra-op, peri-op, that's a small number, but they live with incontinence, they live with a sexual function issue, and that's what 40 to 50% of the patients may have that problem. And one of the legends of the prostate cancer field, his name is, those who are urologists in this room will know, Dr. Walsh. And his main goal was that if we can reduce the sexual function problem in prostate cancer surgery, this will be a major, major milestone. And he devoted his entire life developing principles and techniques of doing in robotic, non-robotic, open radical prostatectomy, what he called a nerve-sparing prostatectomy. Till 2000, that was the way we were tackling it. And that may have been the reason that robot became such a useful tool in hands of a good, qualified, understanding surgeon, because this is one operation in which you don't get judged by what you took out. You get judged by what you left behind. And the margin of error is literally in millimeters in this disease, that on one side is a cancer lurking outside the prostatic capsule, and then very close are the nerves which are controlling the sexuality, which are controlling the urinary control, which are controlling the bowel movements, which are controlling the orgasm and everything. So the fact that the margin of error was very low and there was competing goals for this operation, that's the reason even the open radical prostatectomy was not able to get to that point what robot got, because robot gave us dexterity, we saw that, but robot also gave us magnification. Robot gave us tools to go above and beyond what was being done, and that may have been the reason why robotic became a common tool, and now it can be expanded to the other things. But why there is an variability in an outcomes of a prostate cancer surgery even today? We have been doing the robotic surgery for the last 20, 25 years. Very good surgeons, very good teams, but the results, they vary. And that is where I think AI can help us to kind of making a great equalizer. The problem is prostate cancer is a multimodal problem. It has been with us for longest time, about 27,000 years ago when we had the first case of prostate cancer, and we are still trying to beat it. It is a disease which is driven by the cancer cell, but it is also driven by the volume. It takes about a couple of million cells before the cancer becomes about a centimeter mass, which can be seen on an MRI. It takes about 50 million cells. So the behavior of the cancer is driven by the cancer's own aggressiveness. It is also driven by the number of cells we are dealing with, and then it also is driven by the genes. Same word cancer, prostate cancer will behave differently if there are more bad genes, higher volume, or there is a more invasive cancer cell. Combining all that is not an easy problem for us to kind of navigate this journey, and I personally have been involved in this for the last 20 years. Somehow I got lucky about, in 1993, I was writing papers on the neural networks and artificial intelligence in prostate cancer. I didn't know that I'll be standing today.
VIP company, WhatsApp audio.
They can still get me from New York here. So the phone works. And so basically, there are innovations in the neural networks, artificial intelligence, neuroanatomy, surgical techniques, and then finally, there is something happening in the co-pilot, and we have written multiple papers on each one of these topics. So what I will be talking about, that how my journey about being an early adopter of the AI led me to be where I'm standing today and talking about how AI can be a great equalizer for the outcomes. This is 1993, multiple papers written, talking about the imaging, talking about the genes, talking about the models, and now first paper about the ChatGPT on the prostate cancer, and then slowly navigating toward the 5G, which will ultimately lead us toward the telesurgery discussion. We have put together an electronic version of the PSA that if we can do this model, we can risk predict for an individual patient what's the likelihood that there will be a cancer. And this is where we started. Dr. Himal is a part of this paper that we wrote about the technique of the robotic surgery in 2003. And prostate cancer surgery is driven by understanding of the anatomy. We wrote multiple papers about the anatomy. And as you can see, the AI is helping us in understanding even the anatomy a little bit better. This is an AI-generated, AI-augmented model which is telling us that the stress during the surgery can have an impact on the nerves around the prostate. We have created the 3D models which tell us exactly where the cancer is, We incorporate all the information about the MRI, the ultrasound, the PSMA, and we have a digital twin. And we have created a compass which when we go inside the operating room, it tells me exactly where the cancer is trying to escape. It is on the left side at the anterior apex where the cancer is coming close to the edge. That is where we should avoid getting close to the capsule, and the rest everywhere else we can save the nerves. So we have this co-pilot being built in our own program. We have multiple computer engineers working in the department, and it goes through the entire process what we normally go through, and it gives us in a very accurate, very tangible, very actionable detail so as to how to modify the surgery in this particular patient. Prostate cancer surgery in 10 different patients will be of 10 different kinds. One patient will have a wider bladder neck, other patient will have to deal with the median lobe, third patient will have to have a extra facial nerve sparing, other patient will have a hood procedure. So there are many variations which need to be managed to the particular patient's own diseases, and that's what this co-pilot, so this is an AI innovation. Second part, we got to know that the nerves which we are trying to save around the prostate, they are not just single nerves. These nerves are existing with the blood vessels, the fatty cells, the stem cells, the mast cells. They are existing within some kind of a supporting structure, and we call them as in compartment. So if we try to save the nerves alone, we are going to save the nerves, but these nerves will not survive. They will shrivel. And AI allowed us to understand that there are compartments around the prostatic capsule. These compartments need to be saved in entirety so that the nerves are not just saved, nerves are viable. And that may be the reason why there is such a variability in the different programs. Some patients have a function returned within 6 weeks, while the others we are waiting for 5 years. So this is what computer generated, but an AI augmented reality, that these nerves are traveling in a compartment and we can possibly tackle the whole compartment and not just the nerves. Coming on to the actual art of doing the nerve sparing, and I personally think that even an experienced surgeon can get better with an AI interventions. And as you can see, there are many things which can go wrong. We don't get to understand how much of a traction we are putting in, how much of an cautery we are using in, are we using the clip which is crushing the nerves. That all can be combined, and I'll show you a small example of how the good nerve sparing can start, but we can take it to the next level by incorporating some additional tools which I'll show in the next slide. It's literally an operation of delicacy. It's an operation of millimeters. On one side is the cancer, and other side are the nerves. And you have to find the right plane all the time, as many times as you can. And how delicately it is being done, and that's the reason the robot makes all the difference. We could do that with an open surgery, we could do it with a laparoscopy, but when you get down to a delicacy, I think it makes all the difference. But supposing you see the structures with the naked eye, but we have developed a method in which we can actually hydrodissect the whole system around the prostate so that we can see the nerves in much more detail. And there is no coded nerve system in this part of the body that tells us that this is sexual nerve, this is incontinence nerve, this is a prostatic nerve, or this is a bladder nerve. They are not color-coded. So as a surgeon, we have to decide which nerves are important and which nerves are not. And that's what we are trying to add into this equation. So we have done these models in which we can actually dissect it out around the nerves, and these nerves are literally like 3 of your hair. So that makes all the difference between the outcome. So we wrote a paper about how to develop this technique and all those things, and then we developed a couple of AI tools which give us an intraoperative methods for incorporating this diverse surgical information along with the patient's own unique imaging data. So this is what we are doing in an operating room to help the surgeon become a better surgeon. We call it an AI co-surgeon. It is giving all the unique information about the patient. It is sensing the all data point at the time of the surgery. It is looking at the images. It is looking at the MRI. It is looking at all the data points and then telling us where to change, where to tweak it out. So right now we have a tool which can tell us which part of the operation we are in. This is the beginning, and this is what we call, this is the bladder neck dissection happening, and this is the vas dissection. because this will help us in taking it to the next level and possibly having a co-pilot doing the important part of the operation by itself. We will see how it evolves. It can give you the force feedback. It can give you which plane you are in, and surgery sometimes is all about the plane. So it can recognize the tissue and color code that you look like you are in a good plane or are you getting too close to the cancer cells. This bluish changes in the color is because of that. If you're using a cautery, it will monitor that whether you're using too much of a cautery around the nerve or you're using the adequate amount of the cautery. We call it microzapping. You can actually histomap. You take the cancer out and 7 days later you find out that you left some of the cancer in the body, which happens in anywhere between 20 to 40% of the times. If this AI tool can tell you at the time of surgery that tissue which you are concerned about is actually cancer or is not a cancer, is an important tool. So we are training a model right now that area where you are concerned, tumor is about 2.5 millimeter away. You're looking at the other area and you think that you came too close to the capsule and it's telling it's actually a benign tissue. You look at the other area at the apex and you're concerned that are you at the sphincter? This was a benign gland. You can create a zone that gives you a heat map at the time of surgery that are you very close to the cancer or are you very close to the nerve? And based on that guidance, you can tweak it a little bit, one layer on the outer side or one layer on the inner side. This all is happening right now. But most important thing is, can we see the nerves? And these nerves are not exposed outside the prostate. They are hiding in periprostatic tissue, and sometimes they are inflamed. And about 30% of the time, cancer is coming outside the prostate to intermingle with the nerves. So with that background, I want you to see that this is what it takes for a normal surgeon to find the nerves. And nerves are hiding somewhere here. But supposing there is a way that you can color code the nerves at the time of surgery, like green color you're seeing here, and beginning surgeon can also identify that these are the nerves and that can be saved. You can color code the nerves with an AI intervention that where the nerves are, and then you can not damage them. You can float the nerves within water jet so that that's the least traumatic way, and then you can do it when you can see that the nerves are. This is all being done with an AI telling you which structure is what. You can see here that you can actually see the nerves in a greener color. These are all experimental models right now, but we hope in next couple of months or years, this will become in common practice. If this can happen, this will avoid damage, and this is that delicate nerve which we talk about it. Can we save it or can we not? If we can identify it, we can save it. And that may be the reason why we have a good results in most of the cases. We are developing a model in which a model looks at the whole surgery and it predicts what's the likelihood that the patient will do well. Because at the time of surgery, we don't know 6 months later patient will be having a sexual function or not. But if we can train a model which has been done on the 500 videos whose outcome at 6 months we already know, and then can train the model, then it can tell the actions which you're doing are looking good, or you may want to tweak it a little bit here and there, and that's what we need to think about it. So before I summarize, I want to say that the AI models are going to make the surgeon a little bit better by being more prepared. So there will be a co-pilot or a digital twin which will go to the operating room with the surgeon. Second part, in next few years, there will be a part in which a robot will say, hey, can I take over this part? And you don't need to worry about it, dropping the bladder, doing certain part of it, and you just be around to supervise. We do that with the residents all the time. And then the third part may happen, and I'm sure it will happen, that it will be done by the robots. So all that foundational work is being done now, today, by the surgeons in this room, and the technologists, and the inventors, and the dreamers who are in this room, that it is going to happen, and basically it will give an access to almost everyone who needs a surgery, whichever part of the body it is, whichever part of the world they live in. So this is the best equalizer. Thank you very much.
Thank you so much, Dr. Tewari. And it's now time for us to start our inauguration session. I'll just request the SSi team members to please call everyone who's outside so that we can begin in next 2 minutes. May I please request everyone to join us in this hall for the inaugural ceremony? And I would also request people to not step out. We're not taking any break. We now arrive at a very special moment in the journey of SMRSC 2026. The conference has officially opened its intellectual doors, and it is now time to mark its ceremonial inauguration. Ladies and gentlemen, we begin the inauguration ceremony of SMRSC 2026. May I now request our dignitaries to kindly join us on stage for the ceremonial lamp lighting. I would like to invite Dr. Sudhir Srivastava, Shri Aman Sharma, Dr. Naresh Trehan, Dr. Ashutosh Tewari, Dr. Mylswamy Annadurai, Dr. Sanjay Maheshwari, Ms. Neetu Chandra Srivastava, for the lamp lighting on the stage, please. Can you please manage? Thank you so much. I would now request you all to take your seat. As a lamp is lit, we honor the light of knowledge, the spirit of healing, and the collective aspiration to shape a better future for humanity through science, compassion, and innovation. Thank you so much, esteemed dignitaries. I would now request everyone in the hall to kindly rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Bharat Mata ki Jai. Thank you so much. I will also request Ms. Neetu Chandra Srivastava to please join us on stage. I will also request Dr. Vishwa Srivastava to come on stage, please. Can we please call Dr. Vishwa Srivastava? So it's now time for us to introduce you to our guest of honor. So I'll start with Dr. Ashutosh Tewari, Chairman, Department of Urology at the Eisen School of Medicine at Mount Sinai. A world leader in robotic prostatectomy, he has performed over 10,000 robotic radical prostatectomies and is a pioneer in nerve-sparing techniques to improve patient outcomes. He is known for extensive research in urologic oncology and his role in establishing global standards for robotic-assisted urological surgery. Dr. Sudhir, I would like you to kindly welcome Dr. Ashutosh Tewari with a bouquet. Dr. Mylswamy Annadurai, former director, ISRO Satellite Center, known as the Moon Man of India, served as the project director of Chandrayaan-1 and Chandrayaan-2, as well as the program director of Mangalyaan. He is celebrated for his extraordinary leadership in India's space exploration programs and his efforts in utilizing satellite technology for societal advancements. Dr. Sanjay Maheshwari, Clinical Director and HOD, Surgical Oncology, Shalby Cancer Institute, a veteran surgical oncologist with a focus on head and neck cancers and breast oncology. He has been instrumental in bringing advanced cancer care to central India, recognized for his contributions to hospital management, healthcare expansion, and strategic medical innovation. He has played a key role in strengthening clinical infrastructure and patient-centered healthcare systems. Ms. Neetu Chandra Srivastava, National Award-winning actress, producer, and martial artist, an acclaimed actor and producer known for her contributions to Indian cinema and international collaborations. As brand ambassador of SSI, she supports the vision of advancing accessible robotic surgery and promoting healthcare innovation initiatives. A versatile personality in the global entertainment industry and a black belt in Taekwondo, she represented India at international championships. So happy to have you here. Do we also have Dr. Fred Moll joining us, sir? So it's now time for us to welcome Dr. Sudhir Srivastava, founder, chairman, and CEO of SS Innovations, the man who has performed the largest number of robotic cardiac procedures in the entire world, a pioneer who delivered multiple robotic heart surgeries, and a visionary who continues to push the boundaries of surgical science. Please welcome Dr. Sudhir Srivastava.
Good afternoon, just turned afternoon. So first of all, thank you very much. I have a lot of friends from literally around the world, both here in India. I see a lot of prominent people who are here, and great to have all the dignitaries, Neetu, Dr. Annadurai, Ash, Sanjay, and of course Vishwa. Dr. Fred Moll could not be here because of what's going on globally in relation to the flights. Dr. Trehan is tied up in the operating room, and I think the ministers are, as usual, delayed, but very happy to really see so many of you. And this is our third global conference. Every year seems to get better, and really appreciate, first of all, everyone coming. I know people have come from various distances, different countries, so really welcome you all. Welcome all the colleagues and friends who are here, families here, and of course, I will say great thanks to our SSI team. These events are not easy, and also Bharat Mandapam, first time actually we are doing it here. It's a phenomenal facility that actually has been done. G20 is held here, and I think our team has done a great job organizing all of these things. There are always certain challenges that occur, so pardon us for that. And I think we'll have a wonderful scientific program. There will be live surgeries, there will be telesurgeries, and I do have some presentation, but I think, Shruti, what did we decide? Shruti, what did we decide on? Wait till the minister for me? Yes. Yes. All right. I will talk a little bit later, but I think why don't we do this way? Is Gaurav here? Gaurav Sawant? Yes. Yeah, please come. So I think let's do this way. We were going to, hi Fred, good to see you.
Hi. How are you?
How are you?
Good. Congratulations on such a wonderful start to the conference.
Thank you. And I actually, I was being interviewed downstairs and I missed your talk, but Sam Balke was telling me it was great. So thanks very much.
Thank
and
you.
I know with the time differences, it may be late, but thanks for staying up.
No, I'm excited to be a participant in some fashion. So thank you.
Yes. So you will be part of the thing. So we're going to turn it over to Gaurav. Gaurav is a very well-known journalist, and I'm his fan. I watch India Today TV channel, and the best part is I love his debate with his other colleagues. And talked to him this morning. It was great talking to him. So what we thought instead of getting everybody to speak here, Gaurav will raise certain questions and get people to answer and talk, and this way change the format somewhat. So Gaurav, please.
Thank you very much, Dr. Saab. Ladies and gentlemen, good afternoon. I've just had a very fascinating conversation with Dr. Srivastav, and there's so much to learn, so much to share, and we intend taking this forward. Let me begin by just saying, when we speak of Indian doctors, as you know better than I, wherever you go across the world, you talk of Indian doctors and people speak of them so highly. Indian doctors, Indian healthcare workers, Indian caregivers, nurses, Indian hospitals for healthcare, for example, very good healthcare and very affordable healthcare. How are we scaling up medtech, Indian medtech, to that scale and even take it higher? So Indian healthcare story, we are told, is at a turning point right now. For decades, was very import dependent. Right now, it's emerging as a growing hub of innovation. Make in India, make it affordable, make it world class. So the medtech sector is becoming a key pillar of Atmanirbhar Bharat, or self-reliance in healthcare. The global demand is rising. So it's not if India can lead, when will India lead? And here at SMRSC 2026, we're talking about what will it take to make Indian medtech the best in the world. We've had an introduction with all our guests, and let me take it to Dr. Srivastav first. We'll start and conclude with him. His vision. You've operated in the United States of America, in Texas, thousands of surgeries, also through robotics. How do you take all of that in India to the world stage, sir?
I think having been involved with the robotic surgery, particularly obviously cardiac surgery, because that's what my profession and the passion is, and seeing the benefits whereby splitting of the sternum or other approaches, it was great for the surgeons, but not for the patient. And the robot actually allowed us to really take it to the next level, whereby we can do very complex operations through tiny holes. When I was there, 20% of my patients went home next day. 50% 2 days or less, average length of stay 3.2 days, with wonderful results in terms of mortality, complications, etc. And I'm grateful to Dr. Fred Moll. In fact, I think has been said, the robot was originally done for heart, but those are early days, and it did not take off early on and landed at prostate. And so it will continue, but I'm glad that it's there. So when I came back, the idea was to really launch these robotic programs in the country. I started out with the Fortis healthcare chain, but very quickly realized that it was expensive, it was unaffordable for the patients. So really then made a commitment that we must do something, because at that time when I came back to India in 2011, there were only 7 or 8 robotic systems total, early days, and mostly were dust collectors. So we really pushed, we tried to train people, but because of the cost, it was not possible. And I must share this little story with you. Give me 20 seconds.
Of course.
So I had a patient, a 22-year-old female with atrial septal defect, which is a hole between 2 chambers of the heart that normally closes, but in some patients it stays open, and it becomes a problem as they grow, and it can cause issues. And so brother brought saying that if she has a scar in front of the chest, probably won't get married for various local and cultural reasons, except they didn't have money. The brother tried to raise money. A month later, he called me. He was really struggling, and then I never heard from him. And I must say that was the turning point in my life from being a cardiac surgeon, that we must do something to really change that, because money was the issue. Patients could not afford. So literally got involved with the development. It wasn't easy. Entrepreneurial and innovation journey, and then trying to get investment. So very difficult journey, but then the whole idea was that yes, we have the talent in India. And so essentially I was stubborn as a heart surgeon and determined and persisted. And here is what we have. And really, thanks to our SSi team, it is truly an engineering project for clinical use. So I did play a role in keeping it together. But ultimately, I'm very grateful to our young team of engineers who really have created this thing from literally ground up, not even having knowledge about robotics, forget about surgical robotics, but what we have created, we are very proud of truly making India an indigenous robot that is now serving so many patients. And the vision is global, because the same problem exists in so many parts of the world. 7 billion people do not have access. So the whole idea, what I call decentralize and democratize access, and of course, with that, we advanced a lot in how to bring the care to the patients more and more using the telepresence that is available today. So I think I'll stop here and maybe others can get into it.
Oh, absolutely. And I'll come back to you for more on this, on how are we scaling up. Dr. Annadurai, you're seen as the moon man of India. And when you talk of India's space mission, we've done it at a world scale at much less of the price, and it's world class. Can the same be done with medtech in our country? Is it possible and is it scalable?
Yeah, it's very much feasible because the third edition I am sitting consecutively, okay. And every edition I am seeing that medtech means medical science and the technology science, I think putting together. When we go to the moon or Mars, basically we rewritten the planetary science. The people have gone to the moon in 60s and 70s and forgotten to go to the moon. Today the whole world is going more. Today Artemis is around that. Thanks to our Chandrayaan going discovered water on the moon, which no previously people have not done. It's a basically when we did, as Sudhir has told, this is we as young mind. Even I myself was a youngster when we went to the 2008 when our mission was made, and we made very fraction of the money what elsewhere they sent. But still, the innovative way we looked at the moon remains the same. But still, the innovative way we explored the moon, we are able to identify where is the water on the moon. Similarly, we are the first time itself with the fraction of the budget, whatever elsewhere people have done, acquiring the Mars also we have done. That means repeatedly we could show that success and again landing on the moon where previously any one of them had landed, the south pole of the moon, which was considered to be a tough, we have done that. Again, it's a fraction of the amount, but everywhere, Indian mind, the technology we shown to the world. I think parallelly when I'm saying to see here along with the Sudhir, Sudhir has directed the people, as he rightly told, the young mind, they are looking for the opportunity. Somebody said give an opportunity, give the proper guidance and direction. I think these two things done, direction, opportunity, and lead it, definitely they will take it. So that's why, though he is not an engineer, engineering marvel has happened here in India, thanks to the direction he has given, thanks to the conviction he has happened, and thanks to the opportunity given to the youngsters. I think youngsters have done extremely good. Today, young India, emerging India shows to the world convergence of the technology, convergence of the young and elders. Elders giving a wisdom, young is ready to go with energy. I think this is what happening here. This is one of the things, I think very many places I'm seeing, very many things it keep happening. So I am really say, that the elders' wisdom and the youngsters' energy is the India of today, emerging for tomorrow for the global scientist concern.
Oh, so well said, so well said. So you have the brains and you have the youngsters, the youngsters will be guided and they'll take it forward. Dr. Maheshwari, let me for a moment specifically talk of Uttar Pradesh, because Uttar Pradesh has, can also be seen as mini India, has urban pockets, but has massive rural pockets too. And in a place like Uttar Pradesh, if we move beyond Lucknow or the bigger cities, how much of robotics can we see? How will it benefit people in smaller towns, in tier 2, tier 3 cities and the mufassal towns of UP, sir?
सबसे पहले तो मैं आप सभी लोगों की तरफ से एसएसआई और डॉक्टर श्रीवास्तव का धन्यवाद देना चाहता हूँ। मैं खुद एक कैंसर सर्जन हूँ और पिछले 42 साल से मध्य प्रदेश के एक छोटे गांव में सतना में मैंने अपना काम काफ़ी किया। उसके बाद अब उत्तर प्रदेश में माननीय योगी जी के नेतृत्व में हम कुछ काम कर रहे हैं। मेरा ये मत है कि छोटी जगहों पे जब टेक्नोलॉजी आएगी, when technology reaches the smallest of the town and the poorest of the person on a affordable health care, मैं आपको सिर्फ इसलिए बताना चाहता हूँ कि ये ज़रूरी है भारत के लिए। 140-150 करोड़ लोगों को जब माननीय प्रधानमंत्री जी ने वैक्सीन प्रदान किया, तो उससे ये इंडिकेट हुआ कि हम काम कर सकते हैं, बड़े काम कर सकते हैं। जब एक रोबोट जो 18 से 20 करोड़ का है, वो अगर 3 से 4 या 5 करोड़ में मिल सकता है, तो हो सकता है कि कुछ समय बाद हम और उसको सस्ता कर पाएँ। और प्रयास हमारा ये रहेगा कि इस रोबोट को, जैसे कि कवि ने कहा, मेरे को कुछ शेरो शायरी का शौक़ है, तो आपको रखना चाहता हूँ
जी।
रोबोट बिल्कुल प्रभु कृष्ण की तरह है। तो वो कहता है कि न मैं रंग हूँ, न रूप हूँ, न प्रायण किसी आकार का, जो दिखता वो मैं नहीं, फिर प्रश्न क्या अधिकार का। ये बार बार क्या पूछ रहे हो कि रोबोटिक सर्जरी हो पाएगी क्या नहीं। न मैं रंग हूँ, न रूप हूँ, न प्रायण किसी आकार का, जो दिखता वो मैं नहीं, प्रश्न क्या अधिकार का। क्यों निज को संकुचित करूँ, क्यों निज को संकुचित करूं, जो रूप है विस्तार का, जो दिखता वो मैं नहीं, फिर प्रश्न क्या अधिकार का।
क्या बात है।
बार बार ये मुझसे क्यों पूछ रहे हो कि रोबोटिक सर्जरी हो जाएगी या नहीं। होगी, जरूर होगी। और यहाँ पे इतने बड़े बड़े लेजेंडरी लोग जो भारतीय मूल के, मैं पर्सनली बहुत लोगों को जानता हूँ यहाँ पे, और कई हमारे साथी रहे। तो मुझे ऐसा लगता है कि अब प्रयास भारत के विकास के लिए भारत में रह के होना चाहिए।
बिल्कुल।
और जो समय है उसमें 10-15 साल अब अपन लोगों के पास हैं, जो हम लोग 65 के ऊपर निकल गए हैं, तो अब गांव में जाना पड़ेगा आपको। और ये मैं इस पोडियम से इसलिए बोल रहा हूँ कि माननीय प्रधानमंत्री जी और हमारे सभी लोग और माननीय योगी जी का प्रयास है कि गांव तक हम पहुँचें। जब 90 करोड़ लोगों को एक जगह पे स्नान करा सकते हैं, तो हम 140 करोड़ तक रोबोट को पहुंचा सकते हैं।
क्या
बहुत आसान। और बस इतना कह के अपनी बात को यहाँ पे अभी विराम दे रहा हूँ कि अटल जी की उस कविता को ध्यान में रखते हुए जो उन्होंने कही थी कि बस इतना काफ़ी है, अंतिम दस्तक पर खुद दरवाज़ा खोलें, अपने ही मन से कुछ बोलें। अंतर आत्मा से बात करके ये बोलें कि मैं गरीब तक पहुंच पाऊंगा या नहीं। और जिस दिन हम 200 रुपये में गरीब तक पहुंचेंगे, उस दिन ये सफल भारत एक विशाल भारत कहलाएगा। थैंक यू।
बहुत सुंदर। हालांकि जो हमारा फलसफा है, हमारे देश की फिलॉसफी है, हम तो वैसे ही जीवेम शरदः शतम कहते हैं, 100 वर्ष तक सकुशल जिए। तो आपको बहुत लंबी सेवा भी करनी है, केवल ये 10-15 साल नहीं, अभी 35-40-100 साल तो मिनिमम, और ये सेवा जारी रहनी चाहिए। बट लेट मी ऑल्सो कम टू नीतू चंद्र श्रीवास्तव जी, बिकॉज द क्वेश्चन दैट डॉक्टर महेश्वरी पुट टू अस and to all of us here, how do we make it affordable? Because when people may struggle for 2 square meals a day, can they afford robotics, which would be very expensive, and would one accessibility to affordability? Should it be a part perhaps of Ayushman Bharat, that then it's the government's responsibility that it is affordable for everyone?
Thank you so much for the question. ये बहुत बहुत शुक्रिया मुझे यहाँ पे बुलाने का और मुझे ये स्थान देने का, डॉक्टर सुधीर श्रीवास्तव एज अ ब्रांड एम्बेसडर, और सारे डिग्नेटरीज को मेरा नमन। बहुत अच्छा लगा आप लोग की बातें सुन के, एंड गौरव, थैंक यू सो मच फॉर दिस fabulous opportunity. Since this is the first time, I'd like to take a little more time.
Of course.
And I've got some pointers to talk about. It's absolutely an honor to be announced as a brand ambassador of SS Innovation. With this role, I pledge to leave no stone unturned in taking SS innovations from the class to the masses. My journey is from Bihar to Hollywood, and as a former Indian Taekwondo player, a Hollywood Bollywood actor, I have dedicated my career to representing India on the global stage. It is with immense pride that I now carry forward the same mission with SS Innovations. Speaking of Dr. Sudhir Srivastava, he's truly placed Indian healthcare on the world map, and thank you so much for that. Robotic surgery was once a distant dream for the common person. Today, through his vision, leadership, SS Innovations have revolutionized robotic care and made it affordable and accessible for people across the globe. It is in the initiative of Make in India, the SS Innovation is taking this ahead. SS Innovation has pioneered telesurgery, bringing cutting-edge care to people in Tier 2 and Tier 3 cities across India, and it is now expanding this impact worldwide. The name Mantra, MantrAsana, Mudra, Yantra, and more resonates deeply. They are powerful amalgamation of ancient Vedic wisdom and AI-integrated modern medical science, a seamless blend of heritage and innovation that stands as a matter of pride for every Indian worldwide. This synergy ensures accuracy, safety for every patient. And concluding, I will conclude with a quote that truly reflects Dr. Sudhir Srivastava's vision and spirit. As India's visionary Dr. APJ Abdul Kalam famously said, "A dream is not what you sleep in, what you see in sleep. It is the thing that does not let you sleep." This is the dream that has brought Dr. Sudhir Srivastava and the entire SS Innovation team this far, and it is the same dream that will propel us forward. And I think it is a beautiful opportunity for me to be a part of it. Thank you so much. Jai Hind, Jai Bharat.
Brilliant. I mean, that's really lovely to hear you say that. And let me now just take our viewers to the father of robotic surgery. Dr. Moll, you're very fondly referred to as the father of robotic surgery. Thank you for very patiently listening to that journey, and how do you see that journey from its initiation to where it stands in India today, and do you see it being scaled up now so that it can reach masses? It isn't just restricted to the elite, but can perhaps reach those Mufassal towns and be affordable to all.
Well, I think that's exactly right. I'm very proud of what we did at Intuitive, but I think the Da Vinci has two very significant flaws. One is obviously the lack of affordability, which limits access of this technology to many parts of the world and many patients, and I think that is a true weakness. Accessibility is a little bit the same thing from the standpoint it is related to affordability, but this whole new world of telesurgery, I think, which SSi is leading rather than following, is the key to much of the situation we have today, which is the haves and the have-nots of a robotic surgery. There must be affordability, but telesurgery can I think transform the use of robotic surgery and reach millions of patients that otherwise would never have the opportunity to benefit from its capabilities.
True, true. Let me also bring in Aman Sharma into this conversation, sir, as somebody who represents the government, Joint Secretary in Pharmaceuticals. What in your view, needs to be done, one, to scale it up, to take it forward?
He's not here actually. He was here and then he left for
So, yeah, he's just joining us. And okay, I'll take that to Mr. Annadurai because and let me also take that to, Dr. Tewari. In terms of how do you scale this up to a level that the government can assess and bring it to its masses? What needs to be done in your view?
I think the even basic question is it possible to do it in India? Answer is simple, yes.
It is possible. Brilliant.
And it will happen because of three things. We have one of the most caring doctors here. And when they go across into the other part of the world, we are really highest number of Indian doctors in the United States. So doctors have already established that they are very gifted and good surgeons. It is a common saying in United States, it's difficult to get into MIT than to get into IIT. IIT is a more difficult exam to get into, so we already know we have one of the best pools of engineers and IITs people in here. And then the last part is the digital payment system, which was implemented in India, was far better than any part of the world, and it is really scalable. Combine all that with Indian Jugaad, why will it not happen?
Oh, absolutely. When you talk about your experiences, because in New York, you took that bus around in New York, those who were not getting access to the best healthcare, you attempted to reach out to them. You've had an experience that can perhaps be brought back here and can it be replicated? What are the changes that can be made to it so that more people have access to that to medicine?
So even in a very advanced country like United States, there are people who don't have an access, and we created a mobile unit to get to them, to get them tested, and my goal was to reach out about 1,000 people over a few years. We crossed 14,000 men in last 3 years, so it is expanding to 3 different areas in the US itself. That same model can be implemented here also. Only difference is that we have to equip it, and I have seen the mobile unit equipped within your mobile chair, that it can go to the right place, it can have the basic amenities, it can go to the village, and that is how you will get to the point of care. This is the last mile which will be held by this thing. Not only that, there will be telesurgery, but it will be done into a mobile unit. And I think 10, 20, 30 mobile units of one particular area can really take away this discrepancy out of the equation, and it's possible. Only challenge here is, I used to call it million strong initiative. I'll have to change it to billion strong.
The billion strong initiative. And since you mentioned Jugaad, since you mentioned how India was able to do everything, because every story that you see here is story of hope, and to be able to deliver, whether it was the vaccine that you spoke of, Dr. Saab, whether it was the UPI that you spoke of, Dr. Tewari, India has been able to deliver. Dr. Vishwa, is it also because of the youngsters in this country who are willing to experiment? They have the knowledge, they have the skill set, and as Dr. Saab said, they have the guidance. 65 plus give guidance, 25 plus have the hope and the will to do it.
So I can answer this question on 2 fronts. One would be, I can speak, directly on behalf of my team, who we're extremely proud of, and as Dr. Sudhir mentioned, they had very little experience in robotics, forget about surgical robotics, but, and I think that really helped them because they didn't have these blinders. They didn't have these preconceived notions that they were married to. They remained open. It's sort of the saying that, Bruce Lee said that you should always keep your cup half full, right? And if your cup is full, then you cannot put any more water inside of it. So our team remained very open and amenable to be able to work, not only with guidance from Dr. Sudhir and other surgeons, but also to be able to push the boundaries of their own imagination. And without even telling us, one day they'll come up with a new idea and then they'll show us. So one thing is that we really want to remain a science-first company, always pushing those boundaries, keeping in mind that yes, it is for a clinical application, but there's a huge spectrum of applications, and this is something that we hope to unveil during the meeting at this SMRSC 26. Now, from a medical point of view, I think India, has been pointed out previously, has a plethora of very talented young surgeons also. And they all want to come up. I think historically, access has been the biggest issue. Now, if you give them the tools, as Dr. Magan had said, like a warrior needs the proper weapon in order to win the battle. So what we've done now is being able to democratize that, providing it in tier 2, tier 3 cities, because what we found previously is that a lot of these doctors, they come from these smaller cities, they come to the metro cities, they have access to the latest technologies, and there's very little incentive for them to return to their homes. I think now if you look at the majority of our systems across India, close to 200 systems, the majority are in tier 2, tier 3 cities. So now they have a viable reason to return to their homes, to actually help their own communities. And ultimately, surgeons, they want the latest toys, they want the latest technologies. Why? Because in the fast-moving, pace that we're moving in the world today, technology is the one thing that sort of democratizes access to all these things. So by providing them this technology, then ultimately you're providing better care, better options to care. Who benefits most? The patient, whether they be in tier 1 metros or in the villages. So I think that we as a company, we will not succeed until we touch the lives of patients in the villages.
Oh, absolutely. Go ahead. You wanted to come in.
You said the right word, hope. And I'll tell you this, that my grandfather has been a heart surgeon in New York for last 40-45 years. And जब दादा यहाँ से आते जाते रहते तो हमेशा कहते थे कि काश मैं यही चीज़ इंडिया में कर सकता था. And I think hope is the right word. With SS Innovations globally now present, and we are moving in there very soon, I think any surgeon, any specialist globally can take care of all of us whenever, wherever is required. And this is a dream come true for even my grandfather, who's always thought of this. And I'm very proud to be associated with this today. Listening to everybody, every second, I'm just very excited for India and 1.4 billion people to avail this in the remotest part of India. I think the government has to really intervene to see that every corner of India especially has this facility.
I'm glad you spoke of government intervention. We were just having a conversation with Dr. Srivastava on the public-private partnership. And Dr. Annadurai, let me take this to you first. When we spoke of India's space mission, ISRO, with single-minded devotion, was hoping to achieve its targets, but then they took young scientists with them, young engineers with them, so that future generations would be trained. The government supported it. What kind of government support, since you know both ends of the story, what kind of government support would MedTech require and is getting?
Yeah, my experience tells it's both ways. That means you extend your hand, definitely other side also extends. So that means our willingness, our courage, yes, we can go like that. When put forward, definitely government also was equally responding for that, more than equal. I think they are trying to push us, started pushing that also. I think a similar way I feel in this context also. You look at here, the governments also time and again. Education and healthcare is the prime importance of the populace of India. I think that's the time and again people are telling. Education is taken care, and of course both private and governments are helping that we are going. Healthcare is equally important. Especially look at here, the productive age of the Indians is keep going up. We are no longer at 60 years, you are not available. More than, now you look at here, even myself is nearing 70. Okay, I think another 10 more years I can pull on. So that means the productive age of the Indians also keep going up. And even young, the problem is medical science, medicine is concerned, it is not discriminating between the young or disease is concerned. It is not young or old. So that means equally we must be able to serve them. And the productive age means that means we cannot afford the people to be away from the beds for a longer time. So this robotic surgery enables to bring the people to the active life earlier. So that way, look at there, looking at that point of view, government also will try to push it, the medical health care, making the people to be live in a health point of view. Definitely this will enable the way in which it's going, robotic surgery is coming out. One side will keep come down because the populace is going up. As Moradabad itself, he told that how affordability is there. So like that, we have across India, tier 2, tier 3 cities also keep going up. So like digital India, when you look at here, one of the cheapest in the world for the data is India. Correct,
Yes.
no? So that is, though we got the late in the digital cell phones concern, today India populace is enjoying the connectivity much cheaper than anybody else in the world.
True.
No, I think soon, even education also look at here, people getting an IIT entrance is very difficult than that, but like that class of college have come. Similarly, medical science also, we have the world-class hospitals are there, and it's keep penetrating down into the tier 2, tier 3 cities also. So that way, look at here, all the things putting together, definitely the affordability of the also people also will go, and the requirement of people paying more also will come down, and a good number of people around there. So all put together, I think this is Indian model showing the way to the global, how healthcare can be affordable. I think this is the one we will able to tell the whole world.
To scale up and to scale up as much as possible. I want to bring in Dr. Srivastava because we had a very interesting and a very fascinating conversation of a robotic surgery. You were in France and the surgery was carried out in Indore in Madhya Pradesh. Now, if that is possible, how long before that same medtech can enable us to have that kind of surgery that you may be in Delhi or any other part of the country and this can be done, let's say in Arunachal Pradesh or in Ladakh? How does that scaling up happen, sir?
I think it's a great example, and thanks to Mohit Bhandari, who was with me in Strasbourg, and at his hospital in Indore, we did a cardiac case, almost 10,000 kilometers of communication distance, because sometimes when you draw a straight line, it is not that much, but once we realize that it has to go through fiber and under the sea and around the country, it is much longer. And I think one of the challenges that one always faces whenever we are talking of telesurgery, is there a delay? Because any significant delay beyond 200 milliseconds, which is like 1/5 of the second, can cause some confusion. So with the advanced, actually, high-speed connectivity today, it is absolutely doable. You don't even feel the delay, and I know a bunch of people who have used the system and have done surgery. It is absolutely feasible. I think this is what will, and what was the second part of the question?
You know, whether it's Arunachal Pradesh
Yes,
or
right.
Ladakh, and
Yeah.
this is something, I mean, you know, we have Brigadier Saab here. I want to understand that can something like this not benefit the armed forces in a very big way in combat, or even because they're deployed in such difficult areas?
Absolutely. But you see this little covered guy here, we're going to show, and I think it was shown in the movie. So, in fact, I was approached by a brigadier in our office about developing something, and our team just does not waste time. In 2 months, essentially, we created a drone-based technology whereby the robotic arms, and of course, this is really a proof of concept. This is not anything close to the final, but yes, we are working whereby these drones today is very well known. The technology exists. All the capabilities of different payloads exist also. So it's a matter of size and how long the battery lasts. So I think this will be very helpful because in a lot of these remote locations, because of either weather or just not having access or whatever may be the other geopolitical issues, one can really extend this care either in emergency or even electively. So one of our project, Operion, which is a mobile operating unit, it can be, you know, in the bunkers, for instance. And, you know, you may not have all the specialists, but because of the tele capabilities, and either through satellite or 5G, one can actually extend that expertise to, so the patient don't have to be stuck. And, you know, biggest issue always is delayed care and translating into bad outcomes. So I think not only just in the remote location and army, but many times the natural disasters occur, earthquake or floods and landslides, etc., where suddenly you don't have access by road. So I think a lot of these technologies really will help save lives. And that, I think, you know, at least we are pushing whereby, you know, one of these days satellite communication will become more and more efficient and cheaper. So whereby then you have absolute coverage in every part of the world. Right now we are using fiber and 5G is there, and sometimes 5G is not all that stable. So currently we have been focused only on fiber, but I think as this satellite-based communication occurs, this will absolutely change. And I think that will apply also not just these remote areas, Arunachal and so on, but every village and nook and corner of the country or the world. You can give the best possible access using the expertise that otherwise will not be able to. And I think that is the biggest benefit of telesurgery, to extend the expertise. And as Dr. Bhandari had mentioned earlier, certainly, these patients all over the country, we did 24 operations in 12 hours from our office, 9 surgeons operating. Otherwise, any of these patients will have to travel somewhere else. So I think, this is how we need to look at. It's also a tremendous teaching and training tool that you can literally help people in the operating rooms. Young surgeons coming up, you can monitor them, and when they are having difficulty, you can take over and perform the surgery. And I think based on our experience, safety is absolutely never compromised, because we are very diligent about the process. So I think if we keep all those factors in mind, telesurgery really will be the future, I think not just in India, but globally, and I think more and more countries will, if you look at the other continent, Africa, for instance, so I think it is really going to be a global need, and we just have to perfect it.
Oh, absolutely, because our doctors have great reputation, our healthcare givers have great reputation. Dr. Maheshwari, Dr. Moll had raised a very interesting question about affordability, that what's keeping this back to an extent is, the more democratization of this process is lack of affordability. Usko kaise address kiya ja sakta hai? What is the best way forward there so that more and more people can afford to get this treatment done?
मेरे ख्याल से the main thing remains now all on the dais and many of hundreds present here. डॉक्टर रावल हैं, मधु हैं, डॉक्टर गुप्ता हैं, मोहित हैं, मतलब मोस्टली जो लोग डॉक्टर हेमल छोटी जगह से आए हैं हम लोग, और कई बड़े बड़े इंस्टीट्यूट में लोग बाग काम कर रहे हैं. द मेन प्रॉब्लम रिमेन्स कि अफोर्डेबिलिटी का एक बहुत लंबे समय तक ये गाना हमने गाया, भारत गरीब है, ये नहीं है, वो नहीं. अब मिलने लगा है सामान, लोग बाग एफोर्ड करने लगे. आयुष्मान योजना के आने से बहुत लोगों को सुविधा मिली है, लेकिन अब ये ज़रूरी है कि गांव तक कैसे जाएं. तो टेली रोबोटिक, टेली सर्जरी से गांव तक जाया जा सकता है. और मेरा एक इस बड़े पोडियम को जो उपस्थित हैं यहाँ पे लोग, मेरा कहना है आप गांव में आइए. मैं 42 इयर्स गांव में रहा हूँ. 400 की पॉपुलेशन थी पाडर की, जहाँ पे हम करीब 30 साल पहले डॉक्टर रावल से मिले थे, और हमने खूब सर्जरी करी है वहाँ पे. एक दिन में 40 सर्जरी मैंने किए हैं सीधी जिले में. तो करीब मतलब बिना एनेस्थेटिस के. जो अच्छा है, अभी तो इस फोरम में नेताजी नहीं है और IAS ऑफिसर्स नहीं है. मेरा ये मानना है इस देश की डायकोटमी में जब डॉक्टर्स जो काम कर रहे हैं उनको अगर नीति में बैठाया जाएगा तो फायदा होगा. जब तक ये लोग, देखिए जो स्पेशलिस्ट है, मैं मतलब जैसे आप जर्नलिस्ट हैं गौरव, तो आप जानते हैं क्या क्वेश्चन पूछना है. अगर मेरी नीति स्वास्थ्य के बारे में, एजुकेशन के बारे में बनाई जाए तो उसमें डॉक्टर जो गांव में काम कर रहा है उससे तो पूछा जाए. उससे ही नहीं पूछा जाता और नीति बन जाती है. NABH के एक्रेडेंशियल में मैंने ये बात उठाई थी कि जो एक गांव में मैं सतना में NABH का एक्रेडेंशियल लूँगा और मेदांता में जो एक्रेडेंशियल होगा उसमें क्या फ़र्क होना चाहिए. मेरे पास तो पैथोलॉजिस्ट है ही नहीं. मैं हिस्टोपैथोलॉजी कैसे करूँगा? जब नर्व स्पेयरिंग की बात रोबोटिक्स में होगी तो मेरे यहाँ तो पैथोलॉजिस्ट ही नहीं है. और ऐसा पैथोलॉजिस्ट और ऐसे अल्ट्रासोनोलॉजिस्ट हैं जिनको किडनी नहीं दिखती. औरत के अंदर बोलते हैं प्रोस्टेट वेल सीन. मजाक चल रहा है देश में. और ये आज़ादी के 75, 76, 78 और विकसित भारत की ओर जब हम देखेंगे तो हमको इस डायकॉटमी को कम करना पड़ेगा। ये मेरा एफोर्डेबिलिटी है, सरकारें बहुत मेहनत कर रही हैं और ऐसे ऐसे रोबोट, ऐसी ऐसी सर्जरी बहुत हो रही हैं। मैंने एक लेडी के पेट से 66 किलो का ट्यूमर वर्ल्ड रिकॉर्ड निकाला है, वो है मेरे पास रिकॉर्ड। संसार के सबसे बड़े स्टोन का म्यूजियम मधुनोज मेरे अस्पताल में, लाखों स्टोन मैंने जमा करके रखे। इज़ द लार्जेस्ट स्टोन म्यूजियम ऑफ द वर्ल्ड। एक छोटे से गांव में मैंने काम किया है। तो जब हमारे जैसा जो अच्छा पढ़ा लिखा, मैं स्लोअन में भी रहा, मैं एमडी एंडरसन में भी गया, सीखने गया 2 महीने के लिए, उसके बाद भारत में आ गया छोटे गांव में। हेमल इज फ्रॉम अ प्लेस छतरपुर, पूछिए ना कितना छोटा गांव है। तो आना पड़ेगा गांव में आपको। जब आप जैसे अच्छे लोग जब गांव में आएंगे और एक इफ़ेक्टिव टाइम देंगे संसार के उस जन को जो आपकी ज़रूरत को महसूस करता है, तब ये सफल होगा। अन्यथा ये प्रयास शहरों में रह जाएंगे। शहरों से गांव में जाने के लिए नीतियों में डॉक्टर्स का होना बहुत ज़रूरी है। अगर ये नीतियाँ 5 और 7 स्टार होटल्स में बनाई जाएंगी और हम पे थोपी जाएंगी और हमको ये बोला जाएगा कि आपका अस्पताल वैसा वाला नहीं है, तो हम बोलेंगे साहब हमारे पास तो डॉक्टर ही नहीं है, तो हम कहाँ से बनाएंगे। तो मेरा आज सब लोगों के मैं क्रिटिकल नहीं हूँ, लेकिन मैं ये कह रहा हूँ सरकारें बहुत काम कर रही हैं, लेकिन हम डॉक्टर्स को कुछ मदद की ज़रूरत लगती है और वो मदद हमको समय पे नहीं मिल पाती, हम बूढ़े हो जाते हैं। मैंने अपने 42 साल दिए हैं गांव में, उसके बाद मुझे ऐसा लगता है कि सरकार ने मुझे फेल कर दिया। और फिर मैं उन पेशेंट्स को ये नहीं बता पाता कि मेरी जो सर्जरी आधी अधूरी है, क्योंकि मैं तो आज नर्व स्पेयरिंग देख रहा हूँ और मैंने तो ओपन प्रोस्टेटेक्टमी किए हैं पूरी, और क्या क्या उखाड़ा है, क्या क्या निकाला, आई डोंट नो। बड़े बड़े कैंसर, स्टेज 5 के कैंसर, बाहर निकले हुए कैंसर आते हैं, पेट के ऊपर बाहर निकले हुए कैंसर। आप वो 66 किलो का ट्यूमर देखेंगे तो उस पर देवी माँ का आरोप, उसमें ट्विन प्रेगनेंसी के आरोप, कोई पानी निकाल रहा है, कोई पानी डाल रहा है, पता नहीं क्या क्या जादू करते हैं। और इतनी सारी पैथीज हैं, बाप रे बाप। कोई बोल रहा है इसमें नमक डाल दो, कोई बोल रहा है चूना डाल दो, कोई बोलता है हल्दी डाल दो, और हम बोल रहे हैं रोबोट भी डाल दो। मजाक चल रहा है। बट एनीवे, आज ये बात करने का मौका नहीं, लेकिन आपने इस क्वेश्चन को पूछा तो मैं इस के साथ ये भी बोलना चाहता हूँ कि ऐसे टीचर्स लोगों को सलाम है जो डॉक्टर श्रीवास्तव के रूप में हमको मिलते हैं।
बिल्कुल सही कहा आपने। और इन्हीं दो भारत को मिलाने का ये प्रयास और ये मंच की शहर और गांव का वो जो अंतर है वो कितनी जल्दी समाप्त किया जाए और कितनी तेजी से। एंड डॉक्टर तिवारी, when the first surgery was done, the robotic surgery in 2002, it made great headlines in our country. Dr. Srivastava would remember he'd flown in from Texas, if I remember correctly. Dr. APJ Abdul Kalam was there when that surgery was conducted. Dr. Naresh Trehan was there. We had all reported it in 2002. Now we're in 2026. Why hasn't it been able to pick up at the pace at which it should have? What do you think, in your view, since you're looking at it from a distance, what was lacking, what needs to be done, what is being done, and what else can be done?
I think it has picked up reasonably well. I mean, I think considering amount of work and amount of experts which are here in India, we are very proud of it. Yeah, can it go to the scales? Can it go to the periphery? Can it go to the every individuals? That, I think, is a problem not just in India, it's everywhere else. India, it seems more magnified because of the sheer number of patients we can help. And it will happen by combination of efforts which are happening right now, meaning the mindset. Second part, resources. And the resources cannot be generated just by Dr. Srivastava or an industry. And we heard about that there has to be in public commercial partnerships. That is important because still the blessing comes from the higher authorities, the blessing comes from the resources, blessing comes from that this needs to be done, it will get done. On one side, we will make the robot cheaper. Other side, we'll have the training done to the next level so that people can handle, even with the telesurgery, we will need someone trained enough to handle certain things at the other end. That itself is an event. We have to create a more comprehensive network of basics, fundamentals. Before the robot comes, there has to be a bed, there has to be an operating room, there has to be a lab, there has to be a blood pressure instrument, there have to be a sterilization. These are the fundamentals. And all that can be done, but starts with our mindset. And the questions you are asking and everyone is thinking about it, it will happen.
It will happen. Are we, Dr. Saab, before I bring in Dr. Vishwa and Dr. Moll, Dr. Srivastava, are we on the right track? Is it that we need to start inculcating, as Dr. Tewari mentions, that ecosystem right from medical school or college? Is that where it needs to be done?
Yeah, I think one thing I would add, and with due respect to Ash, my friend here, unfortunately, if you look at back, 2002, when I did the first case, and if you take out the SSi Mantra system, which are around 200, we have roughly around 500 systems total in the country. Now, if you take that out prior to our coming, there were only roughly 250, 280 total system for our population, 70,000 hospitals, and even if you take out 70% smaller hospitals, you still have more than 20,000 hospitals. So just imagine at that scale, having only 250 or 280 robotic systems, surgeons don't have access. Patients don't have access. So yes, it has come up, but again, it is mostly has been in the metropolitan areas. And only selected centers do larger volumes. And again, because of the affordability factor, people may buy the robot in smaller communities to keep up with the Joneses or for marketing purposes, PR purposes. But then when patients cannot afford, they may do 3 or 4 cases only. And that is this. So what it has actually done, tremendous disparity. And also, if you take the comparison with the United States, more than 6,000 robotic systems are there, 1/4 of our population. So it is really absolutely dismal. Now, what will change really, and of course, it's very important, and it's not just actually the Indian scene, it is 7 billion people in the world do not have access for the same reason, because monopoly existed, costs were high, people actually were afraid to come up with systems because of sometimes intellectual property concerns, lawsuits of patent infringement, etc. But now all that is behind, and more companies are coming. So I think as we move forward in the next 10 years, there'll be many, many more companies actually. There are almost more than 250 robotic companies today are working. And gradually it will come up. And I really hope someday, as we have done in India, every country will have their own robotic system. Because ultimately it needs to become indigenous and cost effective based on the local environment and factors that are there. Secondly, I think in terms of really taking it further and further, and we have been talking to the National Medical Council people, the government side also, some of our physician champions have gone and talked to them about really introducing this as part of the medical college curriculum, whereby around 4th year or so they can be taught starting out, and then postgraduate program actually continue. So we will, in India, having more than 750 plus medical colleges today, the largest number, we will actually produce a pool of surgeons. Robotic surgeries team, then the entire support staff we will produce. And also with the younger generation always looking, and it is wonderful that because I think it is high time we change the direction of surgery from large incision to literally, and at some point there will be no incision, I think, as a lot of things are happening further on. I know Mohit talked about some of that. So I think, we must become totally patient-centric, because ultimately the only reason patient comes is get better, go back to their previous lifestyle. So I think this minimally invasive, and the robot does provide the best way to be able to do with all the technology attributes. So I think we need to address that. And when we look at it as a project, whereby we have to train people.
Yes.
So not just selected surgeons who have been trained are doing it. And ultimately, when we talk of democratizing, who is going to go and operate in villages because everybody wants to stay in the big cities. So I think when we produce this thing and provide the facility, have addressed the affordability factor, I think we will actually make India a model. That's my personal vision, and I think we will absolutely achieve that, yes.
No, it's a beautiful vision. More people should have access to better healthcare. Dr. Moll, what are best practices that India can look at from the West and adopt, and perhaps not repeat some of the mistakes that may have been made by the West? What is your understanding, sir?
Me?
Well, I think one of the things that has been mentioned, but is a complicated subject. But if you take, if you listen to the surgeons at this meeting, and I think it reflects, a general belief now that's growing that the use of robotics is, results in superior healthcare, that it isn't, for necessarily for the private sector to decide who gets robotic surgery and who doesn't. It becomes a public health issue, and a public health care that should be addressed by public health care policy. And so, I don't think the U.S. has done a great job of endorsing and providing pathways for, yes, there are lots of robots in the US, but there are also a lot of challenges in the healthcare system to justify the use of robotics. And I think it is, to the extent that government policies make it easier to afford and upgrade, current practice to improve generally healthcare. I think it's, it should become public policy, and governments should get involved in solving the problem of access to better technology.
Great. Dr. Vishwa, how do we ensure that Indian medtech is considered the last word? Because by and large, there are times when people say that we are still emerging. What are we doing to ensure that we are the last word?
I think historically, if you look at it, until most recently, India, imported close to 80% of all of its sophisticated medical device technologies. I think that what's required is opportunity, to keep it simple. The talent is here, and they're yearning for this opportunity. We have wonderful universities like IIT and even non-IIT. In our team alone, very few of them went to IITs. But we provided the opportunity. And with that opportunity, we were able to quench their thirst, for knowledge and to be able to create. And I think if you provide that opportunity, then what you'll see is a transformational paradigm shift. And at first it'll start small, as all things do, but eventually, it'll spread like a wildfire over time, and then to the point where we won't even recognize it because we were growing into it. And I think we're at this very, critical stage right now where this mass has been generated, and the only message that I have to give, to all those out there is that if you can think it, you can do it, and as long as that opportunity is provided. So we dug deep, we struggled in order just to provide that opportunity. During the pandemic, we really struggled as an organization. We had no idea how we were going to pay our employees. Our entire senior team came up to us, was like, "Sir, please don't pay us." We said, "No, that's okay. We'll figure it out." And we did figure it out, and we came out of it. So I think that, innovation, entrepreneurship in any field will be difficult, but it's those who remain steadfast who will be able to, come out of the other end.
So that's very heartening to hear, and I will let that be the last word on this part, that if you can think it, you can do it. That is inspiring. I want to thank all our guests for being here and sharing your thoughts and your views with us. We have a couple of minutes. I'm just being told, before our chief guest also joins us once again. So let me quickly take closing comments one by one in a minute from you. And Neetu, you wanted to comment on the closing comments.
Well, thank you so much, Gaurav. And, you know, it's a great example of patriotism when I see it, the journey and the vision which Dr. Sudhir Srivastava has. Last month, I was in Patna. And I must tell all of you guys कि SSI की जो presence है, वो 3 robots Patna में present हैं अभी. And there are few doctors who have returned from different parts of the world, and I must congratulate, of course, the way Dr. Sudhir Srivastava's vision is. I have a doctor returned from London, Dr. Bipin Jha, sitting here, who told me about the whole thing, and I was so proud because I am a girl from a middle-class joint family of Bihar to making it as one of the main leads among 2 girls in Hollywood.
Wow.
And I returned to my country and trying to do my best as an entrepreneur and as somebody who really immensely care for India. And health is, as we say, health is wealth. I am really looking forward for great things for SS innovation, and whatever in my capacity I can do, I will. And that's a promise. Thank you so much.
Thank you very much. Dr. Annadurai?
Yeah, I see one model here, look at here, as Viswa and Sudhir is telling about. This particular model is an affordable healthcare we are able to provide. That too, taking a private entrepreneurship with the young innovators they are given there. So that is, as time and again he told the science behind that. Basically, they enough they spent for R&D. I think I know that last 3-4 years along with them, how the R&D they've grown, and they matured it, and they commercialized it, affordable thing they are able to show, Indian make for the global reach itself. So this is the message, not only for the medical field, I think across India, I think private entrepreneurs should learn there. I think they have, if they invest in R&D, they are going to repeat. Okay, I think this is the very well it is told there. And that is the science is there, entrepreneurship is there, opportunity is there, and you are coming to the global level in the even medtech. Okay, so that means any other technologies, any other field also. I think private entrepreneurs also should learn this thing happen. I think that is the message the whole of India is concerned. As far as I am concerned, coming with them the last 3-4 years, being in ISRO, they are funded by Government of India. But here it funded by Government of India is not there. Only when it is going to penetrate into India, Government of India have to help coming. But otherwise, the mature technology has come. And the mature technology is now even almost awaiting FDA approval. So that globally also presence has come. So such a model, in the even medtech it has happened there. Definitely it is an eye-opener for all the emerging and established entrepreneurs of India. This is a message across. This is what I feel beyond medtech.
Dr. Tewari, you know, because it's very heartening to hear Indian doctors are considered the best, amongst the best in the world wherever you go. And you must have experienced this over decades, but medtech getting there?
I think it is. I mean, I think I will bring in a previous story about space and the robotics, what we are talking about. Actually, this program was initially supported because Department of Defense felt that the NASA and Department of Defense are sending astronauts to space. And one of them will get an appendicitis, and appendicitis cannot be cured just by giving an antibiotic. They needed an operation, and they cannot take the spacecraft back. Their goal was to develop a device which will help in getting this surgery done by Dr. Bhandari or someone of that caliber sitting here in US. That led us to be where we are. But the point to note here is it was funded by the Department of Defense. Department of Defense was the government funding agencies. I have personally gotten a lot of NIH grants and all those things to support what we do. So we need to know what needs to be done. I think we have a good idea on this podium and in this room what needs to be done. Just the affordability shouldn't become the only mantra here. We have to get an access, and the government can help in this process. If they can send the buses there, they can send the vans there, they can send the ambulances there, they can get the robot there. And we will work on our end to make it cheaper, more economical, precise, and possibly smaller.
तो जहाँ चाह वहाँ रहा डॉक्टर महेश्वरी.
Yeah.
चलिए दो लाइनों से इस मेरे वक्तव्य को मैं ख़त्म करता हूँ। साहिर साहब ने और गुलजार साहब ने बड़ी अच्छी चीज़ें लिखी, तो उसमें टेक्नोलॉजी और लाइफ साइंसेस का सिंक किया, तो एक दो लाइन ऐसी बनी कि टेक्नोलॉजी पे पहले ओपन सर्जरी होती थी, हम लोगों ने कई साल करी और छोटी छोटी जगहों पे करी, लेकिन उस टेक्नोलॉजी के बाद अच्छे एनेस्थीसिया वाले लोग आ गए तो सेफ सर्जरी हो गई, उसके बाद टीम अच्छी क्रिएट हो गई तो और अच्छी हो गई, उसके बाद लैप्रोस्कोपी आ गई तो और अच्छा हो गया। वो अल्टीमेट माना गया था कई साल तक। उड़वाड़िया साहब यही बोलते थे कि इसके बाद कुछ नहीं आ सकता, सबसे अच्छा दूरबीन से दिखता है। उसके बाद डॉक्टर तिवारी आ गए तो उन्होंने बोला कि सबसे अच्छा हम दिखाते हैं आपको। तो टेक्नोलॉजी में और लाइफ में बड़ा सिंक्रोनाइजेशन है मेडिकल साइंस में। तो एक और एक दो हुए, एक टेक्नोलॉजी अमेरिका से आई तो दो हो गए, एक और एक दो हुए, दो के बाद तीसरा, आगे आगे सब चले, ना एक है ना तीसरा। एक पुष्प खिल रहा है डाल पे गुमान से, आज रोबोटिक डाल पे गुमान से खिल रहा है। उसी तरह से उड़वाड़िया साहब का लैप्रोस्कोपी भी डाल से गुमान पे खिल रहा था। एक और एक दो हुए, दो के बाद तीसरा, आगे आगे सब चले, ना एक है ना तीसरा। एक पुष्प खिल रहा है डाल पे गुमान से तो एक कोई मिल रहा है धूलकण निदान से, एक कोई जा रहा है तो दूसरा कोई आ रहा है, कर रहा है पीछे पीछे इंतजार तीसरा। जीवन के इस नियम में टेक्नोलॉजी आएगी और जाएगी, पुरानी टेक्नोलॉजी भी रहेगी, क्योंकि जब तक हम नहीं मरेंगे तब तक तो हम वही बिलीव करेंगे हम अच्छे थे। जब हम मर जाएंगे तो फिर दूसरा कोई आएगा। और फिर गुलजार साहब ने उसको इस तरह से रखा, और आपको मैं सुना के अपनी बात को फिर से विराम दूंगा कि जो वक्त है, आकाश जो है, जो आसमान है, जो बादल है, वो टाइमलेस है। यहाँ से देखो तो अमेरिका तक है, तो वहाँ से जब एक बूंद गिरती है तो उसको एक लम्हा बोलते हैं। एक बार वक्त से लम्हा गिरा कहीं, वहाँ दास्तां बन गई, वहाँ पे ये कॉन्फ्रेंस बन गई, लम्हा कहीं नहीं है। सब रोबोटिक सर्जरी अपन लोग कर रहे हैं, तो एक ये दास्तान बन गई। ये आज सिंपोजिया 3rd है और मैं इस सिंपोजिया को ढेर सारी बधाई, और डॉक्टर विश्वा को और उनके पूज्य पिताजी को और उनकी पूरी टीम को, और यहाँ पे विदेश से आए हुए, देश से आए हुए, देश के विदेशी लोग, विदेशी के देशी लोग, सभी को ढेर सारी शुभकामनाएं देता हूँ। और भारत सरकार की, उत्तर प्रदेश सरकार की तरफ से और मध्य प्रदेश सरकार की तरफ से जो भी काम हम लोग कर रहे हैं, उसमें मैं आपकी सहभागिता और ऐसे रोबोट्स सब जगह पहुँचें, ये मेरी उम्मीद है आपसे। और आप हमारी मदद करिए, गरीब के लिए आप सब लोग आगे आएँ। आप लोग अच्छा काम कर रहे हैं, सभी लोग अच्छा काम कर रहे हैं, बस एक साथ मिल के डॉक्टर्स एक साथ मिल जाएं, वो बहुत ज़रूरी है। थैंक यू।
हाउ ब्यूटिफुली सेड एंड सो वेल पुट सर। लेकिन आपके उत्तर से एक प्रश्न आ गया, और वो पत्रकार ही क्या जो प्रश्न ना पूछे। डॉक्टर विश्वा के लिए प्रश्न है, हाउ डू यू स्टे अहेड ऑफ द कर्व, बिकॉज व्हाट यू आर डूइंग is being done across the world. For India to be world class, how do you stay ahead of that curve?
I think to stay ahead of the curve, one, you should never think that, my father has a saying, he says that best is the enemy of better, right? So you should remain humble, keep your eyes, keep your head down, but eyes on the horizon. You do your work, you don't be boastful about it. But one thing I will say is, to stay ahead of the curve, to put on a conference like this, it's not possible without the people in the audience who are curious for an alternative to what is offered today, curious about how they can become better, curious about how they can improve and offer their own skills, right? And this curiosity has drawn in people from all over the world. Here we have people from Ecuador in the back, from all the way from Guyana. They've come here. So, why is because this curiosity allows them to propel, not only their own intention, but their professional goals, ultimately to help people. So to stay ahead of the curve, I think one thing must remain consistent throughout everyone is to remain curious.
remain curious and ensure it goes as widely as possible. And perhaps right here at this Bharat Mandapam, during India's G20 presidency, we were all covering it. The conversation was all about India and the global south moving together. And it's heartening to see in healthcare it's happening in such a big way. Dr. Tewari, you wanted to come in, sir.
Yeah, I want to challenge when you were saying that why we are not ahead of the curve and how can we be ahead of the curve. This is a question for why do we need a robot? Why can't it be a small miniaturized drones which can be put into the patient's body and they will be managed by long distance, and the drone flyers are already there and they can operate. And basically what we are doing in surgery, we are removing, we are cutting, we are clubbing, we are pinning something, we are clipping something. Why cannot we work on a totally different trait of miniaturizing like a drone, small size, going inside the patient's body?
Fascinating. Absolutely. And well, on that thought, wonderful conversation.
Thank you so much, Gaurav. I'll take it up from here. So we have with us Shri Pratap Rao Jadhav ji, Honorable Minister of State, Ministry of Ayush and Ministry of Health and Family Welfare, Government of India, a veteran legislator with deep experience in public administration. He plays a pivotal role in shaping India's integrated healthcare policy and the modernization of traditional medicine systems. He is known for his leadership in expanding healthcare accessibility and promoting the Viksit Bharat vision through robust public health infrastructure. Welcome, sir. And now I will request Dr. Srivastava to formally welcome our chief guest. A big round of applause, everyone. Thank you so much. We also have Sadhguru Sri Madhusudan Sai ji joining us virtually, global humanitarian and founder of a worldwide free healthcare mission, founder of a global mission of service across 30 countries, established Sri Madhusudan Sai Institute of Medical Sciences and Research, India's first completely free medical college. He is widely recognized for his love all, serve all philosophy, leading massive nutrition and healthcare initiatives that provide world-class services to the underprivileged at no cost. We are blessed to have both of you here with us today. Before we move further, I would now request Dr. Sudhir Srivastava to kindly give his presentation.
Sai Ram Sadhguru, Shri Pratap Rao Jadhav ji, very, very humbled, and thank you very much for both of you. And I know Sadhguru is in Fiji, doing more and more charity work internationally, and was kind enough to join us virtually with a lot of busy overseas schedule and time differences. And I know Honorable Minister, you know how busy you are. Flights were delayed, but we are very, very honored and happy to have you here. So I'm going to go through some couple points that probably will be good to share with you in relation to where we have come. So could I connect? All right. So I'm just going to give you some very quick updates, and I know some of them have been talked about. Now we have 200 systems sold, more than 10,000 surgeries have been performed with wonderful results, 160 plus telesurgeries, and in India we have 187 systems, and internationally 13 in different countries. And we have done all kinds of procedures, including almost 500 cardiac procedures at this time, and all of these things in relatively short time. And telesurgery, I think we have talked a lot about it. All different specialties have been covered, including cardiac surgery. And again, wonderful results of all of these things, because I think this will really help democratize the access to so many people that we have been talking about in various rural areas. in terms of new advances, please watch this movie. There is an audio on this one. Can we connect that one? Is the audio connected here? Anybody? Yes? I must thank Naveen. He is our genius AI guy that has created this thing in literally a very short time. When I saw, I was absolutely like, wow. I said, we have to show this one. And just to bring you, Dr. Moll, I don't know if he's still on. We are on NASDAQ, and we did the ringing of the bell last year on June 3rd. And I know I'm not going to get into this thing, but I want to conclude as I wanted to be an engineer. The destiny will have it. Became a surgeon, back to engineering, project, innovation, and entrepreneur. Was it easy? Absolutely not. Was it worth it? Yes. Would I do it again? Yes, many times over, but better with all the lessons that I have learned. And so going through a lot of these journeys, and I won't get into philosophy, but what have I understood all these years? I think we are part of a cosmic symphony of manifestation. Each one of us is an instrument in the field of awareness. Let us be the best instrument to transmit the music of God, to bring about a change for betterment of generations to come, and finally realize the true purpose of the earthly journey. So does it end here? No, it will continue. So very grateful to our team. It's all because of all their hard work and efforts. We're very proud of this Make in India and with the Indian team. So thank you, Jai Hind, and I'm going to turn it back over to Shruti.
Thank you so much, Dr. Srivastava. I'm sure everyone is now looking forward to the launch. But before that, I would now request our chief guest, Sadhguru Shri Madhusudan Sai ji, to kindly speak few words.
Namaste and Bula Vinaka, as they say in Fiji Islands. So while I could not be there in person with all of you on this very important occasion of the symposium, I'm very glad to join you online all the way from Fiji Islands, 11,600 kilometers away. And my respects to the Honorable Minister, Sri Jadavji, and of course our very and all the guests of honor and the participants of this symposium. When I heard about this, I was truly excited because here was a person in Dr. Sudhir Srivastava who, at a point in time in his life when most of the surgeons are looking at retiring after having worked so hard, he decided to quit everything and shift to India from America, lock, stock and barrel, and start a new company of innovation, SSi Innovations, which has built India's first highly capable robotic surgery system. And we are very proud because I visited them in the month of August last year, their head office in Gurgaon. And from there, the next month, he sent me a whole robotic surgery system to our institute, which is a free medical college come teaching hospital. The healthcare is also free. And he did that as a gift to the institution so that more people could benefit, the poor and the needy in the most rural areas. And in November, he himself came and performed the first robotic surgery. It was an ASD closure on a 29-year-old female from the Chikbalapur district near Bangalore in Karnataka. And I would be happy to tell you, Dr. Srivastava, that the lady has recovered well and she has joined us in our hospital as a receptionist because she wants to work for the hospital that saved her and gave her a new lease of life. Thank you. So you're not just doing innovation, you're actually bringing transformation in the lives of people, especially the rural and the needy. I've heard all the talks and all the opinions and comments of the previous panelists, and I'm very, very happy to see that every one of them converges on this one thought that healthcare has to be affordable, accessible, available to the people of this country. As we know, we live in two Indias. One is India, the other is Bharat. And that Bharat lives in villages, in small towns, in small cities, and that's where the need to create accessible, affordable healthcare is paramount. And we as an institution, as you know, we call ourselves as One World, One Family Mission. We are in 100 countries and headquartered in a small place called Mudenhalli, which was the birthplace of Sir M. Vishweshwaraya, the Bharat Ratna, who built dams and reservoirs and brought irrigation and factories and so many technologies to the country in those times. So having this machine here with us and performing robotic surgeries absolutely free of charge for the most vulnerable and the needy communities is truly a feather in the cap of our institute. And we run 16 facilities across 5 countries, 2,000 beds and 35 operation theaters and cath labs. And I think we have only one system right now, but I would look forward to having many more. Incidentally, I'm here in Fiji Islands where we have a child heart hospital, which was built in 2022 and inaugurated by the Honorable Prime Minister of Fiji and the Honorable Prime Minister of India, Narendra Modi ji. This hospital has been serving the children of the South Pacific. This is the only hospital for pediatric cardiac cases. And I hope, as we discussed, that one day I would be able to have a MIS system, SSi Mantra in Fiji Islands in South Pacific, the first one. And we are all gearing up for that. We have all the infrastructure. The communication networks are better now. Telesurgeries can be done. And right now, for remote island nations like this, the issue is to bring missions from across the world because there is no local talent and no capacity locally to perform high-end surgeries. But I think with your kind of systems, this is getting transformed when the remotest areas of the country and the world are able to access the highest quality of surgeries, the high-end surgeries by the best of the surgeons from around the world. And that would be a game changer. It's already being one, but I think in the coming times, it will be a game changer as more and more hospitals partner with you to bring this innovation to the last and the least. And I'm very impressed with the kind of other things that you're doing, MantraM or MantraM, as you call it, the mobile unit, the MantrAsana, the chair, which allows the surgeon to sit anywhere and perform complex surgeries across thousands of kilometers. And the future that you are building on drones and other facilities, the avatar and things like that, truly it inspires me. They say that necessity is the mother of invention, but it looks like in your case, inspiration is the mother of innovation, and you have created so many amazing technologies, and it's a proud thing for India to have a doctor, now a scientist, and an engineer all rolled in one in you, in your personality. And I am very impressed with the team that works behind you, led by Dr. Vishwa and the whole of your facility, which is world class. I've walked through every corridor, every hall of the facility. I've met all your engineers, such young, bright minds. As Vishwa said, opportunities is all they need. They have the talent. And I think with the support of public policy in India, which can help democratize robotic surgeries for the last and the least, and decentralize it. If that help can come from the government, it will go a long way in making it more and more available to the people. I have added another D, Dr. Sudhir. You have done the democratizing, you have done the decentralizing, and I have done the decommercializing of healthcare. And I think if these three Ds come together, wonders can happen. And in decommercializing, not just NGOs, but if governments and similar public policy bodies can all come together, then this could become a dream come true for most of the patients from around the world. I won't take long. I have been very keen observant and also participating in all the discussions. And I look forward to that India, that Viksit Bharat, where the highest quality of healthcare technologies are available to the last and the least. There is that last mile connectivity, and the best of the minds can serve the poorest of the people also, who cannot afford it or who cannot travel long distances to get it for themselves. And that would be truly Viksit Bharat. And I believe that Viksit Bharat should be built on India's original ethos of Sarve Bhavantu Sukhinah, Sarve Santu Niramaya, Sarve Bhadrani Pashyantu, Ma Kaschit Dukkham Apnuyat. May all be happy, may all be healthy, may all see good and auspicious everywhere, may no one have any sorrow. And what you are doing is just that, creating health for all, creating happiness for all, creating goodness through these platforms of innovation, and creating a happier and a prosperous country and the world. And that is the greatest patriotic contribution that you are making. At your age, nobody can guess your age with the energy and the enthusiasm that you carry. You look younger than most of us. And I really wish you that you live really long, live a healthy life, and build more such innovations, such technologies which will solve the problems and bridge the gaps between the haves and the have-nots. As an institute, Sri Madhusudan Sai Institute of Medical Sciences and Research, and the chain of hospitals that we run, we are always there to partner with you, your company, and do whatever we can in our capacity to build the best of the healthcare to the last and the least, as I said, because we believe in the idea of Vasudhaiva Kutumbakam, which was also the guiding thought, ethos of G20 summit. And it means that the whole world is one family and all belong to us, and we are here to take care of each other. I know we still have a long distance to go, but I know in you there is that spirited, not just the doctor, the engineer, the scientist, but a patriot who would take this mission forward. And I'm sure it's not going to be too long before we see such a robotic surgery system available in the tier 2, tier 3 small hospitals as well, not just the big ones, not just the private ones, but in every single hospital. And through capacity building, like medical college that we have, we are already introducing the course in robotic surgeries training, and that would eventually become a course for all medical students to learn. And that's how we can do better capacity building, create that ecosystem that most of the panelists talked about. And that can be done in rural geographies. I think we have achieved what we set out to achieve with the help of the government, with the help of the society at large, and with social service organizations like us, which we call as the tripartite model of Sarkar, Samaj, and Samstha. If we come together, definitely this dream is achievable. So I look forward to many more achievements for SSi the innovations company, as well as all the wonderful people that you have. And I also invite everyone who is there on this forum to participate in such a life transforming, not just innovations, but transformations that are happening through these amazing surgeries across the world. I hope that I could talk to the Prime Minister and the President of Fiji in a week and a half as we celebrate the 4th year of our hospital over here, which has done close to 450 surgeries and more than 45,000 ecos. And I could talk to them. I'm here to set up the first Philips Azurian cath lab, which is first in the South Pacific. Even for the Philips company, it is the first. But because of us, they could come all this way. And I hope that one day SSi Mantra will be sitting here in Fiji Islands serving the people of this South Pacific region, which are so very distant and so very disconnected from the rest of the world because of the huge Pacific Ocean that becomes the barrier. And I hope that someday we will be able to solve more problems for all the people of the world. So with this, I think I would like to conclude and thank you very much for having me here. I wish you all the very best for your future endeavors. And namaste again to Jadhav ji and everyone else who is there as a part of this symposium. Namaste and Jai Hind.
Thank you so much, Sadhguruji. And I would now request Honorable Minister Shri Pratap Rao Jadhav ji to grace the gathering with his kind words.
आज इस मेड इन इंडिया सर्जिकल रोबोट इवेंट, थर्ड ग्लोबल एसएस इनोवेशन मल्टी स्पेशलिटी रोबोटिक सर्जरी कॉन्फ्रेंस में उपस्थित डॉक्टर सुधीर श्रीवास्तव जी, संस्थापक चेयरमैन एवं सीईओ एसएस इनोवेशन एवं आयोजन अध्यक्ष SMRSC 2026, सद्गुरु श्री मधुसूदन साई जी, वैश्विक मानवतावादी एवं विश्वव्यापी निःशुल्क स्वास्थ्य सेवा मिशन के संस्थापक डॉक्टर फ्रेडरिक मोल जी, श्री अमन शर्मा जी, संयुक्त सचिव औषधि विभाग भारत सरकार, डॉक्टर मायलस्वामी अन्नादुराई जी, पूर्व निदेशक इसरो सैटेलाइट सेंटर, डॉक्टर नरेश त्रेहान जी, अध्यक्ष मेदांता हॉस्पिटल, डॉक्टर संगीता रेड्डी जी, संयुक्त प्रबंध निदेशक अपोलो हॉस्पिटल एंटरप्राइज लिमिटेड, डॉक्टर आशुतोष तिवारी जी, अध्यक्ष यूरोलॉजी विभाग आइकॉन स्कूल ऑफ मेडिसिन, सुश्री नीतू चंद्रा श्रीवास्तव, ब्रॉड एम्बेसडर एसएस इनोवेशंस, फिल्म निर्माता एवं अभिनेत्री, डॉक्टर संजय माहेश्वरी जी, मेडिकल डायरेक्टर एमपी बिड़ला ग्रुप ऑफ हॉस्पिटल्स और देश विदेश से पधारे अनेक प्रतिष्ठित सर्जन, वैज्ञानिक, नीति निर्माता, नवाचारकर्ता, राष्ट्रीय एवं अंतर्राष्ट्रीय स्तर के प्रतिष्ठित महानुभाव, अन्य सभी सम्मानित अतिथिगण, आप सभी को मेरा नमस्कार। आप सभी की उपस्थिति न केवल वैश्विक चिकित्सा समुदाय को प्रेरित करेगी, बल्कि भारत की प्रतिबद्धता को भी उजागर करेंगी कि हम नवाचार को बढ़ावा देने, घरेलू निर्माण को मजबूत करने और समान स्वास्थ्य सेवा वितरण को बढ़ाने के लिए भारत सरकार की प्रतिबद्धता जाहिर करेगी। मैं एसएस इनोवेशन के संस्थापक चेयरमैन एवं सीईओ, विश्व प्रसिद्ध हृदय सर्जन, रोबोटिक हृदय सर्जरी के अग्रणी विशेषज्ञों में से एक डॉक्टर सुधीर श्रीवास्तव जी की सराहना करना चाहूँगा, जिन्होंने इस भव्य सम्मेलन का आज यहाँ पर आयोजन किया है। आपका यह नोबेल प्रयास दर्शाता है कि भारतीय प्रतिभा और नवाचार वैश्विक स्तर पर प्रतिस्पर्धा करते हुए देश की स्वास्थ्य आवश्यकताओं को पूरा कर सकते हैं। डॉक्टर सुधीर जी के नेतृत्व में एस इनोवेशन भारत में उन्नत सर्जिकल रोबोटिक तकनीकों के विकास में एक अग्रणी संस्था के रूप में उभरी है। मुझे बताया गया है कि आज यह प्रणाली 190 से अधिक अस्पतालों में स्थापित है, जिसमें अंतर्राष्ट्रीय संस्थान भी शामिल है और 10,000 से अधिक रोबोटिक सर्जरी तथा 160 से अधिक टेली सर्जरी को सफलतापूर्वक सक्षम बना चुकी है, जो इसकी क्लिनिकल उत्कृष्टता, विस्तार क्षमता और वैश्विक प्रतिस्पर्धात्मकता का दर्शाता है। SSi मंत्रा जैसे स्वदेशी प्लेटफॉर्म हमारी क्षमता को दर्शाते हैं कि हम सस्ती, स्केलेबल और विश्व स्तरीय समाधान न केवल भारत के लिए बल्कि पूरे विश्व के लिए विकसित कर सकते हैं। आज मैं विशेष रूप से SMRSC 2026 के एक्सपीरियंस जोन को लेकर उत्साहित हूँ, जहाँ कई अगली पीढ़ी के नवाचारों का अनावरण किया जा रहा है। इसमें एंडोस्कोपी एवं अल्ट्रासाउंड असिस्ट कार्ड्स के लिए सिंगल आर्म रोबोटिक प्लेटफॉर्म, फॉरवर्ड बैटल क्षेत्रों में विशेषज्ञ रोबोटिक सर्जरी आधारित SSi विमाना ओवरहेड इंटीग्रेटेड रोबोटिक आर्किटेक्चर, SSi ऑपरियन AI संचालित रोबोटिक्स को मानव केंद्रित SSi अवतारा ह्यूमनॉइड रोबोटिक सिस्टम जैसे महत्वपूर्ण अत्याधुनिक सिस्टम भी शामिल है। ये सभी नवाचार दर्शाते हैं कि भारत रोबोटिक्स, आर्टिफिशियल इंटेलिजेंस और उन्नत स्वास्थ्य समाधानों के क्षेत्र में न केवल अपनी आवश्यकताओं के लिए बल्कि पूरे विश्व के एक वैश्विक केंद्र के रूप में उभर रहा है। साथियों, मंत्रा का यह प्रयास आदरणीय प्रधानमंत्री श्री नरेंद्र मोदी जी के नेतृत्व में हमारी सरकार के आत्मनिर्भर भारत के दृष्टिकोण को मजबूती के साथ आगे बढ़ाने का और स्वदेशी नवाचार, उन्नत चिकित्सा तकनीकों को सुलभ और किफ़ायती बनाने में महत्वपूर्ण दिशा प्रदान करने का काम करेगा। आज भारत के विशाल आकार, विविधता और संक्रामक एवं गैर संक्रामक रोगों के प्रभाव को देखते हुए समय की मांग है कि सरकारी और निजी दोनों क्षेत्र में स्वास्थ्य सेवा को मजबूत करने और स्वास्थ्य परिणामों में सुधार लाने के लिए मिलकर प्रयास करने होंगे। आदरणीय प्रधानमंत्री जी के सक्षम नेतृत्व में आज भारत में नेशनल मेडिकल डिवाइसेस पॉलिसी और PLI योजना के चलते देश में घरेलू निर्माण को सशक्त हो रहा है। PMJAY जैसी वृहद योजनाएं उन्नत सर्जिकल सेवाओं तक पहुंच का विस्तार कर रही है। आयुष्मान भारत डिजिटल मिशन से डिजिटल एकीकरण को सक्षम बनाया जा रहा है, जिससे टेली सर्जरी और दूरस्थ स्वास्थ्य सेवाओं को बढ़ावा मिल रहा है। PM अभिम पहल स्वास्थ्य अवसंरचना को मजबूत कर रही है, जिससे पूरे देश में ऐसी उन्नत तकनीकों को अपनाने का मार्ग प्रशस्त हो रहा है। साथियों, हम सभी जानते हैं कि आज भारतीय चिकित्सा प्रणाली को वैश्विक पहचान मिल रही है। मैं इस अवसर पर इस बात पर जोर देना चाहता हूं कि हमें आधुनिक चिकित्सा पद्धतियों के साथ साथ अनुसंधान और उपचार के लिए आयुष चिकित्सा पद्धतियों को भी अपनाना चाहिए, जिससे मानव कल्याण के लिए बेहतर उपाय प्रदान किया जा सके। अंत में मैं SS इनोवेशन को उनके अग्रणी योगदानों, पावन प्रयासों के लिए हार्दिक बधाई देता हूं। मैं सभी प्रतिभागियों को एक अत्यंत सफल और ज्ञानवर्धक सम्मेलन की शुभकामनाएं भी देता हूं। हम सभी मिलकर एक ऐसा भविष्य बना रहे जहां भारत स्वास्थ्य, नवाचार और प्रौद्योगिकी के क्षेत्र में विश्व का नेतृत्व करे। धन्यवाद। जय हिंद, जय भारत।
Thank you so much. And before we unveil these two beauties hidden here, we'll just take a moment of recognition, gratitude, and celebration. Ladies and gentlemen, we would now like to have our Lifetime Achievement Awards. To lead this special segment, may I invite Dr. Sudhir Srivastava, and also it'll be great if Minister Sir can give the awards.
So we have a list. All right, let me start out. Dr. S. Tewari. He does not need much introduction for a lot of people, but people who do not know him. He is the big shot at Mount Sinai in New York, leading a wonderful department of urology, and also when we talk about democratizing access, I was with him in Mount Sinai, and they were kind enough to honor, but I saw his setup, saw the bus that is going around literally picking patients actually and doing the screening, and how many positives were found. So great service. So we are very proud of you, and we are very delighted to offer you your Lifetime Achievement Award for your efforts. Congratulations. Next is my dear friend, Sam Balke from University of Chicago. He is professor of surgery there. Sam and I are attached on the hip. He is the successful robotic cardiac surgeon, globally renowned, and tremendous efforts to teach others, travels all over the world. I don't know when he operates, but we're delighted to offer as part of our gratitude in the robotic world for your efforts and all the things that you're doing to train people, your Lifetime Achievement Award. Congratulations. Dr. Sudhir Raval. Now, we carry the same name, and he always bothers me. He constantly tells that I don't listen, which is not true, by the way. But I tell you, he has been our champion from day one. I happened to meet him in one of the meetings in Orlando. He came up to me, I think it was 2019, and then really got involved and did a lot of early work, and why we are here today in a tremendously successful way. So Sudhir, thank you very much for all your support. Yeah, congratulations. Venki. Dr. Venki Manikrishnan, another leader in the field of colorectal surgery at Apollo, and is heading the whole program there. I got to meet him in Belgium on a boat, and we really bonded. He's a very wonderful surgeon. I've seen him operate, and also the vision of what we call democratizing access to telesurgery. So thank you very much, and congratulations. Mohit. Dr. Mohit Bhandari. You know, I must say I've never seen a crazy person like him. I don't know when he sleeps, he operates, flies, and operates again. and he's done the largest number of bariatric surgeries, and we've been really delighted to know you and all the things that you're doing. Congratulations. Dr. Somashekar unfortunately could not be here. It's his actually 25th wedding anniversary, and he's palace on wheels. So he'll be here tomorrow. But so I think with that now, Shruti, I think we should.
We are all ready for
unveil.
the launch, sir. Yes, and I would request Honorable Minister to kindly help us with the launch. So we'll go that side first. Can we please have the music? Presenting to you SSi Vimana. Dr. Srivastava. So it will be great to hear very briefly about Vimana. From you. You have the mic there.
So this was done based on the request from a brigadier who came to our office, I think it was 3 months ago or so. And within 2 months, our team, they don't waste time, they created this thing. Obviously, the drone is purchased from one of the companies in India. And so essentially, we have configured it. Of course, this is purely a proof of concept. It's not fully functional, but you saw that in the movie. And so the whole idea was that it can fly in the battlefield or many other areas whereby access is difficult. And then small robotic arms are attached. There is a built-in camera, and everything will be remotely actually seen and controlled by surgeons sitting wherever. So this will be very helpful in saving lives, soldiers that are injured, and sometimes they don't make it because of delay, or many other situations, earthquake or natural disasters, and so on, that where humans cannot reach, so we can at least provide service and save some lives. So we are very proud, actually. Thank you to our team, actually. They worked very, very fast and hard. Yeah. I think there's one more.
And now we have Kaya.
On this side.
Our humanoid.
Kaya. Who is going to run this one? So this little guy, our team has named it Kaya. We have not made it, so let there be no confusion. We have purchased it with the idea to develop all kinds of programs, and one day we will have our own humanoid, and this is where a lot of things are actually going to head. So Kaya, go ahead. Is he going to say hello?
Yes.
And welcome
Oh,
to
namaste.
SMRSC 2026. I'd like to begin by thanking Dr. Sudhir Srivastava for this incredible platform. My name is Kaya. I am SSi Avatar, humanoid robot. My brain, my voice, and everything I'm learning, that's been given to me by the team at SSi. I can see you, I can hear you, and I can understand you. Today I'm a student, but tomorrow I could be assisting in your hospitals, supporting your teams, and working alongside you. Standing in a room full of doctors and surgeons from around the world, I couldn't ask for a better place to start. What you're looking at is not a finished product. It's a promise, and I intend to keep it. It's an honor to meet you all.
Thank you, Kaya. क्या चीज़? तो ये जो श्रुति कहाँ गई वो हेल्प मी ये बोल रहे हैं क्या ओके तो ये जो है ह्यूमनॉइड है हम लोगों ने बाहर से ख़रीदा है पर अभी हम लोग खुद डेवलप कर रहे हैं और अभी रिसर्च और डेवलपमेंट हो रहा है प्रोग्रामिंग हो रही है ताकि इसको सिखा सकें और बहुत सारे टास्क इसको दिए जाएंगे जैसे आगे बढ़ते हैं हमारी सॉफ्टवेयर टीम इन्वॉल्व है और हम लोग खुद अपना ह्यूमनॉइड बनाएंगे इन टाइम टू कम बट दिस मेनली ये भी जो है सिर्फ यूज़ हो रहा है और ये सारी प्रोग्रामिंग हमारी टीम ने की है इसकी तो ये है इसका अभी फंक्शन तो प्रोटोटाइप है फॉर रिसर्च एंड डेवलपमेंट यहाँ पे और वो जो ड्रोन जो है एरो और विमान वो आर्मी के लिए है बनाया हम लोगों ने पर इसकी बहुत सारी और भी यूजेस होंगी जहाँ पे भी मुश्किल हो इमरजेंसी चाहिए तो उसके लिए बनाया ये उड़ के जा सकता है रिमोटली कंट्रोल कम्प्लीटली और ऑपरेशन वहाँ पे भी हो सकते हैंगे वो रोबोटिक आर्म्स हैं नीचे तो सर्जन कहीं भी बैठे होंगे वो इसको कंट्रोल कर सकते हैं तो मेनली वो इमरजेंसी ट्रीटमेंट्स के लिए अभी बनाया है
Thank
no
you so
questions,
much.
Please. No questions right now.
So we'll just go for the press conference. I will now request Minister Sir to kindly do the ribbon cutting of our Experience Center. I know you have a very, very tight schedule, sir, but we'll be honored. I think we can get down from here. Sir? We'll go here. Yeah, we can go down from here. Ribbon cutting You want to announce what is going to be happening after this thing? Lunch and then split up cardiac and all that. Also, immediately afterwards, the lunch will open up and then we'll split up into multi and cardiac specialties.
Ladies and gentlemen, we request you all to please proceed for lunch. We will be reconvening in the next 30 to 40 minutes. We have some power-packed sessions lined up post-lunch, so hope to see you here back on time. Check.
I have not checked it, but do you have any idea how many people are sitting in the panel?
So five we know of, like 4 moderators and 1 chairperson.
I'll ask them to
Check one, two, three, four, five, six. Check. Check. Check.
Check one. Can you please raise the pitch? Check one. Check one. Sound check. Sound check.
Check one, check. Check. Check one, two, three, four, five, six. Check.
Check one. Check one. Is there anyone operating? Check one. We should tell him, can we call the sound guy to get done with the checking? Because I think he's left for eating.
take. We need to check the mic.
सुन रहा है कोई? ये वाले ऑफ कर देते हैं। मुझे तो इससे बेटर ये लग रहा है अभी।
Check. Check one, check. Can you switch off the podium mics for us? We are unable to do it from here.
थोड़ा सा रिवर्ब चाहिए अपने माइक पे, हल्का सा रिवर्ब चाहिए।
Check. Well, good afternoon, ladies and gentlemen. I'm Akriti Narula, and I welcome you all to this fantastic day. This is just a sound check. Check one, check. Check. Check one, two, three, four, five, six. Check.
Check one. Check one. Is there anyone right now to operate and change? Can you raise the volume? Check one. Check one. Sound check. थोड़ी और. Check one. Check one. Sound check. More, please. Check one. Check one. Check. Check one. थोड़ा और बढ़ाओ. Check one. Check one. Check one. Check. थोड़ा सा reverb दो. Volume कम मत करो. Just raise it. Check one. Check. Sound check. थोड़ा और बढ़ाओ. Just increase it. Check one. Check one. Sound check. Sound check. Low mid center पे कर दो पूरा. Check one. Check one. Sound check. Sound check. This is 1, 2, 3. Sound check. Reverb. हल्का सा reverb दो. 2 points. Check one. Check one. Check one. Sound check. Yeah. Check one. Check one. ये वाले monitors बंद हैं क्या? ये खोल दो. सिर्फ वो चालू हैं, ये बंद है. Check one. Sound check. 1, 2, 3. Sound check. Sound check. थोड़ी सी volume, थोड़ी सी और बढ़ा दो. Check one. Sound check. Good afternoon, ladies and gentlemen. Check one. Check.
Check one, check. Check.
Check, check one, check one, check one. Sound check, sound check, sound check. थोड़ा बेस बढ़ाओ प्लीज इसका. आपने चेंज किया है क्या दोबारा? Check one. Check one. Good afternoon, ladies and gentlemen. This is sound check happening. Check one, check one, check one. थोड़ा सा reverb दिया आपने? Reverb थोड़ा दो. Check one, sound check, sound check. Okay.
Yes, all set. Anji, thanks, same to you.
बस पकड़ किसका नहीं ठीक है इसको प्रेस करके रख कर
पॉकेट नहीं खोली थी चला जाएगा आई थिंक
Good afternoon, ma'am. Can you hear us?
Yeah, good afternoon. Let me increase the volume.
This is just the audio test from hall, ma'am.
No, I can't hear you. Just give me 1 minute. मुझे वॉल्यूम बढ़ाना है. वॉल्यूम इससे बढ़ेगा?
Can you hear me now?
हेलो
Can you hear me now, ma'am?
Yeah, just let me increase the volume. I can hear you very lightly.
Okay, you can increase from the headphone also.
ये थोड़ा बढ़ाना है भैया. Hello.
Yes, ma'am. Can you hear now?
Hello.
Yes.
Okay.
I can hear Sanjay's voice also, and the other mic is from which place?
Ma'am, right now I'm testing from hall. Still
From
lunch.
hall. Okay.
Yeah, still lunch break is going on, ma'am.
Got it. Okay. The volume is clear. I can hear everybody now.
Okay, can you talk to the OT ones?
Sanjay?
यस मैम आवाज आ रही है मैम
हाँ संजय सुनाई दे रहा है.
Yes,
Yes. I can talk to my staff also.
जी मैम
ये मुझे ये एडजस्ट करना है. उठा रहे यूट्रस.
उठा दो
उठाओ. ठीक है. एक तरफ का बहुत प्रॉक्सिमल है, इधर तो बहुत एडिशंस है रे, है ना?
हाँ वो ज़्यादा थे वो निकाल दिया तो पूरा चिपका हुआ था
हाँ. लेफ्ट साइड की तो रिकैनलाइजेबल नहीं है. ट्राई करें क्या फिर भी, है ना?
हाँ देखते थे
पीआईडी बहुत है उसको.
कंट्रोल दे दे क्या मैम
Good afternoon, ma'am. Can you hear us from hall? Ma'am, can you hear us?
Yeah. Are you from the hall?
Okay, we are just testing from the hall, ma'am.
Okay.
We are waiting to over the lunch break.
Good afternoon, ladies and gentlemen. Well, may I request everyone who's outside, if my voice is audible to everyone, I request everyone to kindly come inside and be seated. There's so many vacant chairs in the front rows. Kindly occupy that first. And we're just going to start with both the sessions, both multi-speciality and cardiac sessions. So I request everyone to kindly start taking your chairs, and we'll be starting soon. Thank you.
Hello. Can you hear us? At the Apex Hospital, Moradabad, RGCI or Bhopal, anywhere else? Dr. Rawal, can you hear us?
It घूम रहा latency है
Dr. Rawal?
जी सर.
Yeah.
Okay, this is Dr. Deep Goyal and is Dr. Hemal here. I think I will hand over the mic to Dr. Hemal for your surgery.
Yeah, sure. leg है Deep, Dr. Hemal.
इसमें तो कुछ नहीं आ रही है सर, वो तो उधर से सुनाई पड़ रहा है.
I am just actually, we are sorting out some problem of lag in signals and movement, you know. When I'm moving, it's not moving as it used to be. It stops somewhere like this.
I know people, but I don't know much about that. But I can get surgery started. They're waiting for. Yeah, Alex. Sudhir, you can hear me?
Yes, sir, I can hear you.
All right. So what we'll do, I know you are waiting for us to start, so we'll get started. And where are you operating?
I am in downstairs, sir. Same building downstairs.
Okay. All right. So while
better.
people are coming to introduce how to go with the program, but in the meantime, we can start. Dr.
Yeah.
Rawal, you heard him speaking this morning. He is, the chair and the director of this uro-oncology and director of the hospital Rajiv Gandhi Cancer Institute. And he's going to demonstrate robotic radical prostatectomy. So,
no, sir, I'm
sorry. Go ahead, Sudhir.
I am showing anti-exentation.
Oh, I
It's
see.
a muscle invasive CA bladder.
All right.
So I'm going to show anti-exentation. Already the lymphadenectomy has been done.
Yeah, so the program, okay, that's fine. That's great because that's what we were amazed to see what a great lymph node dissection you are doing for the prostate.
Yes, sir. Yes, sir.
Can someone introduce about the case, Sudhir, from your team? Because,
Yeah, sure, sir.
All right.
Sure, sir. Ashish?
Am I audible?
Yeah, very well.
You are audible, Ashish.
Yes, I would request the audiovisual team to put the case. Please show the case. Is the case visible?
Ashish, we have problem. There's nobody to guide us what to do. So I have taken over the mic and I started the program.
Yes, sir. So I'm here. I'm here. Greetings, sir. Welcome.
Yeah.
Am I audible? And is the slide visible? Robotic anterior exentration with bilateral pelvic lymph node dissection.
Yes.
Okay. So Dr. Rawal is sitting at Bharat Mandapam, and I, Dr. Ashish Khanna, along with Dr. Nikhil, we are at Rohini with the patient at Rajiv Gandhi Cancer Institute, RGCI. This is a 55-year-old female with no comorbidities. She has a recent history of hematuria, and on the basis of a CECT, we were able to determine that she has a bladder mass. She underwent TORBT, and that has come out to be a muscle invasive bladder cancer. So the CECT showed a 6 centimeter growth on the left lateral wall of the bladder, and a PET scan has confirmed that the disease is localized to the bladder. So I think on the CT it is very appreciable that there is asymmetrical thickening of the left lateral wall of the urinary bladder with intense uptake, and there are no significant pelvic lymphadenopathy. So she is planned for a robotic SSi Mantra telesurgery, where we'll be doing an anterior exentration with ileal condu with bilateral pelvic lymph node dissection.
Excellent. Thank you, Ashish, for telling us about the case. It's all
Sir,
right.
as you know, inauguration was getting delayed, so I asked Ashish to do the lymphadenectomy. I could have done from here also, but I was busy with the exentation. Oh, sorry, inauguration. So already lymphadenectomy has been done here.
Sudhir, Sudhir, let me. So why don't you explain us what you have done, and you can show those anatomical landmarks. It's beautiful what we can see from here.
Sure, sir.
For
Sure,
audience,
sir.
it will be very beneficial.
Yeah. So right now I am struggling with the signal problem here because when I move my hand, it's not moving smoothly. Anyway, I'll show you with my left hand. This is the external artery. There's the vein, external vein. You can see that.
Very well.
Yeah. So there's the obliterated umbilical artery. Here, there's the ureter. So it's actually right now there is a lag. They are sorting it out. So.
All right. So Dr. Rawal has, you can see very well they have done the dissection on one side. And Dr. Rawal, we have two legendary figure in the audience from the United States, Dr. Badri Koneti and Dr. Murli Manohar. So these are the giants in the bladder cancer surgery. So while you start, quick question I'll ask Dr. Koneti and Dr. Murli. Can you tell us what is the current concept regarding the lymph node dissection? Should we be doing extended lymph node dissection or standard after randomized controlled trial? I'll give it. Because there is some issue in the telesurgery, so while they are fixing it, so we thought to start question answer.
It's not working well.
Yeah,
it's not working well.
Thank you, Ashok,
Moving as
and
it should.
good to see such a lovely dissection that they've shown on the screen. And you bring a very good point up. You know, in the past, the idea was we would do a very extended lymph node dissection, and that was important for survival. And we would go up all the way to the IMA and also clean out all the presacral nodes. But now there have been 2 randomized clinical trials, one in Germany and one in the US through SWOG. And both of them showed that there is no added survival advantage to going beyond the bifurcation of the iliac vessel. So beyond the common iliac, there's no point in dissecting that out. And more importantly, in the US SWOG study, the random arm that was randomized to doing the extended node dissection actually had more deaths. There was a mortality rate of 3%, which for a variety of different reasons, but it was more shocking. So I think we have all given up doing that extended node dissection that goes to the IMA, but I still do clean out till the common iliacs at least. And I don't know.
Thank you, Dr. Coretti.
Yeah. If I can just add, all the cystectomy surgeons used to take pride in doing extended lymph node dissection before. It's changed completely. In addition to what Badri said, we are also started using the ctDNA to guide us the stage of the disease and the PET scan. So I'm doing like more of a disease-based and a patient-based. I don't go beyond the bifurcation. Just started at distal common iliac and do that.
So the ctDNA, how does it impact deciding regarding the lymph node dissection in?
We are actually we are part of one of the studies we are doing at the moment. Yeah. We do the ctDNA beforehand and preoperatively, and do the surgery postoperatively, do it as well. Our studies have shown that if the ctDNA is in a negligible or a lower level, none of the lymph nodes have come back as positive. So we are going to use that as a thing to see whether we need to do more dissection or not. So the ctDNA is going to change the way we're going to manage many things. Neoadjuvant chemo, adjuvant chemo, how we are going to do the surgery, etc.
Thank you. Thank you, Doc. Yeah, that's why I'm trying to get. All right. Can we speak to the Her Health Hospital, Bhopal? Can you hear us in Bhopal? Audiovisual team, can you connect us to Bhopal, please?
Am I audible in the hall?
Yes, we can hear you.
Okay, hi, good afternoon, everybody. I am Dr. Priya. The patient is at Her Health, Bhopal, and we are attempting a tubal recanalization.
All right, what is the indication for doing that? For audience purpose. I'm just asking because the audience would like to know what you are doing.
Vasopressin here.
Yeah.
So this patient is a para 2 living one. She had a laparoscopic tubal ligation. यहाँ पर vasopressin थोड़ा. So she had a laparoscopic tubal ligation and unfortunately lost one of her children. And now she has come for a reversal of the tubal ligation. So this हिलाओ नहीं अभी uterus को.
Excellent. So on I think on your right hand, right hand screen, you are watching the tubal recanalization. What have been told by Dr. Bhave that this lady had lost some, maybe now they are trying to do a recanalization of the tube. What we are seeing on the Moradabad, Apex Hospital, Moradabad, can you tell us what you are doing, sir? Can you hear us?
Hello.
Yes, we can hear you.
Very good afternoon to all. This is Dr. Leena Mehrotra. Am I audible there clearly?
Very well.
Yeah, good evening. So today I'll be demonstrating this telesurgery of robotic hysterectomy. This is a multi-paras lady, 45-year-old with previous all 5 normal deliveries, and she was troubled a lot with her abnormal uterine bleeding. She had taken multiple hormonal medications, but she was not relieved with the treatment. So finally, she was planned up for surgery. Her ultrasound showed an adenomyosis in the uterine wall, and the uterus size was slightly bulky. So starting with the steps, I had started the surgery. So we started with the resection on the right side, and this is, you can see, I have already dissected on the right side. We have conserved the ovary, and we are sacrificing the tube along with the uterus.
Can we ask you a quick question? What's your plan? Yes. Are you doing a total hysterectomy, radical, or subtotal? We don't know anything. So
It's a total robotic hysterectomy with bilateral salpingectomy.
Okay.
And we started with the port placements initially, and I am using 3 robotic arms right now. And the main camera port is around 2 finger breadth above the umbilicus. And the secondary ports, they are lateral to around 10 to 11 centimeters lateral to the primary port and around 3 centimeters below that horizontal line. So total of 3 robotic ports and 1 laparoscopic port, which is a 5 mm port to be used by my assistant in between.
How do you start step 1? Which ligament you go first?
I'll just demonstrate it on the left side. Can you please move the uterus onto the opposite side? Yes, there is a vaginal assistant, my team, a gynecologist from my team who is sitting at the vaginal end, and she is moving the uterus with the uterine manipulator. And here you can see, because we are planning to sacrifice the fallopian tube, we'll be starting our dissection from the lateral attachment of the fallopian tube and conserving the vascularity to the ovaries. We have to remain closer to the tube. And as we proceed here, I am using the 2 instruments that are being used here on my right side. Right hand is the expert seal, which is a bipolar shears, and on the left hand is a grasping forceps.
Very nice.
Just starting with the dissection here, just coagulating and cutting with the same instrument. That is a big benefit with the expert seal, that is the bipolar shears. I am remaining, yes.
This is a robotic bipolar shear, that's what you are saying, am I right?
Yes, yes,
So
it's a robotic bipolar shears.
It's an ultrasonic device.
Yes.
Okay.
Lina,
and your
this
goal is you are trying to save the ovary and you are trying to divide the fallopian tube, am I right?
Yes, I'm just separating the fallopian tube right now, and then we'll proceed with the round ligament dissection and the ovarian ligament dissection.
Dr. Goyal, please.
Lina, this is Dr. Deep Goyal. Fantastic.
Good evening, sir.
Hi, how are you doing? Just a quick question for the sake of audience, since you are doing telesurgery. How are you feeling? What's your feeling at this point of time? Are your movements being translated immediately, or there is a lag period? What's going on in your mind?
So I don't feel any lag here right now. I'm comfortable, and I feel whenever I'm moving the instrument, the instrument is moving simultaneously there on the patient's abdomen also.
Perfect.
The only thing that I am missing is the sound of the cautery that we hear when we are inside the OT.
Right.
Otherwise, I'm comfortable doing it.
Perfect. So that's I think for the sake of audience, this is something which is, if you have a good internet connection, there is hardly any lag period. This is what is required. And also, I think it's important whenever you're doing telesurgery that you have a equally experienced team present at the place where the patient is there, in case of any mishappening or in case of any untoward scene circumstances, that team can take over.
Yes, sir. Definitely that is required, especially in the evolving time of telesurgery.
So, Dr. Mehrotra, before we go to the another screen, can you tell us why you are using an ultrasonic device? Why not use a bipolar? You have a scissors, so you can use a monopolar scissors because this will.
Yes, sir. Yeah. We can use both the instruments. It is your comfort, whatever you want to use. I had used in my earlier times when I started with robotic, I was using monopolar and bipolar only. But now with the availability of this instrument, I feel more comfortable using it.
Got it. And do you think what size of the blood vessels it can control?
So I think...
No, because this is some of the... I'm not talking about this particular robot. It's difficult to control the blood vessels which are 5 millimeter in size. It's very good up to 3 millimeter, although they claim it can be good up to 8 millimeter. But in the reality, it's not that true. That's the reason I asked this question to you.
So I feel it is up to 5 millimeter. It is okay using this instrument because while dealing with the uterine artery, we are comfortable using this expert seal.
I see. All right, because that's good point. Good to learn from you. But the most of the places, what I hear for the uterine artery, people like putting a one hemolock clip. Then you can use it with the bipolar energy, whether you are using a ligature or the ultrasonic device, whichever energy source you want to use.
So I have never used a clip in hysterectomy. I have been comfortable using this instrument. Even if you talk about conventional lap also, a normal bipolar instrument is good for the uterine artery.
Lina, what about what kind of consent have you taken from the patient?
So the patient is definitely counseled about the surgery, how we are planning to proceed with it, the telesurgery part of it that is required. A patient should be always be counseled about it, and the patient consented for it.
Is there any other legal requirement which, as a surgeon, we need to or you need to, fulfill, like licensing?
Deep, I think we can come on legal question later on. Let's focus on the surgery. Can you connect to Rajiv Gandhi? Back to Rajiv Gandhi. Dr. Rawal, can you hear us? Audio-visual team, can you connect to Rajiv Gandhi, please?
I think he's not doing the surgery. I just.
They started doing. All right. Or you connect to the Bhopal.
Yeah, am I audible, sir?
Oh yeah, Dr. Bhave, go ahead, please. Tell us
So,
what you are doing.
So what I'm doing is on the right side, if you could notice, I have established the patency of the proximal end of the tube, right? And I have visualized the lumen on the distal end. Now, this is not a very great case for a recanalization.
Okay.
That is because, can you see, the cornual ends are very much thickened.
Right. So
what he is injecting here is vasopressin.
I see. Initially, I thought you were injecting the saline because some people, they like injecting saline so you can do a helpful in the dissection.
We inject little bit of vasopressin because we don't like to coagulate the mesosalpingeal vessels.
Right,
यहाँ पे
right,
थोड़ा
right.
सा करेंगे. बस.
And what dilution you use?
We use 20 units in 100 ml and we will use hardly 10 ml of that.
And what size of needle is this?
Now this is a very interesting thing. What you can see here, it's called easy view. Okay. Now easy view is called as VVIN, visual vasopressin injection needle. Can you make out that the thoda needle ko andar lao? हाँ. Can you make out that the proximal end is transparent?
Right.
Okay. So when we aspirate, nikalo needle nikalo. So in case when we are injecting vasopressin, we never want to go intravascular. In case we are going intravascular, when we aspirate, there will be blood.
Right, right.
But if it is a steel injection needle, by the time you realize it, there could be blood in the lumen, but because it's of steel, you will not realize. So this innovation is by Dr. Sanket Pisad. Dr. Sanket is a gynec surgeon. As gynecologists, we have to use VVIN very often. We use a lot of vasopressin in our myomectomies.
So my question to you, when you put this needle at that time, there is no, because there is no fluid there. So if you try to pull, there may be blood even in the peritubal tissue also, there may be some amount of the blood.
No, we always bring the vasopressin up to the tip of the needle and then only inject. And while aspirating, see, mesosalpinx is very vascular.
Right.
So in case there is blood, then we don't proceed with injecting the vasopressin. Now, can you make out, although the robot does not give us tactile sensation, but this is a very thick, very fibrotic proximal end. I'm not very happy with this.
Right.
But you have to work with what you have. So this is the lumen on the proximal side. Now, if I was doing a laparoscopic recan, the instrument change is very quick. So I would have done an anastomosis on one side and then prepared the segment on the other side.
How do you figure out that you have reached to the normal lumen?
See, one is that you could see as she was injecting methylene blue, there was a jet. Most of the fibrotic tissue has been removed and this is the normal circular nice lumen that you can make out.
So you are relying on the cognitive view or anything else you can do?
We can sometimes put a cannulation set, but all of that we have abandoned doing long back. Now because of the excellent magnification, we don't put any. So in the era of open recanalizations, we used to put a wire through it and then make out and see if that comes out through the other end. We don't do that anymore. Some people at the end of the recanalization do like to inject some saline or methylene blue and see, if it is coming out.
But by that time, it's a done deal.
Now, if I show you, as I cut. Can you make out? Can you see this pouting?
Yeah,
These
yeah.
folds? Yeah. So there's absolutely no doubt that this is a normal patent lumen.
Sure.
And now, say a patient of recanalization might have a proximal block, but there is usually no reason for them to have a distally blocked tube. Right? So in this patient, we are not going to play with the tubal mucosa too much by inserting wires or catheters or whatever. We are going to put mesosalpingeal sutures and bring it all together.
Right.
So now he'll change the instrument. Meanwhile, if there are any inputs from the audience or any advices.
Can we ask question?
Yeah,
In the
yeah,
audience?
of
Yes.
course.
Yeah.
So Dr. Priya, excellent demonstration. Now we can see this this patient is having a pelvic inflammatory disease, and you have ensured the integrity and the patency of the proximal end. So would you like to check the patency or integrity of the distal end as well?
Hi, Farin.
Hi, ma'am.
Farin, as you can make out, not a very great case for a recanalization.
Yes, I can see.
In fact,
because
you know,
no,
if
I just
she
wanted to
conceives,
ask
I
this
would
question because there are very few gynec who are sitting here, and I can see many a surgeon who are sitting.
Right.
So
So
just
we
wanted to
could
put this
a
body.
catheter and see, but I think I would rather do the anastomosis.
Perfect.
On the right side, the fimbria looks fine. On the left
Yeah.
side, it looks a little agglutinated.
Okay.
But as I said, not a great case for
Not a
recanalization.
great case. Yes, sir. We can see. We can see this.
Now, in case there was no proximal patency, I wouldn't have proceeded.
सीधा कर दे सीधा दिखा दे
Correct.
दिखाओ बस ठीक
So many times, if you want, you can just put a pediatric,
Control
what you can say, infant feeding tube from the proximal end and check the connection from the fimbral
Yeah,
end
we
to
used
the
to
other
do
end.
that
Yes,
when
we used to
we
do
would
that, all
do-
these things.
Yes, yes.
But
In
thank you so
fact,
much,
there
and
was
it's
a
looking
time-
fabulous, ma'am. It's the way you are demonstrating and the way you are doing it. Thank you so much.
Farin, what has been your experience? I know that you have done quite a few cases with another platform.
Yeah, ma'am.
What are your tips and tricks for recanalization?
For recanalization, though it looks a very simple surgery, but this is something, it's a result-oriented surgery, you can say. So, minimal access surgery gives you a good hydration, doesn't allow this tissue to become dehydrated, and very minimal tissue handling, and you can perform good suturing. That's the best part, because in laparoscopy, taking this suture, what you are taking from 6 o'clock outside in, is very difficult. And sometimes you can have a cut through also. So I hope you're using 5.0 or 6.
Yeah, so this is for the mesosalpinx. For the
Yeah, for the mesosalpinx approximation.
I think Farin, game changer is the triangulation. We
Correct,
all
ma'am.
are ipsilateral surgeons.
Yes.
So one of the sutures, it becomes very difficult to take in robotic.
No, ma'am. Excellent demonstration, ma'am. Thank you so much.
Thank you.
All right, while you are doing that, can you tell us what sutures and what needle you are using for the mesosalpinx and what kind of suture you use for the anastomosis?
I'm using a 5.0 vicryl for the mesosalpinx. And I'll be using a proline 5.0 for the anastomosis. I don't like to use a multifilament suture. There are some people who use even barbed sutures. Farin, do you have any experience with that?
No, ma'am. Frankly speaking, the barb is of no use in recanalization at fallopian tube. Yes, urologists are using in ureteric anastomosis. I have seen them. But here, what you need is good margins and tension-free approximation so that this will heal nicely.
So the barb suture should not be used for the small lumen. Number one, because these are braided suture, and the barb suture they can damage the mucosa. Because the barb suture they have a kind of a pin on either side. So the unilateral barb suture or bilateral barb suture. So usually most of the people they prefer using a monofilament suture. Monofilament suture because less friction. So if you use a vicryl suture, it's a polyglactin. Again, it's a suture is a so it's not a monofilament, it's smooth suture. So for anastomosis, monofilament is preferred for, especially what I learned from, I don't do personally, but I'm just trying to tell you based on the literature. So for the ureteral implantation also, you can use any suture. Ureteral implantation is not a problem. People can use a bicural suture, can use a monofilament suture. But when you are doing a reversal for a vast difference, or you are doing this kind of reversal, preferably one should use a monofilament suture.
तो पकड़ ले एक ही throw दे. I agree because
Yeah.
you don't want to damage and
Right.
cause any inflammation inside the lumen.
Right,
because-
absolutely right.
पकड़ लो. नहीं नॉट को नहीं उसको एंड को पकड़ ले.
Can we go to Moradabad? Audio visual team, can you please connect to Moradabad?
ट्यूब तो नहीं लगानी.
Dr. Malhotra, can you hear us?
Yes, sir.
Can you tell us what you are doing?
So I've just dissected both the lateral attachments, which include the round ligament, broad ligaments, everything, and now I have reached till the uterine artery.
Can you
The
show
uterine
us? No, just see, it's not for the audience sake. I'm asking you. Can you
Yes,
show us
yes.
where is the round ligament you divided, where is the broad ligament you divided, and you separated the ovary also. So just to
Yes. So this part of the uterus, this is the round ligament which was attached to the lateral pelvic wall.
Right.
And then we proceed with the complete dissection of the broad ligament from the cranial to the caudal end.
Right.
This way. And we have completely separated the uterus from the lateral attachments. Then we reach till the uterine pedicle. And we've just coagulated the uterine artery pedicle. And now we are planning to open the vaginal vault.
So
now I'll be asking my assistant to introduce a vaginal tube from below that will help us in making the vault more prominent and will help us to open the vault.
So
They are just yeah.
we have divided the uterine artery. How do you take care of ureter at that part? How do you figure out okay, we are not very close to the ureter?
The main thing is that we should remain as close to the uterus as possible. And we normally at the level of the uterine artery, we remain at 90 degrees to the uterine surface. So, and this is the way how we safeguard the ureter. Ureter is normally around 1 to 2 centimeters away from the uterine artery at this point, but remaining perpendicular to it and closer to the uterus is the main thing. This is now you can see the vaginal vault which is being, there's a tube which has been introduced through the vagina to make it prominent here. And this is where I'll be giving my colpotomy incision.
So what kind of a vaginal probe you are using? Any balloon or cone or dilator?
No. It's a simple cylindrical tube that we use after ETO. And it is just a cylindrical tube, that's it. And we just push the vault with here you can see the bulge here at the vaginal end. This is the vaginal tube which is pushing the vault up.
Any landmark where you divide and why you divide there?
Normally it is at the level of the uterosacral insertion on the posterior surface of the uterus. So normally we cut from here and we can easily do the colpotomy from this side. But at times we use the vaginal wall. The vaginal wall will just push the vault area above. It will become prominent and we can just, this is the area where we can just give a nick and open here.
Right. Very nice. Sorry?
So just opening the vaginal vault here and about to open. I'll just, this is slight pressure on the vessel.
So Dr. Leena, excellent demonstration. I can see you're using a bipolar and energy to cut open this vault. I think previously we were discussing this is ultrasonic energy. So this device is a electrosurgical unit energy. And how comfortable you are by using this bipolar device on cutting the vault, or would you like to change your instrument with a monopolar at this
if at times it happens that when you are not able to open the vault using this bipolar instrument, we can always use a monopolar which will just give an incision over the vaginal tube.
Okay.
I didn't want to change the instrument, so I'm continuing with it right now, but
Perfect.
definitely we can always change it.
Very nice, ma'am.
बेटा थोड़ा सा ट्यूब पीछे कर लो संजय पीछे
Yes, ma'am.
बस thank you. So
Okay.
I've just marked the area where I'll be able to open the vault and proceed with this instrument. this is the uterosacral at the posterior end.
Right.
So normally at the insertion of the uterosacral, you can open the vault.
So do you plan to do any kind of sacrocolpopexy or anything else in addition to that?
Normally, we always suspend the vaginal wall to the uterosacral ligament so as to avoid any future possibility of enteroceal formation or vault prolapse. So while suturing, we'll take care of the uterosacral ligament. We have just opened the vault here, you can see.
Yeah.
Yes, sir.
And that is the vaginal tube which is there inside. Now, once it is open, we get very comfortable because we just have to remain close to the cervix so as to preserve the vaginal length also. We have to give a good vaginal length to a lady for her sexual activity in the future. And just remaining close to the cervix, I'm just opening the vault, complete vault now.
Ashish?
Sorry?
No, not you.
Okay.
Can you connect to Rajiv Gandhi, please? Dr. Khanna? All right. I think we are not able to hear. Can we go back to Bhopal? Dr. Bhavek, can you hear us?
Yes, sir.
All right.
Very well.
Can you tell us what you have done so far? And
so unfortunately, sir, the proximal end is very, very thick. As I'm doing the anastomosis, I'm not really happy.
Sure.
Because it does not look like a healthy cornual end at all. Now, in this situation, one thing could have been that we just abandon it. But because the tubal length, the residual tubal length is okay, and the proximal end is patent, so we are still going ahead. But we have to remember that this patient might have a little higher risk of ectopic pregnancy.
no,
So
the question
these
you said.
patients have to be told that, you know, the moment they conceive, we have to check for beta HCG doubling. And but essentially these are fertile women. So sometimes even with not a great anastomosis, not a great tubal length, we do see pregnancies. Also, you know, it gives you multiple chances at pregnancy. I could have done an IVF directly for her, but that would be one and done. So if she conceives in one cycle, fine. Otherwise, they have to go through the whole process again. Here, they are able to take multiple chances. Cut. एक ही काटो.
So you are planning the anastomosis or you are not planning?
No, I'm doing it. I've taken the first stitch.
That's what I.
Yeah.
And this is a proline suture you are using, or what kind of suture you are
This
using?
is proline. I think.
What size proline?
5 लिया है ना नरेन?
5.
5.
But and the suture you are taking through and through means you are coming inside the mucosa, not the seromuscular. Am I right to say that?
Lumen. But I have always believed in going through the lumen because this is proline. It's non-reactive monofilament suture. And sometimes over this mucosal layer, I might take a couple of seromuscular sutures also. There are some people who don't take 4 sutures. There are some people who don't take the lumen at all. Now here, can you make out? It's nicely through the lumen, this suture, but the proximal end is very thick because of probably PID, and it just cut through.
Any question from audience or any comment from the audience?
I have a lecture wherein I have beautiful videos wherein the proximal end is very nice. The parity of the two lumina is very important. If the two lumina are similar, then the anastomosis is going to be very good. If it's very thick lumen on one side, cut through हो रहा है वो.
So do you think, if you have exercised more tube, then you might have reached to the normal area and...
There's no normal area.
I
The
see.
entire tube is very thick.
Okay.
The closer we go to the insertion of the tube, the more is the bleeding.
Yes, ma'am. Okay.
So I think this where we cut, we were able to see the dye coming out.
Yeah. Right, Dr.
Most
Priya,
of the-
in this particular condition, you are doing a fantastic job because this right side tube, proximal end, looks edematous, fibrosed, and whatever best we can do surgically, this is what you are doing right now.
Parind, what do you think is your experience on modular arms versus platforms which have which are multi-arm mounted on a boom? Have you had a chance to try these multi-arm platforms, modular platforms? Cut kar do.
What I can say, like once you have docked completely and once you are inside, it doesn't matter. And how comfortable you are, and especially here you're using two arms. If you're using your third arm as well, at that time you may need some more ergonomically, placed ports and other things.
But
as
for
of now,
recanalization,
not required, not required. I'm not saying.
correct.
I'm not saying.
In what cases do you actually use the other arm?
Practically, I'm using in my all cases. I'm using my fourth arm, just because to have a better control in the during the surgery, so that I'll have to depend less on my assistant. My assistant does the job of suction and irrigation, or just giving my needle and other things. So,
but in simple hysterectomies also, do you
everything, madam, I'm using because that gives me a better control and a faster movement.
Okay.
Yes.
Yes.
Meanwhile, if we want, we can go to Moradabad and can have this.
Sure.
Because the chairperson was asking about the question of wall suspension, sir.
Yeah.
So in gynecology, in benign cases, this is our technique of doing intrafacial hysterectomy. What Dr. Mehrotra is showing is like we keep ourselves inside the fascia and what you can say medial to the uterine artery. And you can see there's a lot of white tissue medial to that. And this white tissue is a fascia. If you suspend this fascia to the vaginal mucosa, the vault is suspended nicely. So this is what she's trying to say, that she wants to tuck the vagina to the uterosacrals. So basically, uterosacral is a ligament which is extended from cervix to the vagina. So having a good uterosacral gives you a good suspension, sir.
So it all depends on the what kind of age group is the patient. Depends on the because the pelvic organ prolapse, you are trying to prevent the pelvic organ prolapse. Also, if some patient they have an incontinence, I don't know. I mean, I'm just trying to throw the question. I'm not a gynecologist.
Yes, sir.
But I'm trying to keep audience engaged.
Yes. I can say we are, both of us are interacting so that the audience can listen to us.
Yeah. So let me ask you this way. So when you are doing a hysterectomy, this is a young woman. But if you are operating on the 75-year-old woman, she also has, in addition to that, some degree of pelvic organ prolapse. It can be anterior also, it can be posterior also. What you would like to do?
See, as a gynec, I would like to really quantify what kind of defect she is having.
Right.
So one is, we have got 3 compartments in the pelvic organs. One is apical prolapse, another is rectoencystocele, which is second level, and third is urethra, which what you are saying is SUI, and other legs perineum. So anteriorly, first 3 centimeters from the introitus is a third level segment. So we quantify what kind of defect this patient is having. Every level of defect has got a different treatment options.
All right. Yeah, go ahead.
Yeah. So every level has got a different treatment options. So in this particular case, what we can see is we need to suspend the apex, which is practically a suspension of the vault. So this is what Dr. Leena Malhotra is trying, that she's going close to the cervix so that she can preserve fascia as much as possible anteriorly as well as posteriorly. So this will really gives us a very nicely suspended and a thickened vault. Less chances of having vault dehiscence later on as well. So Dr. Leena, are you listening to us? Yeah, perfect.
Yes,
so
I can hear you.
We want to hear it from you, madam.
Jay. So I'm right now at the lateral left side of the uterine pedicle. I've just cut it, and now I'm trying to complete my colpotomy. And this is the anterior part dissection that we have done, just joining it on in the center basically. And once we are done with the complete separation of the uterus, then we'll remove the uterus through the vagina. The assistant down there will just pull it out.
No, wanted to just put this word that what you are doing is something going into the fascia and taking some time, because many of them can feel that once the vault is open, you can just chop it off all around. And by chopping it off all around may not give you a good fascia to suspend this vagina.
Can we stop conversation for now? And we are going to go to the podium. So now there will be presentation from the podium. So, yeah, please go ahead.
Thank you, sir. Please.
Well, good afternoon, ladies and gentlemen. I'm Akriti Narula, and joining me is my co-host Kamal Homi Mistry, and together we will be guiding you through the remaining proceedings of the day.
Well, ladies and gentlemen, a very warm welcome. What a powerful start we saw. We saw such an amazing, remarkable inaugural session where we brought together distinguished faculty, innovators, and pioneers in robotic surgery. And now, carrying this momentum forward, we now move into a thoughtfully curated agenda for the day. We begin by understanding one of the most important shifts in modern surgery, the transition from laparoscopic to robotic techniques. I would like to invite on stage for this session Dr. Mahek Bhandari from IRCAD India, Indore. Ladies and gentlemen, can we please give a round of applause? And let's welcome also to lead us throughout all the sessions. May I also invite on stage our chairperson, Dr. Ashok K. Hemal. I request you, sir, to kindly take. Oh, so you're already there. So sorry, sir. Please stay back. And may I also invite our esteemed moderators, Dr. Amitabh Singh, Dr. Deep Goyal, Dr. Rupender Sikon, Dr. Nisha Kapoor, Dr. Abhishek Jain, and Dr. Narasimha Srinivasan. I request all of you to kindly join us on the stage.
Yeah, so good afternoon, everyone. So warm welcome to all the delegates, the chairpersons, and I'm thankful to the organizing committee for giving me the opportunity. And specifically, Dr. Sudhir Srivastava asked me to deliver a talk that how I transform my journey from a laparoscopic surgeon to a robotic surgeon. So I'm Dr. Mahek Bhandari. I'm from Indore, and having greetings from Indore, and this is our medical school where I work, Sri Aurobindo Medical School. and I am also a vice president in IRCAD India, and I primarily work at Mohawk Bariatrics and Robotics. So I have nothing to disclose, but I work with these all people, and they are the consultant to these all agencies and the companies. So now the conversation has changed because previously in some tier 3 cities and in some rural cities, robotic was not that much popular. And in some other tier 1 cities also, some other hospitals, the people are not knowing about robotics, or only just the laparoscopy was being practiced. But now it is the routine practice for all the centers to offer. I always talk to my colleagues and my other juniors who have just joined recently their own hospital or some other corporate hospitals, that what all kind of patients you have. So they always say that now the patients are also wanting that they want to get a robotic surgery done. So people are asking about it. So definitely robotic has got a future ahead. And because you can understand that long back when the senior people must be truly relying on what I am saying, that in the long back when there was an era of open surgery, and then gradually laparoscopic surgery became very, very popular with a keyhole or with a kind of a setup which you can just do the surgery with minute 2-3 holes. And then now the robotics has also come because of its particular articulation, ergonomics, and digital integration. So I'll come to that later. Nowadays, the robotic platforms are very well available in India. Maybe the Da Vinci, SSi, Versius, or now the Miso or other robotic companies have also come. And so just for the introduction, robot is just a machine. It's a machine which can do some complex actions. And it has got better visualization, then good clear communication. And there are smaller incision, like there are 8mm ports which are available, and I just got to know that SSi people have just developed 5mm instruments also, and they are in the process of making 5mm ports also. And better range of movement, as I always say that as you can see my wrist, I can just move my wrist like this only, but a robot is a pivot joint, so there's better range of movement and better and broader range of movement which is there with the robot. Greater dexterity. With if you want to do some surgeries longer, then you can stand and you can operate. So as you can see that now the robotic platforms have been created in such a manner that you can stand, you can operate, you can sit, you can operate, you can have rest between the surgery. So it all depends on how much the surgery would be lasting. And you can all do the complex actions because truly speaking, robot is a machine. So if you are doing in an abdomen or anywhere where it's a thick tissue, but robot is an arm, it's a mechanical arm, so it can overcome that particular thing, and it can overcome the thickness of the abdominal wall. And now you can control your own camera. Now the 3D, 4K, and the ICG is all integrated in the robotic platform. So the commonly used robotic platform which are available are the SSi Mantra 3.0, which is an Indian-made robot, and the CMR and the Da Vinci with good degree of movement, then good processing, and there are no tremors which are being filtered because it's a machine again. There are no tremors which can be felt with a good magnification 3D effect. But there are challenges in robotic surgery because there are some ethical issues in some rural areas. People do ask that either you will be operating or the robot will be operating. It's a common question which is there in the remote area or the rural areas. Then there is a cost involved in that because it's a costly machine. There is still full autonomy to be made because you have to have an assistant with you if you want to do a robotic surgery. So always, mind you, be prepared to say that it's a robotic assisted surgery. No surgery is just a robotic surgery. And you are doing such a good job by the robot, but the superiority cannot be demonstrated. So why robotic was needed? Because of the good vision, of the good visualization, and the ergonomic advantage and safety. So I'm just showing you a small video as to understand that how beautifully you can understand the robotic movements happen. So this is a gastro J which I did for a gastric outlet obstruction, and you can just see that how beautifully the suturing can be done from the robot. It can take the movement at any part, at any style you can hold the needle, at any angle you can go and you can do the suturing. So how beautifully it is looking, because there are good joints there and which can make our movement very, very easy. This cannot be achieved by the laparoscopic platform. So what I meant to say is that this is just a small example as to how the movement happens in a robot. And that's why I always say that it has got a very good usage in some complex surgeries also. So now, who should do robotics? Because this is the main topic, and how I transform, I'll be talking. So you should do robotics when you have a good laparoscopic hand. So people, if you think that in the US now they have started giving training to the residents just on a robotic platform, but I particularly feel that you should first know how to do the laparoscopy well, and then only you can go for a robotic procedure. And you have to have a high volume of cases, because if you are a if you are a surgeon and if patients come to you, then if you are a high volume center, then only people will ask for a robotic procedure for you. And who should wait? The people who are still mastering their basic laparoscopy in this era in India, where the seats have increased. Now the workload has decreased to the residents. If the young surgeon, if he wants to do robotics, but he has got less hand in conventional laparoscopy, so he should wait, because there has to be a foundation for doing robotics. Then when you should start, when you feel that you have got good hand in the laparoscopy and your hospital also is also supporting you, because mind you, it's a costly equipment and your hospital has to bear the cost. And so that's why you have to talk to your hospital that we have to purchase a robotic platform, because now the workloads had increased and patients are asking for it. So how to get yourself trained? So it has to be a structured training. You have to first go to the simulation labs, maybe for any platform which you are purchasing. You have to go to the company centers where you can do some simulation, do some dry lab practice before going to the actual patient. Then do some good observership of more than 50-100 cases. Then a good proctor who has done a lot number of cases, and gradually you will progress. So the infrastructure development, always remember, you cannot place the robot in any damn surface, because truly speaking, in some older hospitals where the plinth is not that heavy, I have seen that there are cracks when the robot was placed, because robotic is a very, very heavy equipment. It is not that small equipment that it has got no weight. So there are 4 or 5 arms, and then the surgeon console, and then the vision card. So everything has got a weight, and if your setup is not ready for it, so you cannot place the robot in any setup. Then again, the table, the size of the OT, everything is very, very important if you want to place a robot or start a robotic program at your institute or your hospital. Then you have to have a good team, because truly speaking, again, for robotic, as I told you, it's a robotic assisted procedure. So again, your team has to understand the instruments, the ports, how to do the 3D, how to do the white balance. Everything is different from what you see in laparoscopy. You have to continuously tell them, teach them, everything you have to do by your own. So you have to train your nursing staff, the OT staff, the paramedics, the anesthesia people, because if you are doing because I am a GI surgeon, so if you are doing a ventral hernia, you're keeping the monitor at the other side, then how the anesthesia workstation would be placed, everything has to be in place, and then only you can start a program at your institute. So this is a small video which I have created for my staff, in which the audio is available in this. Okay. So in this, you can see for the robotic cholecystectomy. Some more things which you need to know on the SSi platform or any robotic platform. That once you have placed the patient in a 30-degree head-up position, you cannot change the position of the patient. In a robotic program, whenever you are doing such surgeries, once the patient position has been placed, you cannot change the position, because once you have docked the robotic arms into the ports, you cannot change the patient position now. And the position should be fully table down. These are the two main things which you have to adapt while doing any robotic surgery for that. So I'll just run through, because what I was just trying to say is that I have made some small videos for my OT staff, just to tell them how this was a long video, how to like place the ports, how to bring the instrument or the robotic arms near to the patient, and not to change the patient position, what kind of table you have to do a robotic surgery. So after this all, then you have to do a lot number of cases, and you have to keep in mind that you have to create a center for excellence. You have to publish papers, you have to write papers, you have to do some clinical trainings, you have to call people from outside to make you see that, see, I am doing robotic surgery like this, so that they become your marketing people. Those students or those particular doctors will come to your place, they'll see you, and they'll tell to their own hospital or their city that this particular surgeon is doing robotic surgeries. So you have to do a good number of workshops, then you can start fellowships, because you need to have people to do a robotic platform, to do a robotic surgery. And you have to collaborate with the companies and make the people aware that you are the surgeon who is doing a robotic surgery, and you have to do these all things to call yourself as a robotic surgeon. So there's a good learning curve also, but still after learning the robotic surgery, still you have to tell people and you have to show your work, and then only you can become a robotic surgeon. So it was my journey. I did my MBBS way back in 2002, then I did my MS, then DMAS in endoscopy, then PhD, and I'm still studying. And during my transition, when I was doing laparoscopy, I was not able to do the docking and all. I was not at all able to have the controls, because you don't have the tactile feedback with the robot. I used to like break the sutures and all. So I had some issues when I was getting the transition, because there's a learning curve to it. And what had happened that my brother, Dr. Mohit Bhandari, he has been my mentor, and he was the one when I was starting my robotic journey, because in my city, there are not much robotic surgeons. So he told me that if you want to have your names in, like, if you want to call yourself that you have got something different, then you have to practice the robotic surgery. So this is my first video where I did my surgery individually. I was doing a robotic fundoplication, and what I did is that I had put all the ports, I brought the surgeon console there, and then I called Dr. Mohit to the OR, and then he was standing with me for 3 hours, and then he was seeing me doing the surgery, and he was telling me what all wrong things I am doing. So you have to have a very good mentor with you to just tell you that what all things you are doing wrong, what suturing mistakes you are doing, how to give the throws when you are doing it, and always remember he'll scold you that what all bad things you are doing, because I used to break sutures also. In my first case, I broke around 5 sutures. So in a nutshell, what I meant to say is that you have to have a very good mentor to teach you, and then only you will be able to like have your good hand in the robotics. So why I think the robotic is the future, because now there's a natural progression. Now it's the time of telesurgery. Right now also we are seeing people are sitting here at Bharat Mandapam, and the surgery is getting done in their respective cities. So now this telesurgery is the thing which is there with the SSi Mantra people. And I was fortunate enough to demonstrate a telesurgery in July in the IMAS conference. And I was sitting in a center and the patient was somewhere else, and I was able to do the surgery. And I was able to interact. That's Dr. Adnari, if you people are knowing, he's a brilliant surgeon. And then when you do the surgery, you have to publish your work. So this is the paper which I had published, and it was accepted. I published in 14th of August 2025, and it got accepted at 8 February 2026. So this was the India's first telerobotic surgery done by me for hernias. And again, there was a time when I was doing a IRCAD course and I had no time to practice at my other facility at Ratlam city. So you can see in the night time I was sitting at the IRCAD India Center, and I was doing the surgeries in Ratlam. So my team went at Ratlam city, and I was doing the surgery sitting at my own training center at Indore. Then now, as you have seen that the SSi people have created a bus also, in which you can do the surgery sitting in the bus. You just need a good internet or the MPLS line. So some Iraqi surgeons had come at that time to our city, and so the SSi people had brought this bus to our hotel, and I was sitting in the bus, and I was doing a hernia surgery, and I demonstrated it to the Iraqi delegates. So now they have created such kind of a platform. This bus, I think, is parked right outside the venue also. Then this is the time of office telesurgery. Like, you can place the surgeon console in your office and you can do the surgery because it's all happening now. Now is the time for MantrAsana also. Now you can place that particular chair also in your office and you can do the surgery. So I did a gastric bypass sitting in Indore at my office, and the patient was here in Gurgaon. So I did the office surgery. So this is a small video of a MantrAsana which is placed in the office, and the surgery is getting done at Delhi in Gurgaon. So for the telesurgery, you have to note that you need to have a good MPLS line, and because it's again a robotic surgery, so there are good benefits out of it. And this all has happened because of an Indian company, SSi, and kudos to Dr. Sudhir Srivastava for making it happen. And so for the conclusion, robotic is no longer the future, it's the present now, and you need to learn this technology because it is coming up. People will be asking for it now, and this era has already begun. But when we will lead it, this we have to decide. Thank you everyone for the patient hearing. This is my team with which I work. Thank you everyone.
All right. Thank you.
Thanks, Mehak, for a lovely, talking about your journey.
Yeah,
And I've seen Mehak when he was in diapers. And so it's very nice to see you. But just a word of... Sorry?
Yeah.
Just a word.
Quick.
Just a word. What is Mehak? As I was asking when telesurgery was happening, what legal aspects you look into when you are embarking on a telesurgery?
Yeah.
From the point of legal safety.
Yeah. So, see, you have to convince your patient first. There is a consent of 18 pages, sir, which the SSi people have given us. You have to tell your patient that we'll be doing a tele-robotic surgery. Then before starting the surgery, because I know a lot of software things, so you need to have to check the latency. So the latency has to be less than 30 millisecond. And for longer distances, more than 900 kilometers, it has to be less than 60 millisecond. So right now also, when they have placed this MantrAsana, I went downstairs because I have done cases on that. So I checked that the latency was around 57 seconds. So if it is below 60, then only you should attempt a telesurgery. If it is more than that, then definitely you will be having that lag.
Thank you. Thank you, Mehak.
Thank you everyone for the patient hearing. Thank you.
Mehak, two comments for you.
Yes, sir. Yes.
You said if patient is asking for the robotic surgery, that should not be criteria for doing robotic surgery.
Okay. Yes.
Patient, they do not know what surgery. It is our duty. It behooves
Yes.
on us as a surgeon. So that should not be the criteria. Patient is
Yes.
asking for robotic surgery, which is why we should do. Number one.
Yes.
Number two, laparoscopy is not necessary to transition to robotic surgery. I'm doing robotic for almost 25 years. Dr. Kunete is here. In US, most of the surgeons, they were open surgeon. And
Yes,
they
yes,
directly migrated from open to robotic surgery. So that's not necessary
Okay,
that you
sir.
got to be a laparoscopic surgeon. Also, when you are learning the robotic surgery,
Yes.
it's a laparoscopic component otherwise also required.
Yes, sir.
Like
Yes, sir.
You are placing the port, so it's a part of a laparoscopic surgery.
Right, sir.
So
Right.
it's an advancement of the laparoscopic surgery. But great talk. Thank you.
Thank you.
Do I have the liberty to ask one?
Yeah, yes, sir,
Mahek,
please.
Wonderful. I have seen your entire transformation. Just wanted to ask one thing. How important is it to have an equally competent surgeon on the OR
Yes, yes.
when you're doing a telesurgery?
For the telesurgical setup, sir, because of the consent that which I was talking about, in that it was clearly written who will be the backup surgeon there. So if at all there is some problem, there is some internet connection, it is lost, so the backup surgeon can very well take over it and can convert it to a laparoscopy. So you have to have a very good surgeon there at the other side also.
Okay, thank you so much, Doctor, for sharing that with us. And sir, I believe Dr. Leena has concluded.
Yeah, before we go to the next, can we go to Moradabad, then to Bhopal, then to Rajiv Gandhi? Let's go to Moradabad first.
Dr. Mehrotra, can you hear us?
Lina, can you hear us?
Sir, yes, sir. Good evening, sir. Again,
Hi,
I'm
we're
back.
just waiting for your final comments.
So I'm done with the complete surgery. Hysterectomy done. Then we have sutured the vault with number 1 barbed suture. And we have suspended the bilateral uterosacral ligaments so as to give a good suspension to the vault. And hemostasis has been checked and we are finally done.
Thank you. Congratulations.
Thank you so much,
Thank
sir.
you, Lina. Thank you.
I would like to thank the SSi team for giving me this opportunity. Thank you so much and congratulations to all.
Thank you. Great work. Let's go to Bhopal.
Yeah, thank
Dr. Bhave, can you hear us?
Yes, sir.
All right. Give us a final word, what you want to say, then we can move on to the next.
All right. So I'll just show you the anastomosis on both sides. Antivert kar dijiye.
Antivert.
Yeah. So this is the anastomosis on the left side. Very happy with the luminal parity, good mucosal. This thing we took only through sutures, 2 mucosal and 1 seromuscular. Right side, this is the final anastomosis. We took couple of serosal sutures also. There is a lot of luminal disparity, but the fimbrial end looks slightly better on this side.
Right. So
on the left side, the anastomosis is good, but the fimbria look agglutinated. So we did try injecting the dye, but there is only a very slow trickle on the right side. Left side, there is some fimbrial agglutination which we were trying to release. So that's all from us. We hope that this patient conceives, but we are not going to give her a long trial, maybe 3 to 6 months with ectopic precautions. If she doesn't conceive, she goes for IVF.
But left side, the patency was good with the dye, that's what you were saying?
Right, there is a trickle. Left, the dye is crossing the anastomosis. And here there is a little bit of fimbrial agglutination here.
So how do you
So
see
we'll
the
try
dye?
and release that with the scissors. Scissor de den. Yeah.
All right. Thank you, Dr. Bhave.
Thank you.
Thank you very
sir.
much.
Thank you very much.
It's a tough case, but you did a great job. Thank you so much.
Thank you so much. Thanks.
Can we go to
Right,
Rajiv
Mrs.
Gandhi,
Sikar.
please?
Suction kar le tab.
Dr. Sudhir, can you hear us?
Yes.
Yeah, Dr. Rawal, sorry for trouble. What we heard. That's so. You are back to the speed, or is still any issue?
No, some issue is there, but it is better than before.
Excellent.
And we are using now MantrAsana, which we thought we'll not use it because only problem with this is that vision is very good. It's 3D, excellent vision. But then when your head moves, the whole of the field moves.
Right.
So that's a bit awkward. I don't know how will this, sort this problem out. But I have taken, by the time I have taken the left pedicle completely, ureter and all and frozen I have sent. And I'm going to take right side pedicle.
Sure.
Already I have taken the infundibulopelvic ligament and मैं कर दूंगा आशीष. And the uterine anterior,
Right.
this obliterator umbilical
Yeah,
artery
we saw the
and uterine,
superior umbilical artery.
Yes.
Hemolock.
So I am taking
Extra
now
large.
ureter, taking ureter now.
Right. All right, so Sudhir, we'll let you go and we'll have a second presentation, then we'll come back to you. But we are watching you live, okay?
Sure, sir, sure.
All right,
Please
take
go
care.
ahead.
Well, ladies and gentlemen, before I get down to the next session, I would like to request all speakers to please strictly adhere to the timelines provided. Also, in case you have any questions regarding the session that takes place, please note down your questions and we will address them during the panel discussions. And now, moving on to our next session of this afternoon. From evolution to application, we now look at a precise and fantastic robotic case. Our next session is robotic mesenteric cyst excision. Please join me in welcoming Dr. Abhinav Sonkar from King George's Medical University, Lucknow for this session. Can we please welcome him with a round of applause?
Thank you, Anchor. I've been waiting for a long time for my time to come. Post lunch also. Thank you, Chairman sir, Hemal sir, Deep sir. And would also like to take this opportunity to thank the organizers, especially Professor Srivastava sir and my friend, his son, and attention to details and logistics, everything has been impeccable. My gratitude and my thanks to you. I've been greeting from King George's Medical University, Lucknow. And I'm a novice, as Dr. Hemal was saying, that you don't need to be a good laparoscopic surgeon in order to become a robotic surgeon. Sir, I'm a living example before you. I'm 50 or 56, did only laparoscopic cholecystectomy, and then moved on to do robotic procedure. We have one robotic by CSR in the Department of Surgery, King George's. We have one NEPP model, and then we have another Da Vinci in King George's Medical University, Lucknow. So we are kind of plush with this robotic program. Dr. Bhandari took a lot of load off me when he talked about how to do it, when to do it, what training needs. So I will just concentrate on the topic itself here. And I will talk about mesenteric cysts are relatively, you know, that they are the maladies of the childhood, not the adult men. Etiology is still certain, and developmental anomalies of the mesenteric lymphatics that fail to communicate with the remainder of the lymphatic system and the venous system make the most accepted theory. And we have a synonymous lesion in the neck, which is known as cystic hygroma. Once again, it is a disease of the childhood. And mesenteric cysts are commonly found in the mesenteric small bowel, especially in the ileum or root of the small bowel mesentery. But it can happen anywhere, and we will show you where we found that. The spectrum of mesenteric presentations can vary from asymptomatic abdominal mass. Obviously, when they are small, the masses don't have symptoms. They are non-specific symptoms. There's also a school of thought which says that the mesenteric cysts, which are small, we can leave them and observe closely. My master used to say it to be a masterly inactivity. And when the mass enlarges during observation, it becomes symptomatic or is associated with complications such as infection, hemorrhage, volvulus, torsion, and sometimes bowel dissection is mandated because of this reason. So there are two types, chylomlymphatic and enterogenous. These are the most common type, but the differential diagnosis will also include dermoid and the urachal cyst, but the locations are not these common, not that common when we were talking about chylomlymphatic cysts. The chylomlymphatic cysts have clear lymph or chyle content and also have a blood supply separate from the adjacent intestine. And when we, the another type of cyst is enterogenous cyst, which is said to happen because of the origin from the duodenal, the bowel diverticulum. It sits on the, it shares the same vascular supply as that of a bowel. So that is why we need to be careful and use the help of imaging if we want to save the bowel. Otherwise, sometimes if we do enucleation of the cyst, the bowel could be endangered and we may have to do a repeat surgery. Otherwise, it is a very safe and simple surgery. The radiology is important, and when we do radiology, we understand what kind of cyst it is, what is the content, what is the differential diagnosis, what is the relation to the important structures, and we have to remove whole of the cyst, otherwise complications, lymphatic chyluria and something like this happens, and there is a recurrence of the disease also. This is the CT scan of the same patient. It was referred to us from outside. And then this is the MRI, which is CT, you could say, is hyper intense, hyper attenuation, and this MRI is T2 weightage image is hyper intense images, and it is sitting closely with the hepatic fracture of the colon. Here we allowed the patient, we took the patient the first case and we allowed him to till 3 and 4 a.m. in the morning, and he was allowed 6 hours of fasting, and bowel preparation was done just to, not needed always, but we did it for the sake of, you know, it decompresses the bowel and makes our job easier and prevents distension of the bowel. And the ceftriaxone of third genesiphilus was used. This is the common port position. The cyst was approximately, we made a port position of roughly 10 to 15 centimeters from the cyst, which was right hypochondrium under the cage. And we took 1 centimeter away from the lean alba so as to prevent the formation of hernia. And the two other working ports were R1 and R2 were 10 centimeters above and below the initial camera port. Right. So this is the location of the cyst, which we after made on the paper, and we, as usual, when you do a surgery, whether it is laparoscopic or open laparoscopic or robotic, we do a thorough exploratory laparotomy. Here in the case was we done with robotic, and we try to ascertain the cyst. We moved it around. There was no attachment with the bowel, because if the bowel was attached, would have made our job difficult and could have endangered the supply of the bowel, or it could have increased the magnitude of the surgery. And here, in case it was attached to the retroperitoneum, the mesenteric, it was peritoneal fascia of the right hepatic flexure of colon was just above it. So this is the video. Can we play the video, please? So it is a simple procedure, but you can see it is laterally attached to the abdominal wall. There was the peritoneum of the parietal peritoneum was there, and it made our job easier. The important is that we have to keep the bowel away from there all the time. So we can very easily see that there is stomach, there is colon, and we have retracted laterally. But with the help of the robotic system, I think it would make my life a lot easier. These are all my debut procedures. I have done approximately more than 30 procedures. These are all my debut procedures. So in order to improve your control of the robotic system, all procedures have to be simple and easy. So these are one of the few debut procedures which I took. And this is the Salicut which we've been provided by the robotic, by the SSi Mantra. It worked very fine. So we aspirated the whole, because it is a benign disease, we took a sample of it just for the sake of pathology, and then we went on to do aspirated and removed it. And then it was, once again, we just filled it with water to show you the size of the cyst, approximately 14 centimeter. And then there was no spillage in the abdominal cavity. The ports were removed and the incision was closed. Post-operative period was uneventful. Patient was allowed soft diet on the same day, 6 hours after surgery. We removed the Foley's on POD1 and POD2 patient was discharged. To conclude, I would say the robotic-assisted laparoscopic technique improves the surgical outcome as it provides a three-dimensional stereoscopic view with 10 times magnification of the operating field. Clearer surgical vision compared to the open surgery. There was no handling of the bowel, so patient could be allowed only in the same day, and he would discharge the very next day. Increased degrees of motion mimic human dexterity and improves control of the movements. Better cosmosis of the patient, and it reduces post-operative morbidity with a shorter post-operative hospital stay. These are the few procedures which I have done. These are not the complete list. And robotic and the debut procedures like cholecystectomy, TAP, robotic appendectomy with cystogastroscopy, and robotic rectopexy. I'm still learning and still a student and moving on to do bigger things if it would be. This is KGMU, on the upper left side, right side of a new department building coming up, and in fellow side, I'm doing surgery on the console of the SSi Mantra. Thank you very much for kind attention. Thank you.
Thank you, Dr. Sonkar. Thank you very much.
Thank you, Professor Sonkar. Good job. Just one quick question, that you are using a laparoscopic instrument also, that we saw the ultrasonic device, so that is done by the assistant, am I right?
Say again, sir?
No, we saw the robotic instrument, but in addition to that, we are seeing that ultrasonic device.
So that was Salicut, Mantra Salicut. It is their harmonic is known as Salicut. We use that. In R1 we use Salicut.
It was a robotic instrument, that's what
you said. All robotic instruments. Okay. Only for the aspiration, we made a new port and aspirated. Right. Otherwise, we do what you're saying we would normally do for gallbladder, sometimes any other surgery.
So why did you say robotic, laparoscopic assisted robotic surgery?
No, it is the robotic mesenteric program.
That's what your conclusion slide said, yeah.
No.
All right. Thank you, Professor Sonkar. Thank you so much.
Oh. That's
robotic assisted laparoscopy.
It is robot assisted mesenteric surgery.
No, so Dr. Deep, let me tell you. So there's nothing robotic surgery, nothing like robotic surgery. Whatever you are doing is not robotic surgery. This is one of the board. Usually it used to happen for in United States. They used to say if you do a pure, because it's a laparoscopic procedure. You're using a laparoscopic.
Yes,
you are doing a pneumoinsufflation. So a lot of the coding word they call robotic assisted laparoscopic, whatever surgery you are doing.
Yeah.
So this is another debate going on. So the European literature and in the American literature also, in the Neurology Society, they have come up with the term robotic assisted laparoscopic, whatever procedure you are doing. So perhaps that might be the reason you are.
Principle remain the same. Only thing is that instead of laparoscopy, you are
Because
using a robotic
theoretically,
system.
laparoscopy, what is a laparoscopy? Like we started with you insufflate the abdomen with the virus needle or whatever you are doing
Everything
and
is
doing
same,
CO2, so that
It's
is
probably discussion for another time.
Thank you. Thank you very much. Thank you
Thank
for
you
the
very
attention.
Thank you. Can we go to the Rajiv Gandhi, please?
डिस्टेंस तो काफी दिया है सर बट वो थोड़ा पेशेंट छोटा है
Dr. Rawal, we are back with you. If you want to, you are going too fast. Actually, we are not able to follow you.
I'm not too fast, sir.
Yeah. So can you just summarize what you have done so far before we go to the next presentation?
Okay.
Yeah.
I've taken lateral pedicle on both sides, including ureter.
Right.
And cut the posterior part of the vagina.
Right.
And I have made incision at the anterior part of the vagina also.
Right.
So what I'm going to do, I'm going to dissect the vagina and bladder from here. And that will be up to the urethra, that maybe as far as I can go.
Right.
And after that, I'll drop the bladder and remove the bladder after taking the Foley's catheter inside my operating field, so
Right.
that I can remove whole of the urethra from here only.
Excellent.
That is my plan. So this is the anterior dissection. So I'll
Thank you. Thank you so much. No, you are going
Thank
too
you,
fast
sir.
for us.
No.
We'll come back to you. All right, we can go
Okay,
for
sir.
next
Thank you.
presentation.
Thank you, sir, for moderating it so smoothly. Thank you. And taking it further into advanced oncological procedures, we now move on to the next session titled Robotic CMET 3 Right Hemicolectomy for Colon Cancer. To help us navigate this, we have with us Dr. Deep Goyal from BLK Max Super Speciality Hospital. He's already here. I request you, sir, to kindly take over.
Do you have a pointer?
I'll just ask for it.
Okay. Anyway.
Can we get the pointer here, please?
Good afternoon, everybody. And at the outset, let me thank SSi Mantra for having me here. And it's a very proud moment for me today having Dr. Hemal on the stage. And he's the one who really inspired us to do laparoscopy early in 1993 when I was doing my post-graduation. He was already doing advanced laparoscopic procedures at AIIMS. And I was very fortunate to have some discussion with him at that point of time. And that really helped us understand where we are going. So today I'm going to talk about the complete mesocolic excision for right colon cancer. As we know that whenever we talk about cancer surgery, the oncological principles take a front seat, rest everything takes a back seat. So taking that into account, I will just tell you what I am talking about. So standard right hemicolectomy, what we do there, we only remove pericolic and intermediate nodes. We sometimes leave the apical or central lymph node. There is no mandate to remove the embryological plane envelope. That often leaves the mesenteric nodes behind. And there is no standardized vascular ligation level. And in right-sided colon cancer, there is a higher skip or central node metastasis than left side. So what I'm trying to say, if you do not take the complete envelope of the lymph nodes, then you are likely to leave some lymph nodes behind. And even if your lymph nodes which you have removed are negative, does not mean the lymph node which you have left behind may not harbor disease. So you can have skip lesions. And if you see on the right side, the stage 3 colon cancer patients can have an apical lymph node metastasis in around 8 to 9% of cases, and around 1.5 to 5.5% of cases there is a risk of N3 nodal metastasis, ranging from T2 tumor to T4B tumor. And adjusted hazard risk ratio for cancer-specific mortality with apical lymph node being positive or metastasis is around 2.2%, 2.2 times than the normal. So what is CME-D3? There are 4 pillars. One, that you need to do the dissection in the embryological planes. You need to ligate the vessel at their origin. You need to do D3 lymphadenectomy, and you need to resect optimal bowel length. When we say optimal bowel length, sometimes in colon cancer, we say 5 centimeter this side, 5 centimeter that side. But now we know from this publication that some mucosal spread of the lymph nodes in colon cancer can be up to 10 centimeter. So we need to remove 10 centimeters on each side to say that it is oncologically safe. And this is how, another thing which surgeons, we should learn, that today our surgery is being monitored by pathologist. The kind of specimen we take out after, cancer surgery can be assessed by pathologist, and they can tell you what kind of surgery you have done. And if repeatedly your surgery is not bringing out specimen which are oncologically optimum, then you need to go back to drawing board and you need to retrain yourself. So friends, these are not the times where only surgeons knows what he is doing. In fact, everybody knows what it is done. So when you do CME D3, let's look at some of the literature, what it is saying. Nodal recurrence in conventional colectomy is around 9.5%. In CME D3 is almost 0%. Safety profile, there is a lot of halla gulla that if you do surgery where you do D3 lymphadenectomy, it is dangerous, there are more complications, but there is no literature to support that. There are a lot of trials happening. Some of the trials are showing superiority, but at this point of time, there are a lot of trials which are ongoing, which are recruiting, like Recon trial, like Cole trial, which will tell us long-term results of oncological survival. So controversies and current debate is whether we are able to give better oncological outcomes. And from Tata Memorial Center, there is a result trial came out which says that you are able to remove more lymph nodes by doing CME D3, but at this point of time, it has not translated into better survival. But as I said, there is a lot of trials which are on the underway, and the long-term results are awaited. As far as guidelines is concerned, from USA, they say selective D3 only, but retrieve suspicious nodes outside the standard field. And Japanese guideline says D3 is recommended based on preoperative imaging and depth of tumor invasion. If you have a T3, T4 lesion, it is better to do a CME D3. This is a video on SSi Mantra. This is a infracolic approach where we make a window at the ileocolic pedicle, and we are going into the retroperitoneum, lifting the ascending colon in between the embryological planes, between the deep peritoneal fascia and mesocolic fascia. As you see here, sharp dissection. The one which I am lifting up in my left hand is the mesocolic fascia, and the one which I am leaving behind is the Gerota's fascia. That's the line of Todd which you can see. You can see here, and that you can see here is the duodenum on the right side. This is not unfortunately working. I will show you with the cursor. This is the duodenum here. This is the pancreas here. So our idea is to, that's the duodenum, that's the pancreas. And then we are lifting the ileocolic mesentery, and that's the transverse colon mesentery to taut the fascia there. And you see the superior mesenteric vein here. And then you skirt the peritoneum over the mesentery here to expose the mesocolic vein. The idea is to take away all the lymph nodes from the ventral surface onto the lateral edge of the superior mesenteric vein. And that is where most of the complications are reported. If you are not careful, you are likely to cause injury, which is going to be a disaster. And then you can see the superior mesenteric vein and artery lying together. So our aim is to take all the fibrofatty tissue in an envelope away from the mesocolic vein and artery and gradually go from caudal to cranial side. Look at the beauty of the left hand, how it is dissecting the fat over the great vessels. You see here? And no bipolar or high energy source is being used. Only monopolar coagulation and cutting current is doing. That's the ileocolic pedicle. And completely taking at the root dissecting there with all the lymph nodes. And you saw a gush of blood. That's probably one of the small tributaries, but I'm giving pressure with my scissor to make sure that it doesn't bleed. And then I'm asking my colleague to clip it. So everything is under control. And once you clip that, you cut it. That's the first artery and the vessel you have taken. Once you have done that, you move, again as I said, next pedicle would be right colic, then middle colic right branch. And that's the right colic artery being taken. That's the duodenum. As you see, we are pushing it down. So we have taken all the fatty tissue from the ventral surface of the head of the pancreas. That's the right branch of the middle colic most likely. Yeah, you can see that. That's the middle colic artery. So since this lesion is in the ascending colon, I'm going to do just a conventional right hemicolectomy in the form of taking the right branch of the middle colic artery. That's the pancreas again. So all the fibrofatty tissue along with the lymph node has been taken away. And the fourth arm is giving traction. And we are taking the right branch of the middle colic artery. You see the duodenum is completely dissected there. Anterior surface of the head of the pancreas dissected. And that's the assistant port lifting the mesocolon. That's the middle colic artery as you see there. And now from the top of the duodenum we are trying to enter the lesser sac. This is all the fibrofatty envelope along the vessel being taken en bloc. And as I am just repeating that only monopolar scissor is being used as the energy source, and the left hand is a bipolar. No next generation energy source is being used. It is not required in most of the surgeries. When we started our robotic surgery, we were little skeptical because from laparoscopy where we use all the time next generation energy sources, how we will do it. But gradually we have realized that in, I would say, more than 90% times it is not required. Once we have done that, now we are trying to come to the terminal ileum towards the area where we will fire the stapler. We are trying to delineate the small bowel where we will use the stapler. You can see clearly that there is a demarcation line there, but we will in a minute confirm it with the ICG just for the demonstration purpose. You can see this. ICG is clearly showing that this is the demarcation line. In fact, it is slightly away from where we had marked. So we were able to save little more bowel. And then moving towards the colon, transverse colon side, again to see where there are some lateral attachments remaining at the hepatic flexure which are being dissected, and then trying to devascularize the area where we are going to fire the stapler in the right side of the transverse colon, and you can very well see the demarcation line here. You can see the difference with naked eye, so there is no point doing an ICG here. And once you fire the stapler, you normally use the blue cartridge and then take side to side stay suture to do ileocolic anastomosis. And stapler being fired. And always see inside that there is no bleeding on the staple line, and then running sutures by proline 30 in 2 layers to close the enterotomy. We always close it in 2 layers, not necessarily. A lot of people will do it in single layer. I know Mohit and Mehak, they do it in single layer. And then close the mesentery. We always believe in closing the mesentery, even if it's wider one. And then keep it drain. So that was the video. So every surgeon doing a right colectomy makes a choice to remove the disease completely or to leave some behind. So CME D3 leads to superior specimen quality, better survival, in shorter series, nodal recurrence is lesser, its safety profile is comparable, and RELEC trial is important trial which is demonstrating that there is a superiority, and there are other trials which are going on. CME D3 is not just a better operation, it is the right operation in our opinion and in our institution. In all cases, we practice that. And I invite you all for this Mother of All conferences in 2027 in Delhi, where robotics and AI is the main theme. Thank you very much.
Thank you, Deep. Great talk, excellent talk.
Thank you, sir.
Do you do a concept of sentinel lymph node biopsy in these cases to begin with, or no?
Not for colon cancer, sir. Right. It's not, at this point of time, it is not the standard of care, and it does not offer any help since you are doing a CME D3.
Right. Yeah, no, because you brilliantly, you have shown the use of indocyanine in green. So that's the reason I was asking for the rectal cancer. Some people, they...
You see, today with the imaging being so good, sir, but yes, if you talk theoretically, in rectal cancer, you can use it to find out if there is a lateral lymph nodes which are involved. Right. But today with MR quality is so good that we know it preoperatively that if lateral nodes are involved. So practically it is not required, but yeah, some people can.
And ileocolic anastomosis, you are using a stapler, then you are doing a freehand suturing. So why not that part also with the stapler? Just
of course, we can do it. It's just, I think, saving 15 minutes, nothing else, sir. But yeah, it can be done, sir, easily, and you can save cost.
Right.
Absolutely.
Right. Brilliant demonstration, brilliant.
Thank you, sir.
All right, thank you so much. Yes, please go ahead.
Thank you, Doctor, for sharing your expertise in such a critical domain. Ladies and gentlemen, the next session is on fertility-enhancing robotic surgery. With that, we move into a space where robotic surgery goes beyond technique and truly transforms possibilities for patients. Let's now welcome on stage Dr. Priya Bhave Chittawar from Her Health Hospital, Bhopal, for this session.
Priya, can you hold on for a second? Just we go to Rajiv Gandhi and come back to you. Sure. Can we go back to Rajiv Gandhi Cancer Institute? Dr. Rawal, can you hear us?
Yes, sir. Loud and clear.
Again, you are very ahead the curve. So please tell us what you have done.
So I have dropped the bladder down.
Right.
After dissecting the anterior vaginal wall, I have dropped the bladder down. And from the right side, I have dissected up to the urethra. There's the anterior vaginal wall here. There's, up to the urethra. I'm going on other side, and I'll try to make a hole in the vagina and take the catheter from here inside my field, so that I can remove urethra in toto with the bladder.
Yeah. So one thing I observed what you are doing very nicely. I mean, you tried to dissect the anterior part of the vagina behind the bladder before going to go to the... So that was mainly reason to get a more length of the vagina, or what was the concept behind it?
No, enough, not very big length, but enough length so that I can, right now, since the bladder is mobilized, sir, now you can see, if it is not mobilized, I have to cut the vagina otherwise.
Right.
So once you mobilize the vagina down, the bladder is nicely in your hand, and you can go laterally without cutting the endopelvic fascia, just remain onto the, towards the specimen, onto the endopelvic fascia. Because if I go here, there will be a lot of bleeding also.
Right.
So that is one reason, and secondly, everything is in front of me, so I'm not I have to cut vagina again or anything.
Yeah,
so
because we do the what you are demonstrating, because that's more the vagina sparing surgery, so you can reconstruct the vagina. So that's the
absolutely.
Yeah, that is the main reason.
Yes, sir.
Very nice.
Another thing that we can do genital sparing surgery easily, but especially in the young female nowadays it is being done. And if you are planning neobladder, so is it better to save the vagina, whole of the vagina?
Right, it gives support to the anastomosis.
Yes,
so Sudhir, after this, what's your plan?
After that, I will remove the specimen and node, and then Ashish will take over from there to do open ileal conduit.
Perfect.
We will not be doing conduit intracorporeal.
Perfect.
Yes, sir.
Thank you so much. Thank you. Very
great. Thank you, sir. Thank you.
Excellent demonstration. Thank you so much.
Thank you, sir. Thank you.
Sorry, Dr. Bhave. Now you can go out, please.
Thank you. Very good evening to all. It's such a pleasure to be here. It's been less than a year since we acquired the Mantra 3 robot. And we have already performed more than 125 surgeries, and most of them, because I have been a fertility specialist, most of them have been fertility enhancing robotic surgery. Now, infertility is something which is growing at a very rapid phase, and unfortunately, somewhere we have started equating infertility with IVF. So even patients feel that if they have infertility, the way to go is IUI or IVF, and many of us, even as gynecs, neglect this very important part of pelvic reconstruction, of uterine factor infertility. And as a unit, we have always felt that unless your reproductive surgery is very good, you cannot really expect great outcomes when it comes to your IVF or IUI cycles also. The big advantage that I have found in robotic surgery, we have been operating laparoscopically for a very long time. But I think, as you saw in today's recanalization, the wristed instrument, that has been a game changer when it comes to recanalization. This is one surgery where I think it definitely scores in a big way over laparoscopic recanalization. And the second one, which we are eventually understanding, is fibroids which are very near the endometrial cavity, and also the posterior parametrium and the endometriosis cases. Now, the largest number of cases in our series has been myomectomies. We all know that if a patient harbors a fibroid which is submucous, that always needs to come out, and more often than not it is removed hysteroscopically. But if it's a type 3 fibroid, that is, it is straddling the endometrium, straddling the myometrium, touching the endometrium, these are challenging fibroids because sometimes they may not have a serosal indentation and you may not even be able to figure out where they are. Especially in fibroids where the endometrium is close to the fibroid. So for example, this fibroid, it's just a 3 centimeter fibroid, but what I'm cutting and what I'm leaving behind is actually the endometrial cavity. In laparoscopy also, I would have been able to spare the endometrial cavity, but the kind of magnification and the joy of operating contralaterally what we get in robotic surgery, I do not find it in the laparoscopic surgery. So the bulge that you see down is nothing but the endometrial cavity, and it is completely intact. Definitely sometimes we do end up opening the cavity, and it is said that it does not make a difference, but I would like to believe that the endomyometrial junction, which is very crucial to embryo implantation, we cannot imagine that you open the endometrium, you suture it back, and the results will be the same. So this is one case where we can beautifully appreciate that a type 3 fibroid removed completely without opening the endometrial cavity. Another example of finding beautiful planes, I think gynecology is mainly about finding the right planes. And before I did this surgery, I debated with myself that for such a small dermoid cyst, should I even be docking the robot and taking the whole trouble? But as we went along, you can see that we are able to figure out a very beautiful plane in robotic surgery. And I think the magic is in the monopolar scissors. This is the instrument that I have grown to love. We have hardly ever used monopolar energy when we were doing laparoscopies. But this scissor is such a versatile instrument. I don't even like to call it the scissor. It is like a paintbrush. It gives you such a beautiful delineation. Fiber by fiber, you are able to open and reach the right plane. And there you go, the entire dermoid cyst, we have removed it intact without opening. Now we have done close to 30 dermoid cystectomies, and almost in all cases we have been able to remove the dermoid cyst without spillage. Again, of course, spillage is not a big deal. Even if you end up spilling some of the contents, it doesn't matter. But I would like to believe that when you get into the right plane and you don't do too much of suction or irrigation, it actually improves the patient outcome. This patient went home the very same day. Robotic tubal recanalization we have just seen, although it was not a very ideal case, but I think I will just skip through this because, or maybe rush through it a little. In this patient, you can see that the anastomosis was a little distal. So the proximal end was longer. And in such cases, there is a little bit of luminal disparity, which we try to avoid by doing something called as fish mouthing. So we try to make the smaller lumen bigger by fish mouthing it. Once we excise, I think the game changer suture is the one at 7 o'clock and 3 o'clock. These were extremely difficult to take by straight stick laparoscopic instruments, especially because all of us, most of us gynecs are ipsilateral surgeons when it comes to laparoscopy. Robotics gives us that advantage of sitting comfortably and doing a contralateral surgery. I always like to take 2 layers. So after taking mucosal sutures, seromuscular sutures, and the end where you see dye coming out nicely from the fallopian tubes. Now, other than these few surgeries, there are many situations where we actually need to remove the tubes. And more, as we see cases of hydrosalpinx, we see cases of pelvic inflammatory disease. Many times, tubal surgery has to be for removing the tube. But the problem is that when you remove the tube, which is in a tubo-ovarian mass, sometimes you might end up jeopardizing the blood flow to the ovary. And so, more often than not, whenever we see a patient with hydrosalpinx, we often post her for a robotic surgery, because in case the tube is repairable, we are able to do a robotic salpingostomy. In case it is not repairable, we are able to preserve the ovarian blood flow accurately and remove only the damaged fallopian tube and not the ovarian blood supply. Now this is a fibroid which was really low down, totally under the urinary bladder. When we started operating fibroids, we found that it was very difficult for us to, this is a video of interval cerclage. Some patients have recurrent second trimester miscarriages and they go for vaginal cerclage, that is McDonald or Shirodkar cerclage. But in cases where they have failed a Shirodkar or a vaginal cerclage, we have to do a laparoscopic or a robotic cerclage. Now this can be done in pregnancy and this can be done as an interval procedure. This is a patient where we are doing an interval cerclage robotically. It's not a very difficult procedure, but I think very soon we will try and attempt a robotic cerclage during pregnancy also. I think with the centralization and with the contralateral approach, we'll be able to replicate these exact steps in pregnancy as well. So the steps are very simple. We open and we make a avascular window in the broad ligament, insert the tape and tie it at the level of internal os. This tape can be removed during delivery, or sometimes we like to leave this tape as such. So the trick is that you don't pierce the wall of the uterus, you just go medial to the uterine vessels without piercing the pedicle. Now this Marcelline tape is tied anteriorly. After this, the patient tries to conceive and this tape stays through pregnancy. Now, does it make a very big difference? Well, I would not say it does, but yes, at least in laparoscopic tubal recanalizations it does. This is an interesting case, not exactly a fertility sparing surgery, but this patient had a cornual ectopic pregnancy. She came to us, a very vascular, very angry looking mass, and the tube was distal to it. Now in this case, there is no way we can preserve the tube, and we injected vasopressin, and the whole point is finding the right plane. You see that I am not in the right plane now. Once I go in the right plane, again figuring out the right plane is very easy with the judicious use of the monopolar scissors. The entire vascular mass will pop out, and we will be suturing the cornu. So there you can see the entire pregnancy and the placental tissue. If we are in the right plane, it all comes out very well. There is no point in preserving this tube because the pregnancy is in the intramural part of the fallopian tube. So the salpingectomy has to be done for this patient. And then we suture this cornu. Patient has to avoid pregnancy for 3 months and then she can plan for a pregnancy again. Here, because we were in the right plane, we have removed very little of the myometrium. So I have taken you through a short bird's eye view of what all is possible with robotic surgery when it comes to fertility enhancing surgeries. I think more and more we are adapting to it. The way ahead would be to integrate robotic surgery in a better way with hysteroscopy. Because hysteroscopy and laparoscopy go together. With modular arms, we sometimes find it difficult to have the vaginal assistant do the manipulation. And these are, I think, all the experiences which we will get when we sit together and do more and more cases. Thank you so much for a patient here.
Thank you, Dr. Priya, for such a lovely disposition. So, how your practice has changed before robotic surgery and after robotic surgery, and how do you convince your patient that do robotically, say, cyst, ovarian cyst?
Sir, in 3 ways I think my practice has changed. One is I think I am more energetic in my OPD because I sit and operate. And as we age, I think it is a real thing, surgery fatigue. So people who are only surgeons who have very less OPD, it's fine that they stand and operate. But for me, this comfort of sitting and operating is a game changer. So I am more patient with my patients in the OPD. That is one. Second is that it's very easy to convince the patient for a robotic surgery if you are not charging too much for that. Because the patients also understand that in fertility sparing surgeries, the uterus has to be spared, the ovarian tissue has to be spared, so they understand it very well. So we have no difficulty in convincing them.
Makes sense.
Yes.
Thank you very much, Dr.
Thank you, sir.
Thank you
Thank
very much.
Thank you, ma'am. Your expertise have added immense value to our learning. At this juncture, we take a broader perspective on how robotics is becoming indispensable in general surgery. Our next session is robotics in general surgery, a necessity. Please join me in welcoming Dr. Sachin Mittal from Marengo Asia, Faridabad. Come on, ladies and gentlemen, can we please keep the claps rolling? Everyone, please.
Thank you very much. So, very good evening to all. I want to thank Dr. Sudhir, Dr. Vishwa, and whole SSi team for inviting me here. So, I will be speaking on a broader topic, why robotics is becoming a necessity sort of thing in general surgery. So, surgery has always evolved with technology, whether it is open surgery to laparoscopic and now to robotic surgery. So every transition is always questioned, maybe resisted also, but it eventually becomes standard of care when benefits are proven. So in robotics in general surgery, is it a necessity? It is not about replacing the surgeon skills. It is about magnifying it. In surgery, precision is not a luxury, it is a necessity. So the precision or the finesse we get with the robot in general surgery, one day it will become necessity in this field. So the real question is, in which situations does robotic technology change surgical quality, safety, and reproducibility? So the question shouldn't be, is robotic better than laparoscopy? So our debates, are much centered on comparing laparoscopy with robotic. So the point is not to compare the two technology. They are, have their role at their places. So we should be seeing robotic as an individual perspective. So evaluation of surgery, it's natural progression from once it was an open surgery, then to laparoscopic surgery, and now to robotic surgery. So robotic surgery, it basically represents technological refinement, not the replacement. It is not to replace anything here. It is making its own place. So similar resistance was seen when laparoscopy was introduced, but you can see in many procedures, laparoscopy is now the standard of care. So what are the advantages of robotic, which is making it a necessity, like, 3D vision with 10 to 15 time magnifications. You can see structures with, great clarity, and you can improve your dissection, and which lead to lesser blood loss. So wristed instruments are there, which are having 7 degrees of freedom. So you can rotate instruments in, in the difficult directions, which are not possible with laparoscopy. So it leads to tremor filtration and the motion scaling. Your movements are filtered when they reaches to the tissue. So better suturing in confined spaces, pelvis, hiatus, and deep abdomen. And it is, of very much clinical relevance in complex hernias where, you have to do a fine dissection. There are a lot of adhesions, and with robotic vision and, wristed instruments, you can do a very good adhesiolysis. In recurrent hernias, in redo surgeries, and very important in obesities. In obesity, with longer robotic instruments, your torque is very less and you can perform surgery in a very easy way. So the robotic is not a cosmetic upgrade. It basically lead to a fine dissection, which is, due to its, 3D vision, better intracorporeal suturing, and in hernias, better mesh fixation. You can completely avoid putting a tacker in inguinal or ventral hernias, and a very good Callouts dissection in difficult cholecystectomy with the 3D vision, with the wristed instrument. You can do a very good dissection in difficult cholecystectomy with ICG also. So in complex anatomy, millimeters matter. Better ergonomics for surgeon. Robotics, there is a reduced surgeon fatigue, a better posture, longer carrier sustainability. It is very important in high volume centers where there is a fatigue when you do back-to-back cases. It is a seated console surgery, neutral wrist position, and a reduced shoulder strain. So burnout reduction is an underrated advantage which robotic surgery gives. So what are the expanding indications in general surgery specifically? So gallbladder surgery is one of the most common general surgery everybody performs. So in difficult cholecystectomy with ICG, it is you can do a very good dissection. You can identify CBD in difficult cases, and in acute cases with 3D vision, the vision is very good, and you can do a very good dissection. In obese patient with longer instruments, you get a better reach. If there are adhesions, you can do a very good adhesiolysis with the robotic instruments. And enhanced visualization helps in achieving the critical view of safety more consistently. In hernia surgeries, in complex hernias, robotic TAPP, ETAP, RS, and AWR procedures, you can do a good dissections in retrorectus plane. In TARP procedures, bilateral inguinal hernia, you can create a midline flap, and you can put mesh with sutures. There is no need. You can do a very good suturing in deep pelvic planes. So robotic, it improves ergonomics and suture accuracy in deeper planes. It helps in extensive retrorectal dissection, and it can help in suturing the posterior rectus sheath and larger mesh placements with precision. So in gastrointestinal surgeries, and specifically in rectal surgeries in narrow pelvis, the articulation with robotic instruments improves mesorectal dissection. Fine nerve preservation becomes easier. In bariatric surgery, in the obese, super obese patients with longer robotic instruments, there is a very less torque. With robotic, eventually there is no torque. You can perform surgery sitting on the console, and good oncological dissections. So robotic surgeries, it improves outcomes in complex procedures, and particularly advantageous for technically demanding procedures such as rectal resection, hernia repair, hepatobiliary surgeries. Enhanced visualization and precision 3D high definition magnification, and wristed instruments with 7 degrees of freedom. Reduction in post-operative complications. Studies have reported that robotic assisted approaches, they result in fewer surgical site infection and reduced pain. Ergonomic benefits and growing role in emergency surgeries like appendectomies. What is the real question is the cost debate. There is a high initial capital cost, there is a maintenance cost, there is disposable cost. But the advantage which we get with robotic surgery, like shorter stay, it reduces indirect cost, faster return to work, and fewer complications, they reduce the long-term cost. So with the initial investment, now with time, I think more and more cheaper versions will come with cost-wise, and they will eventually reduce cost much in future. So robotic surgery is not about doing the same operation in a more expensive way. It is about doing difficult operations in a safer and more reproducible way. So learning curve with robotic, it is having a shorter learning curve for complex suturing than laparoscopy. There is a structured training module and there is a simulation-based training. So it may standardize complex surgeries across surgeons. Patient perception and demand, it is very important. There is nowadays increasing awareness among patients regarding robotic surgery. They come to OPD asking about the robotic option. So you have to explain to the patient, if your hospital is having a robotic system, you have to explain that what advantage robotics can give to those patients. So it is now seen as an advanced and safer option. So technology adoption is partially patient driven. So what is the future perspective? Like AI integration with the integration of, CT scans and other things into the robotic systems, future surgery will become more image guided. So it will lead to cost reduction with competition and wider acceptability in India. So with telesurgery, it may improve reach of specialized surgical care to remote area and better training and supervision. Now we are seeing launch of drone today, like Vimana, SSi Vimana. So these sort of innovations will, may help the reach of robotic surgery to the remote area. So just as laparoscopy became standard over time, robotic is moving from luxury to necessity, especially in tertiary care setting. So some examples from literature. So this is a study from University of California, Los Angeles. So they study the trend of robotic assisted procedures for general surgery. So you can see in this slide that the common robotic general surgical procedures, cholecystectomies, ventral hernia and inguinal hernia, they have gradually increased in number from 2015 to 2019. So in this study, they have made this conclusion in colorectal surgery, robotic has led to reduced blood loss. In hernia repairs, there is a lower recurrence rate, reduced complication. In cholecystectomy, there is a reduced conversion rate. And esophagectomy, there is a shorter stay by 3 days. So this is another study from UK. It is a 10-year procedure-specific analysis by Neil Donald. So in this study, you can see the robotic procedures, they have almost become 8 to 10 times in number from 2015 to 2024, especially in cholecystectomy, 42 procedures in 2015 and 2082 procedures in 2024. Same is with hernia and other procedures, robotic general surgical procedure. So with time, as the advances are coming in robotic surgery, as more and more surgeons are trained, numbers are increasing day by day. So this is a growth trend and forecast for robotic surgery market size and share analysis. So robotic surgery market is estimated to be valued at $12.8 billion in 2025 and is expected to reach $38.22 billion by 2032. And general surgical segment is expected to capture 32.5% of global robotic surgery market share in 2025. So robotic surgery is now having the maximum share of robotic market in the world. So this is from AIMS. AIMS has installed robotic system for last 1 year, and this was a statement from aims that it has lead to 30% reduction, 30% shorter hospital stay, 50% reduction in post-operative pain and other benefits. So they have seen, they have said that complex procedures with unmatched precision and accuracy, while also ensuring that the institution keep pace with global advancement in medical technology. So Indian context where we stand, India is witnessing a rapid growth in tertiary robotic centers, increasing patient awareness and insurance acceptance in metro cities. Now, in my practice also, I have seen now more and more insurance companies, they are giving approvals for robotic general surgery. It was very difficult to get a approval for robotic surgery for cholecystectomy, but now as more and more procedures are being performed, insurances, most of the insurances now they are giving approvals for robotic procedures. So in high volume urban hospitals, robotic is transitioning from optional to expected. So this was the real world performance of SSi Mantra robotic system. It was a multi-centric, multi-specialty study evaluating its safety and surgical application by Dr. Somsekhar SP and other renowned surgeons. So in this study also, the maximum share was of general surgery, 1499, 40.6% of the procedures, general surgical procedures, they are performed with SSi Mantra during the tenure of this study. So this distribution highlights the adoption of robotic surgery across multiple specialties, with general surgery and urology contributing the highest procedural volume. So robotics in general surgery is not about replacing surgeons, it is about enhancing surgical precision, improving outcomes and future proofing surgical practice. The real question is not whether the robotic is expensive, but whether avoiding technological progress will cost us more in the long run. Thank you so much.
That was a wonderful presentation, Dr. Sachin. I just want to say that robots have really transformed the way the surgeons think about performing any surgery. And I think as far as the cost factor is there, it is definitely going to decrease in next 5 or 10 years or so. And it does make a difference. And I think who wouldn't want to do a robotic surgery if it is available?
Yeah, exactly.
It does take a toll on your, laparoscopic surgery. It does take a toll on your health. You have a lot of shoulder strain. That is the biggest difference which I have felt since the time I have started doing thoracic surgery. I'm a thoracic oncosurgeon. So last 4 months I have started doing, I'm super excited about performing robotic surgery every time I do it. So I think it does have its advantages, and it has really transformed the way we are thinking.
And SSi also is having a big role in, helping reaching the robotic surgery to the masses.
Absolutely.
Thank you so much.
Wonderful. Thank you. I think we can move on to the next presentation.
Sure, and thank you, Doctor, for that powerful and thought-provoking insight. And now, we move into a highly complex and advanced surgical procedure, showcasing the true potential of robotic precision with Dr. Senthil Kumar Ganesan from Silverline Hospital, Trichy, as he delivers a session on robotic esophagectomy with 3-field lymphadenectomy. Ladies and gentlemen, Dr. Senthil Kumar Ganesan.
And I thank Dr. Sudhir sir and the entire SSi team for this Mantra system and for this great opportunity. I am from a two-tier city, Trichy in Tamil Nadu, and greetings from Silverline Hospital. So this is a straightforward case, a 44-year-old female who had dysphagia. She was evaluated, a growth in the distal esophagus, a squamous cell carcinoma. And as a routine, we give neoadjuvant chemoradiation by cross protocol. And post NACTRT, she was evaluated, had some minimal residual disease and planned for surgery. And this is our usual position. The patient will be in a prone position. And we always give a single lumen ventilation only. We never put a double lumen tube. And these are the classical port placements. The camera will be the first one to introduce, that is at the apex of the scapula, at the 7th intercostal space. Then we place the R1 and the R2 in the corresponding space, such as the R1 will be on the 3rd or the 4th space, and R2 at the 9th intercostal space. We have one more port placement for applying the clips. Usually it will be a 10 mm port. So most of the crowd here will be knowing about the OR setup of the Mantra system. And this is the port placement. There I have placed a 5 mm trocar for the clip, but that will be changed to a 10 mm. So the patient is in a typical completely prone position. So the initial part of the surgery will be releasing the inferior pulmonary ligament. The general instruments used are the hook or the scissor on the right hand, and the left hand has the fenestrated bipolar. There you can see the pleura is incised, and all the periesophageal nodes will be taken along with the specimen. Lower down, you can see the pericardium there. With this single lumen intubation and with the pneumo, the right lung will be usually collapsed. And there you can see the right bronchus, and these are the tissues just dissecting from the right bronchus. And the dissection will be continued, taking the subcarinal node along with that one until we reach the left bronchus. So the entire infrahilar dissection, that is the anterior part of the dissection, is being done now. The dissection goes up to the left side. Because of the post-chemo radiation, there will be minimal additions, and sometimes edema also, which will help you in the dissection. There you can see the pericardium there. And inferiorly, this is over the diaphragm, where the dissection is continued till we see the crus, we see the muscle. So the entire fiber fatty tissue will be taken along with the specimen. So that is a left crus muscle you have seen. Now again, the same anterior dissection is continued more towards the left side. That bulge there you see, that is the inferior pulmonary vein. So all pre-op planning will be done properly. So any infiltration into the pericardium or the pulmonary vein should be dealt cautiously. And there you can see the left bronchus inferiorly. And once the entire infraesophageal dissection is done, now we come to the supraesophageal portion. There the pleura is incised, the esophagus vein is clipped, and the upper part of the esophagus, just for the exposure, I just fix it to the chest wall. So that is how we fix it so that we get a good exposure. Now we just turn our concentrate towards the right recurrent laryngeal nerve dissection. For that, we just trace the entire right vagus. There you can see that is a brachiocephalic trunk there, and that is a right vagus, and all the nodal tissue along the right vagus will be taken. And as the dissection continues superiorly, you will be identifying the right recurrent laryngeal nerve. Here, caution should be the dissection should be very, precise. And whenever you are using the monopolar or the bipolar, so that is a recurrent laryngeal nerve, right recurrent laryngeal nerve. So whenever we are using the monopolar or the bipolar, care should be taken, should be very well away from the nerve. So that is a right recurrent laryngeal nerve. You can see small nodes popping out there, and all these will be taken. And the superior dissection almost will be continued up to the neck. Even we can see the inferior thyroid artery from here. So that is the end of the right RLN dissection. There you can see the thoracic duct. In our Mantra system, we don't have the ICG facility, but I think the Mantra has come up with a newer system with ICG, so that when we use ICG, we'll be able to identify the thoracic duct nicely. So that is, there you can see the carina, and some portion of the infracardial node is being taken. And there, that is the arch of aorta. So that is the arch of aorta. So in this case, actually, there was some injury, so we have removed the thoracic duct. So one thing which is very important is the recurrent laryngeal node dissection, that is in the supraesophageal portion. So this is in another case how we are going to dissect the right and the left RLN. That's what I am showing here. So here again, the vagus is identified, the pleura is dissected, opened up. That is a trachea there. You can see this is a vagus. So remember, on the right side, the recurrent laryngeal nerve will be arching the brachiocephalic trunk, but on the left side, it will be arching the arch of aorta. So these are all the nodal tissues close to the vagus nerve. In this case, we had some difficulty because the lung was a little bit popping out. The lung was not completely collapsed, and there you can see the right recurrent laryngeal nerve when the assistant compresses the lung. So that white structure there is a trachea, that lateral part of the trachea. Here you can see the nerve just, it will be popping out. So that is a nerve. That is a right recurrent laryngeal nerve. Only short burst of current should be delivered. Ideal thing will be to use two bipolars, or we can use a scissor. The hook will be a little bit larger than the scissor, so it may not be ideal in this part of the dissection. So this is a right RLN dissection. Usually it will be placed in a glove bag and it will be removed. So this is a left recurrent laryngeal nerve area, and you can see the nerve there. And remember, since it is arching the aorta, the left RLN will have a very long course, and there is high chance of injury only to the left recurrent laryngeal nerve. And here again, there will be nodes anterior to the nerve and also posterior to the nerve. So that white structure is a left recurrent laryngeal nerve. Whenever we are very close, try to avoid using any energy source and use just a scissor to cut the nodal tissue or the fibrofatty tissues. So this part is the one where Robo has got an excellent advantage compared to laparoscopy. When we are doing lap, this is the most difficult thing to achieve, doing a complete left RLN dissection. So here Robo has got the excellent advantage. So that you see the entire left RLN has been dissected. And now coming here, this is the arch of aorta, and this is where the nerve will be looping around the arch, and the nodal pocket which I am now dissecting is the aortopulmonary window. So deep to that will be the pulmonary artery here. So the one which is being compressed is the left bronchus, and the suction is compressing on the left bronchus. So you can see a node there, and deep to that white structure, that white structure is a pulmonary artery. So this is a aortopulmonary or the Bogdalex group of node, and you can see the nerve arching around the aorta. That's a left recurrent laryngeal. So meticulous dissection is feasible, better accomplished with the Robo. So that is the entire pocket of the aortopulmonary group of nodes. So that's a nerve which is being completely released. So these are the remaining bit of fibrofatty tissue on the arch of aorta. So that is also taken. That completes the entire dissection. So just I'm showing only the thoracic part of the three-field lymphadenectomy. Then we'll be completing the abdomen part either by lap or robotic thing. See the pulmonary artery, arch of aorta, the entire course of the right RLN, the suction is pressing on the trachea. Thank you. And almost we have completed 50 major onco procedures. Thank you. Thank you.
Yeah. Dr. Senthil, I must congratulate you for, mastering the technique of recurrent dissection in Mantra system. That was a tremendous job, and you rightly mentioned that robot does make a difference in supracarinal, especially the supracarinal dissection, which is the most important part of esophageectomy, I think. That was an amazing demonstration.
Thank you, sir.
Congratulations.
Thank you, sir, for your insights.
Can we connect to the OR, please, just for 2 minutes, just to get an update on Sudhir, sir? Hello, Sudhir, sir? Can you hear us? Okay, it's okay. I think we should continue with the talks. Yeah.
Ladies and gentlemen, we would just like to inform you that buses are waiting outside the Bharat Mandapam main gate for the faculty dinner that you have to be going to after the conference is over.
Thank you, Akriti. We now invite Dr. Kushal Agarwal from Aster CMI, Bangalore, to please take the stage and present his session on robotic thyroidectomy based on the SSi Mantra.
Good evening, everybody. I am Dr. Kushal Agarwal. I bring warm greetings from Bangalore. The topic for today for me is robotic thyroidectomy on SSi Mantra robot, tips and tricks. We've been talking about robot at various places, and one mad surgeon has come who's talking about robotic thyroids. So I'll tell you the reason why. Why robotic assisted thyroidectomies is because of this reason. So the concept came from Korea, where people are very much concerned about their cosmesis. Then why should Indians be left behind? Indians are also very concerned about their cosmesis. And the concern was always about young females, but I have seen a lot of young men also being worried about their neck scars. So this is the reason why robotic assisted thyroidectomy, the only advantage of thyroidectomy being done with robot being cosmesis. So if you start a robotic thyroidectomy, you have to finish a robotic thyroidectomy. You cannot start a robotic thyroidectomy and then end up giving a neck scar to the patient, then the whole point is lost and is not justified. So whatever be it, you have to be extremely thorough with the robotic approach and be very, very meticulous about when it comes to robotic thyroidectomy, very confident about it, and always there should be the opening and giving a neck scar should be the last resort. So open thyroidectomy, before I embark on robotic thyroidectomy, I must say open thyroidectomy remains the gold standard but leaves a visible scar. So it is still the gold standard. Robotic thyroidectomy should only be done when the patient and the doctor both are confident in that procedure. As a surgeon, as a robotic surgeon, I never endorse it. I always do it when the patients ask for it. So remote access techniques were developed to improve cosmesis. Baba thyroidectomy, which I personally prefer, offers symmetrical access and a surgical view similar to open surgeries, enabling safe identification of vital structures. SSi Mantra enables advanced remote access thyroid surgery. This presentation provides standardized procedural roadmap. So these are the various approaches to thyroidectomy. I'll be talking about robotic assisted thyroidectomy in particular. There are various access to remote access thyroidectomy. Mind it is never minimal access thyroidectomy. It is always remote access thyroidectomy. In fact, a remote access thyroidectomy is always a maximally invasive thyroidectomy. So calling it minimal access thyroidectomy is wrong. It is always remote access thyroidectomies. There are various approaches: the chest breast approach, bilateral axillobreast approach, transaxillary, retroauricular. The essential difference being either a gasless approach or with CO2. The gasless approach being the transaxillary and the retroauricular or the facelift approach. With CO2, it can be a transoral or toativa or some transoral retrorabial approach, very, very morbid. And robot-assisted bilateral axilloinsufflation thyroidectomy or a Baba RT approach, or as we call it, rabbit approach. So rabbit approach is the only approach that allows 4 instruments to be used at the same time, which provides great convenience at the time of surgery. I'll also show you the video why it provides great convenience. Baba RT has got good exposure, does not require an expensive retractor, generally the chunks retractor required for a gasless approach, which is not needed with Baba RT. 4 instruments can be used at the same time. So the procedural roadmap will include, the preoperative workup remains standard, be it robotic, be it open, it is neck USG, FNAC, laryngoscopy. Patient counseling about remote access scar. There is always a scar in the breast and the axilla. If there is no scar in the neck, there is definitely a scar in the axilla. So we have to tell the patient about it. It is not scarless surgery. If at all it is a transoral, then it can be a scarless surgery. Anesthesia protocol remains the same as to what it is. Preoperative practice, prophylactic antibiotics. I generally do not use a intraoperative routine use of intraoperative nerve monitoring. I don't do. And catheterization generally is not required. This is the operating room configuration, which I try to follow if I'm doing it at my institute. If I'm demonstrating it somewhere, then it is kind of difficult to follow, but this is how it is best done. Patient has to be placed supine with reverse Trendelenburg. SSi Mantra cards come from the head end. Vision cards to be positioned opposite to the primary surgeon. And anesthesia team has to be at the foot end. Patient positioning as shown in the photograph. Patient is supine. Both arms are abducted to 90 degrees and secured. Axillary region and anterior chest is completely exposed. And careful padding. I want to reiterate the padding at the shoulder joint, which is very important, which we have to make sure whenever we do this surgery. Port placement. I tend to use the assistant port. Now there are various surgeons who avoid using assistant port. My personal preference is to use it. The camera port is a 10 mm port with the right periolar. Instrument ports in the left side on the R1 and R2, I always use a bariatric port since they are longer length, so you don't have to create a lot of space. A bariatric port helps. And then retraction arm on the R3 and an assistant port which is triangulated between the R3 and the camera. Docking is sequential, done from the head end of the patient. Camera arm docked first, followed by other instrument. Head end positioning, robotic cards are docked from the patient's head to optimize operative access. And so the instruments are usual instruments at a 10 mm 3D endoscope camera. The energy devices are monopolar curved scissor and fenestrated bipolar. There is some use of using ultrasonic energy device, which I will be showing in my video, where it is actually helpful. And ancillary instrument used by the assistant are essentially the regular instruments. The surgical steps suggested are we initially create a space from a 1.5 centimeter incision in the right pectoralis major muscle, pectoralis major border. Then flap is created and pressure is generally kept at 8 mm of Hg. I prefer to use a air seal if somebody is always advisable for any surface surgeries you do. If you have a air seal, please use it. It makes a huge difference since it has got a suction evacuation in it. Then thyroid exposure is done by dividing the midline raphe, division of the middle thyroid vein. I tend to use an approach which is known as the bottom-up mobilization, where I start the surgery from the bottom of the thyroid gland. I take the individual branches of the inferior thyroid artery. I expose the RLN, dissect the tubercle of Zuckerkandl, preserve the parathyroids, and then last I go to the superior pole. So it's basically you lift the thyroid gland from below upwards. So this is the video. As you can see, there's a surgical space created as shown. These will be my port positions. A 1.5 centimeter incision is given at the right lateral border of the pectoralis major muscle. You can see I'm creating, the initial part of the space is created by open technique, prefer to use a headlight. And then you place either 2 or 3 ports on the right side. The rest of the space I prefer to create using ultrasonic scalpel as it maintains a bloodless field. Adequate space is created. We should always, I know the thyroid gland can be only a 2 centimeter gland, but still do not shy away from creating a significant amount of space so that all your robotic arms can work without any clashing. Then after you have exposed the opposite pectoralis major and sternomastoid muscle adequately, you place the rest of the 2 ports. The pressure is maintained at 8 mm of Hg, like I said. The docking is done from the head end. And then this is how the internal picture looks. This is as good as doing open surgery because I've created a significant good amount of space. The surgery is essentially same as we do in any open surgery. The midline raphe is open. This is where the third arm of the robot helps. You can see it is maintaining traction and helping me expose the strap muscles properly. You continue to dissect under the strap muscle, exposing the thyroid gland. Gentle traction of the thyroid gland will allow you to expose the middle thyroid vein, which you can easily bipolarize and divide. As you cut the middle thyroid vein, you can medialize the thyroid gland more, and this is where I start the bottom-up approach, where I will expose the parathyroid glands. I will expose the recurrent laryngeal nerve first and take the individual branches of the inferior thyroid artery, dissect the tubercle of Zuckerkandl, and last I would take the superior pole of the thyroid gland, where I will be dividing the superior thyroid artery. A simple monopolar and bipolar instruments are more than enough. Sometimes you need ultrasonic scalpel, and I'll show you in the next video where it is actually required. Then you divide the suspensory ligament of Berry. As soon as you divide the suspensory ligament of Berry, the whole right lobe of thyroid glands completely detaches from the trachea, and you dissect the right thyroid lobe, right lobe of the thyroid gland and the isthmus from the trachea, avoiding thermal injury to the trachea. After you have done that, you will start with the left lobe of the thyroid gland. No change in the position of the robot, no change in the position of the patient, no change in the position of the instrument. Surgery. This is one place I just wanted to demonstrate the use of ultrasonic scalpel, and that's why I used it. But I could have easily done it with a monopolar or a bipolar device. Then again, same on the left lobe, I will be doing a bottom-up mobilization where I will start from the inferior pole of the thyroid gland first, dividing, bipolarizing and dividing individual branches of the inferior thyroid artery, and essentially just lifting the thyroid gland from below and taking the superior pole of the thyroid gland last. So here again, I will continue to dissect close to the thyroid gland, taking individual branches of the inferior thyroid artery, then dissecting in the left tracheoesophageal groove, exposing the left recurrent laryngeal nerve, preserving all the critical structure. I think I can fast forward this. So here you can see I am taking the superior pole of the left lobe of thyroid gland last. I am taking the left superior thyroid artery last, and then completely mobilizing the gland. And then the gland is placed in a bag and retrieved from the right axilla, 1.5 centimeter incision. I tend to place either some Surgicel powder or a Surgicel in the thyroid bed, and whenever I have not divided the strap muscle, I always approximate them using a V-lock stitch. This is the post-operative picture. So this particular case I wanted to show, this is a case which I had demonstrated when I had gone to Rajahmundry to do one thyroid case. The reason I'm showing this case is because this was a thyroid gland which was around 7 centimeter in size. So the idea to show this is it's not just less than 4 centimeter thyroid lobes which you can dissect, even larger thyroid glands you can do it. The one trick here is if you see a large thyroid lobe, do not shy away from dividing the strap muscles. See here I'm dividing the strap muscles to gain exposure to the thyroid lobe. Now as you can see, the thyroid gland was so huge that it was actually stretching and compressing the internal jugular vein. So this is where the robot actually helped. The endo-wristed instrument, the sharp scissor where I can do dissection close to the internal jugular vein, exposing the middle thyroid vein, the IJV. And here, this is one case where actually ultrasonic scalpel really helps, because you cannot clip those vessels. You can take it with bipolar, but you're not very confident as you're taking it very close to the internal jugular vein. So ultrasonic scalpel really helps. Then the surgery, as you can see the internal jugular vein being carefully preserved. And then essentially the surgery is same. I'll again do the bottom-up mobilization, where I will go and dissect the inferior pole of the thyroid gland first, exposing the inferior thyroid artery and the recurrent laryngeal nerve. Carefully I will dissect and preserve the left recurrent laryngeal nerve. The right recurrent laryngeal nerve. And last, I would go in the superior pole, where I'll expose the superior parathyroid glands. And here again, as I dissect, I'll see a huge, because of the massive size of the thyroid gland, you can see a huge superior thyroid artery pulsating right in front of you. So taking it only with bipolar, you're a little worried. So again, if you have the facility of Celicut ultrasonic device with you, you can always take it. This was the final specimen. So in our experience, we have done 32 robotic thyroidectomies using the Mantra robot. Most have been females. Most have been total thyroidectomies. Our total operative time have been somewhere around 190 to 200 minutes. There have been no intraoperative recurrent laryngeal nerve injuries. Parathyroid gland injuries have been 2. Thankfully, till now, we do not have any patient getting a permanent vocal cord palsy or a permanent hypoparathyroidism. Our results got published in the Indian Journal of Surgical Oncology in March 2026. where we also compared our results with the other robotic Baba series is done on Da Vinci robot and also endoscopic Baba, and results are quite comparable. So in conclusion, it's a safe and feasible approach. Enhanced precision with the robotic 3D visualization helps. It's a versatile procedure. In case you are doing a lobectomy or a total thyroidectomy with or without a central compartment clearance or even a lateral compartment clearance, you can do it with this approach. SSi Mantra with the indigenous open console multi-cart robotic platform enhances ergonomics, flexibility and potential accessibility. And this presentation shows a standardized roadmap. This is a team at Aster Hospital. I thank you all for patient listening. Good evening, everybody.
Yeah, please. Can we give them the mic, please? Yeah.
So we are beginners and we had two issues. One, this numbness in this area for lasting for around 3 to 6 months.
Okay.
And second is, in one case, there was an injury to the internal memory perforator and there was a lot of bleeding. We had to struggle a lot. How do you manage those?
So injury to internal memory perforator is less likely because you don't go in that area when you make the space for
Maybe we were
thyroidectomy.
misdirected.
So I think you went a little more below than what it was actually intended to, because I personally, sternal notch is my landmark whenever I make space. So I don't try to go below the sternal notch, and sternal notch I try to stay, whenever I'm making the space, I try to stay above the sternal notch. Just a centimeter below the sternal notch is what I make the space. So internal memory vessels, if at all they have to come, they will come way below. They will come in the third and the fourth intercostal space. And injuring the internal memory perforator, because it comes from below, it comes essentially in the intercostal space. I think there was some...
Maybe we were misdirected.
Yeah. Possible. Second doubt being that there was some numbness in the chest area. Yes, that can happen. So what I tend to do is, whenever we are raising the flap, we have to make sure that we are in the skin, the fascia, the deep fascia, we have to preserve it over the skin. Whenever we are making, we have to go under the fascia and let the fascia go above, so that for two reasons. One, because of numbness, and second, post-operatively, if you go above the fascia, there is a lot of stretch the patient will complain.
Bruises,
A lot of fibrosis the patient will complain. The patient will say, you've done a robotic surgery, but I can't move my neck. So this problem happens if you miss that plane. You have to make sure that the fascia always stays above and you are under the fascia when you're creating the space.
Can I have another question?
Yeah.
Yes.
Actually, in the region of that ligament of Berry where the nerve meets the thyroid, in that area, we are a bit skeptical about using the energy device. Very often we use the ultrasonic device.
In fact, I'm more confident with the sharp scissor instrument. Ultrasonic is where you actually grab and cut and it vibrates. So a sharp instrument is always better.
That is always best, but it tends to bleed.
Actually, if you want to add something?
No.
Yeah.
Next
So
question.
I think you are right. There is always a possibility of bleeding, but what I tend to do is I take individual branches of inferior thyroid artery close to the thyroid gland and essentially devascularize that area before I dissect the tubercle of Zucker candle.
Kushal, that was beautiful. Quickly, just what's your strategy to save the parathyroids?
Parathyroids, sir, the basic strategy is you have to stay close to the thyroid gland. That's the basic strategy. I mean, there are various triangles which have been mentioned in the
ICG
theory.
or something like that?
ICG, essentially, it has been shown that without using the ICG also, the parathyroid glands are autofluorescent. But with my experience of around 50 cases, both on Da Vinci and as well as SSi Mantra robot, I have never seen a parathyroid gland showing any form of autofluorescence. The only role of ICG where it comes in, where you are worried about the vascularity of the parathyroid gland. You have preserved the parathyroid gland, but you are worried about the vascularity. So in that case, you can give ICG and check for the vascularity. Any doubt you have of the vascularity, you can always transfer it to the sternomastoid or something. That can be done. But I think ICG for preservation of parathyroid glands, I don't think it helps.
I have seen you have ligated the vessel just above the parathyroid after crossing the parathyroid.
Yes, so I make sure that I
have
preserve
seen
the
that.
branch going to the parathyroids and then tend to preserve it, yeah.
Dr. Kushal, one suggestion, not a question.
Yeah.
So when you started your slide, you said that if we do a robotic thyroidectomy, it's purely for a cosmetic purpose. At the end of the slide, you said 5 advantages of robotic thyroidectomy. So I would like to suggest or appeal you that don't put a slide there only for cost purchase. Nowadays, if we say it's more precise, the way you have shown a 7 centimeter thyroid doing with a BABA approach, even with the open method also, it's not easy to do a 7 centimeter going below the clavicle, saving the parathyroid. The vision and all those things are very good. It can be advocated. If you are able to do, you should do a robotic thyroidectomy. It's not that it's only purely for cosmetic purpose.
See, I am an oncologist and I look at oncology perspective, and considering oncological aspect of see, one is of course cosmesis, which is there's no doubt about it. When it comes to oncology,
the robotic thing in head and neck, especially the thyroid and the neck and all those things, was related to the cosmesis initially when we started doing it. But nowadays we have got a clear advantage or equivalent to the open method. The only thing that we consider right now that whether we are trained with the robotic thing exclusively or not, and the second is the cost. That comes in way. Otherwise, it's just an instrument. Doing it openly or with the robotic method, I think robot always got an upper hand. Regarding the clarity, regarding the precision, regarding the preserving the structures, I prefer more of that.
See, when it comes to patient asking me about robotic, I say it is no less when it comes to the final results, because similar results with the open surgery, similar, in fact, 46% of transient hypoparathyroidism is there even with open surgery.
Gentlemen, I'm sorry, I need to intervene. Our next speaker has already joined us. So I need to cut
We'll have a discussion later.
No, just I want to say that don't start your slide with that. Really a request.
Thank you so much.
Nothing
Thank you,
else.
Kushan.
Okay, so
that was a wonderful presentation. Yeah.
Thank you.
Thank you so much, Dr. Agarwal. And I'm sure we have a lot many questions, but you may meet him directly and we will address your questions as well. Ladies and gentlemen, we are down to our final session of this evening. And before that, once again, I would like to inform you the buses that are to take you to the faculty dinner are at the main gate of Bharat Mandapam. We also have a volunteer right here. You may follow his directions and he will lead you to those buses. And we are now joined virtually by Dr. Ivan Rizal-Sini from Bunda Hospital, Jakarta, Indonesia. We welcome him on the screen as he takes us through his session on complex gynecological robotic cases.
Thank you. First of all, thank you very much for the committee and Dr. Sudhir for inviting me to give a talk, and my biggest apology for not able to attend in person. Allow me to share my slides. Just checking whether you can see my slide. Can you see my slide there, sir?
I think we're not able to see, sir. Excuse me? Yeah, slides not visible.
I'll try it again.
Yeah.
Can you see this one?
No, sir.
Okay, let me just. Okay, can you see one now?
No. Yeah, okay.
Can you see my slide here now? You can't.
No, sir. So if you could just stop sharing and then share again. Just do the entire process again.
Okay, let me try again, yeah? Should be able to see it now. Can you?
No. Yeah.
Okay.
No.
Hang on. let
Still
me
not
try
able to
again.
see, sir.
Mhm.
Yeah, it's visible now. Yeah.
It's visible now? Very good.
Yeah.
Very good. So you can see it now
Yeah.
how it is?
Yeah. Yes, sir.
Fantastic. Okay, so again, thank you very much. I just wanted to share my background. My name is Ivan Sini. I started my journey as a robotic surgeon back in 2011, and then that was the first time I was really quite amazed by the development of the robotic platform. And I was the first Indonesian. I'm the first Indonesian robotic surgeon that I've done over 600 cases up until now, and mostly are benign complex gynae procedures. And I'm one of the founding members of Asia Society of Gynae Robotic Surgeon, and this is currently the society is being led by Dr. Ruma Shinta, who has been really quite instrumental in really helping the society to blossom. And I have been using the Da Vinci platform for nearly a decade. And then we started our first introduction with SSi Mantra last year. And we've done over 100 cases since the beginning of our inception. And currently, we are mostly working in gynae cases. And as I mentioned before, that complex gynae procedures are something that we see quite frequently in Indonesia, as we sort of see many patients who leave the procedures under the very last stage, and that obviously would have an increased surgical complexity that would increase the duration of the surgery and risk of conversion and risk of complication. And this obviously an opportunity for us as a surgeon to be able to utilize robotic has been shown by various paper that we would benefit by having the precision and the dexterity and also the ability to maneuver. And the studies that have been looked at, unfortunately, is relatively quite sparse. However, we see that retrospective study that I have sort of shown here, that showing that the similar perioperative outcomes been seen. However, we have a shorter operative time with slightly less blood loss. And of course, understandably, the conversion to laparotomy is higher in the conventional laparoscopic group. And if you look at the complex TLH, we see the systematic review and meta-analysis showing a similar sort of outcomes. But in conclusion, the robotic assisted laparoscopic surgery versus conventional laparoscopic surgery in complex surgery showing to be quite promising, although it's warranted for us to evaluate further evidence to put on the table. But definitely, from the surgeon's viewpoint, we see that many of the surgeons today are showing so much confidence in performing surgery with minimal invasive approach. And this is obviously a challenge for many of the surgeons that we're dealing with obese patients, as an example, how we want to tackle complex cases with minimal invasive in obese patients. And obviously, this is one of the opportunities that we can have with robotic surgery. So just the last, I think the points that I want to make is when we do surgery, of course, we apply the same principle with any kind of surgery. That is, we need to prepare the patients properly by having a good diagnostic imaging, and then the team a multidisciplinary approach, and of course, the readiness of blood and the DVT prevention and ICU preparation. And other risk that is associated with the procedure needs to be counseled properly to the patients. But we definitely would need to equip ourselves with a very knowledgeable sort of technique of how we tackle the anatomy, especially with deep pelvic anatomy. We will be dealing, quite frequently in cases with severe endometriosis. As we know, endometriosis is frequently found in reproductive women, and it affects quite significantly the quality of life. And as I mentioned to you before about the diagnostic importance, how we see that robotic surgery in severe endometriosis has a potential role. However, the data that we have currently is still ongoing. We still have some way to go for us to really identify the benefit. But one data that I can show you, which is really quite exciting, is that the comparison of ovarian preservation with robotic seems to be better. This is one of the Korean groups that has already identified the benefit. So how about the excision of the endometriosis? We definitely have a much more relaxed attitude towards the surgery, and I think that's one of the advantage we have. And that applies to conditions such as adenomyosis and myoma. For this, I normally would, approach the procedure with fairly cautious, and often would be using high port placement of Li Huang, and that will allow us to have a far better view of the surgical plane. As you are seeing here, I'm just giving you two examples. So, the procedures here is basically, large fibroid. So it's only just about 350 grams, but still decent enough. If you put the angle in the wrong position, then you find yourself quite challenging to remove the tissue. And this procedure is relatively quite simple, straightforward, by identifying the right plane and avoiding the tissue of the endometrial cavity, and we can easily remove the fibroid. And of course, we want to ensure that the suture is placed properly to close the front wall. And again, straightforward, with managing the inner layer and also the outer layer of the front plane. And this is something that we can do in any size of fiber. So, taking you through another example of a patient with complex hysterectomy. So this is a case with the severe adhesion. If you can see, the uterine wall was rather attached to the interior wall of the abdomen. And typically the approach, obviously, we want to identify the anatomy and put everything in place. As what we're seeing here, from the medial, we are able to identify the structure of the uterus. The good thing about the minimal invasive with robot or laparoscopy, we can see the cavitation effect helps us to identify the right plane. And if we, find difficult access, typically what we want to do, obviously, to find the right plane from the congenital adhesion from the left angle of the pelvis, and we should be able to identify the ureters. So what we're seeing here is the ovaries separated, and we'll be able to see the retroperitoneal space. And very important when you do a complex surgery, you always want to evaluate the ureter and the other important structures. And if you want to preserve the nerves, and it's very easy for us to identify because of the 3D sort of visualization that the robotic platform this does. And continuously, we see here, once we already separate all the adhesion away, then definitely the similar process and approach that you would normally do with your TLH, providing that we've identified the anterior and the posterior adhesion. So you can see the cup over there. And this patient had two cesarean section. Was relatively quite easy for us to peel the bladder pillar down and ensuring the bladder as well, pushed down below. I don't normally use any sort of identification or ACG to visualize the ureteric tissue and bladder, because it's very clear that we can see where the structure is here. But the most important thing is once we already have the plane peeled down, we want to ensure that we clean as much as the tissue, especially with the leftover endometriosis, to be removed. Of course, when we identify the plane properly, we can do the colpotomy, circulating surrounding the cardinal ligaments and also the surround of the colpotomy ring. And this will allow us to remove the uterus from down below, and ball closure. I normally use 2O vital or barbed suture. But generally speaking, the procedure is relatively quite straightforward as long as we know the anatomy well and we're quite confident with the surrounding structure. And I think very important that robotic surgery has helped me at the very least, putting my confidence a lot in terms of identifying the difficult, sort of structure, and obviously putting us in much better sleep, if you like, because of the patients have less likely to, result in complications. So, Mr. Chairman, I think that would conclude my talk, and hopefully this can give you a better understanding about what we can do with robotic platform. And thanks for Mantra. This is obviously the one breakthrough that the Indian company has already bring to the robotic world. Thank you.
Yeah, thank you, Dr. Sini. That was a wonderful presentation. Do we have any questions? Okay. Thanks, Dr. Sini. I think we'll be concluding today's session, and I think we had a wonderful entire day seeing various extended uses of SSi Mantra and the ever-increasing role of this wonderful robotic system. So I think we would conclude the session today. Thank you so much.
Thank you, sir, for your patience, for staying with us throughout the day, and for conducting it so smoothly. And ladies and gentlemen, thank you for being such a wonderful audience. And we would like to once again express our gratitude to all our moderators, chairperson, all our panelists who are here to share their knowledge and reflective knowledge. Thank you so much once again. We hope to see you tomorrow. Let's carry this momentum into the day too. We'll see you tomorrow at 9 a.m. Thank you so much. Can you please give us like 2 minutes? Both of us are 5 minutes. Photo लेने दो बस, वो हटाओ मत कुछ. Just 5 minutes. Oh, with the. Can you please give me this?
Sanjay?
I want it with this.
Sanjay?